Hey guys, this is Jeff, the Metis Surveyor, and I call myself that because I'm a Metis Indian. I live in Western Canada where I've done most of my work, and I am retired now, not because I want to be, but because I am on AISH, it is the Assured Income for the Severely Handicapped. But before I get too much into any of that, I just wanted to bring you to my video, and the title of the video was Surveying Supercars and Call of Duty. First thing is surveying, and the surveying, I have over 15 years of experience in the surveying field in legal construction or seismic in Western Canada, and those are the three main points of surveying in my region, and perhaps probably in yours too. All right, guys, I have not surveyed for 15 years straight. It is probably a compilation of about 7 or 8 years over that 15-year span. Other than that, I would have been doing some sort of construction related job, or I would have been in those three fields of surveying where I have over 10,000 hours of experience. That is to put it lightly. However, for all you know that are in surveying, if you have over 10,000 hours of experience, you've probably thought about it for like 30 or more hours in your own time. Okay, so you might be wondering, I have a scan pay and go code. I'm going to take it down now, and that is just for anybody that ever wants to donate for learning the information in this video. If you are seeing this video and that code, which I'll take down now because I just want it for the beginning of the video in case you decide to donate. If you do see that code, um, that means this video has been finished and published. All the information is in this video and there won't be any advertisements. Okay, so we can move on from surveying. Basically, I'm gonna guarantee you that in this video you're gonna learn everything you need to know about surveying as it pertains to you in either residential, commercial, or industrial construction, or legal surveying or seismic. And I'm just gonna give you all my tricks and stuff so that you know how to get your survey on track and what you're capable of doing. Okay, so for the part that I like the most, supercars. What does supercars have to do with surveying? Well, if you've read ahead, you already know $1 million supercar that's 1,000 pounds that can put out 1,000 horsepower is worth $1,000 a pound. Why do I say that? Because all the equipment in surveying, if you've bought it in the last 20, 25 years, or even up until recently, depending on the application, you have paid more than the value of a supercar at that price for it. And I think that's a pretty fair example, $1 million car. And I just want to say right there, if you are a surveyor, you should have bought the supercar because you would have been way cooler. And all I can say is if you have a cell phone that has GPS capabilities, you can do most of the jobs that these supercars would be doing, and you have it in your pocket, and it's probably been bought in the last 5 or years less. Okay, what does it have to do with Call of Duty? If you can play Call of Duty, and guys, I say this because if you have fine motor skills, you can operate instruments, and if you have good eyesight, you'll be able to do layout and all these things a lot easier and quicker. It could be for anybody though. If you're hearing impaired or even blind, you could still access this information somehow. I hope somebody can provide it for you and you would know more about surveying, the value of it, and if you can play Call of Duty and you're generally physically fit, you would be able to do field work. And to do this, you would only need two cell phones and some information. The thing to note about cell phones is they are currently valued a little bit less pound for pound than the supercars, so you can see the great discrepancy in how it could be made up for, whether you produce any of these or anything like that, or whether you use them and you have to purchase them. You might be in military, civilian, or municipal role. Our loadout will handle later. It's going to be what we use in the survey, which you can see on the left. Hey guys, and if you are in surveying and you just need to know like a really simple thing you can do to get all your notes done and maybe save time and not ever have to put anything down with pen or pencil in your notes anymore, you guys can just use these two programs. It is MS Notepad and MS Paint, and they are available on anybody's Microsoft program. I also have the recording software for free that I was able to obtain from OBS, and that's how you're getting all this information. However, my mic setup, laptop, and all that wasn't for free. But if you do have a laptop and you do surveying and you can mount it in your truck, you could do all your notes with just these two programs because you can draw better with one and you can write legibly better with one. And if you want, you can open a notepad and just have a talk to text for your notes in it, and you would be able to make all your notes in a small fraction of the time that it would take to do your survey, which would make them easier to review rather than being on the phone constantly, maybe with a supervisor. So those three areas of surveying that I've done: legal, construction, or seismic, in either exploration, like boundary establishment in any way, so it's subdivisions, all that kind of stuff, construction and or construction, residential, commercial, or industrial. If any of these apply to you, you guys might want to watch this video because I'm going to try and put them all in the video. And like I said, if you ever want to make a donation, just refer to the beginning of the video. It is as long as it is, but I'm going to cover a lot of the ways that you could make money or improve your survey on any project you have going right now. Okay, and because I haven't talked about our loadout will be different for each portion of the job, because some applications only need certain equipment and others need others, obviously. So right now I got in there just for a generic loadout, which would be some point in the game, just because we are going to use a pre-World War III like scenario to make our Call of Duty game, and you're going to have to envision it, and it's going to be on the left, the notes that we'll need to make. Which aren't going to be a lot, but I'm going to try and get it through to you. So if you just want to know how I set that notepad up, all I did was go to the view, and I turned on rulers and grid lines, which I could take off now, and the status bar is on. The status bar is going to show us locations in the bottom. You can see on the bottom left how my location changes at the pixel location. But I want to turn those grid lines on so I can see where it changes values. And then I got rulers, so if I am drawing or anything, I can see it being marked on the outside of the page. As you can see, the little red hash marks on the ruler go up and down based on the position of my mouse. Okay, guys, this basically makes this like a AutoCAD program without 3D capabilities, but for handy sketches that you want close to scale, you could use it anytime. I just drew my north arrow in there with just with lines, really quick and dirty, and that's all you really have to do for this. To prove that you can survey, if you can play Call of Duty, and you can use items that are worth more than supercars. So back to that loadout, we're going to primarily have GPSs, lasers, and EDMs. And by EDMs, I mean a combination of either laser etched glass or, tilt sensors combined with lasers and or GPS in order to give us accurate readings. So just to get on with the example, I'm just going to check my recorder here, make sure I'm driving, and I am. So I'm going to take a lot of the information that's on here off, and it's going to continually change, but we'll always have the current subject on the left-hand side and our current drawing and what we're doing. And so by covering all of these things, we're gonna have the description, like I said, in this window on the right hand side, so you can fast forward the video anytime, anywhere you want, and kind of get the subjects that we're talking about. I'll try to stay as on point as I can so that you know you're getting the information you're looking at. And like I said, guys, there is no guarantees in life, and I cannot guarantee you that you can be a surveyor if you could play Call of Duty and you like supercars. But I could probably make some changes just giving this information out, because the information that I have as a surveyor, I've done for legal surveyors, and I've done in all these facets. So I know what can and cannot be used, but I can also tell you where I don't know that. I could get you to the right people to ask the proper people in that would know or need to know based on your location, wherever you are. So it is typically in North America where you see the similar surveying practices. However, there's places all around the world where you would be able to use this. Hey guys, I do want to keep you interested interested and going. So I have changed my drawing and I've changed my information. I'll scroll a bit so you can see all of it. Now there's going to be a lot of things to explain, so I will pause from here and there to get through it, but I just want to keep you excited. And so here's our pre-World War III scenario where we need all surveying technologies that are available to survive. And I have some notes on this page about the information of this mission. And guys, this is all completely fantasy. So I'm just trying to incorporate what I know about surveying and how I'd use it if I had to be in a battle. So because this is kind of an audiobook in this format, I am going to describe a lot of things. that might seem like they're unrealistic, but I'm going to try and make it as realistic as possible. Now, how you do that, and how you apply this to your location in battle or whatever it is, or this left hand side could be your construction site or whatever it is. I'm going to relate it to surveying as I know it, and then how I would use it in kind of a warlike situation. Okay, so the first thing I'm going to fill you in on is, because it's easy to read, I will take the grid lines off for now. But before I do that, just know at the very bottom center of this drawing where it says 0.000 for meters and 0.00 for decimal feet. Okay, that's information we might want to need. In my picture, I have a little red dot. That's supposed to represent one of the operators or personnel's, and their location will always be 000 according to whatever sensor or whatever they have on their body, or wherever you decide to place this. So keep in mind though, if you do have it broadcasting a different location to each different operator, they're going to be based on the helicopter locations. I know this all seems confusing, so I will have to backtrack a bit, but the reason why I mentioned the 0 meters, 0 decimal feet is because that's going to be the scale of these squares, and because they would be drastically different if you use feet or meters. We're just going to assume they're meters, but you could broadcast in feet, and all it would do is make the equivalent of whatever meter to a foot is, which is 0.3048, the conversion for feet to meters or meters to feet. It's going to follow that number. So it's about a third. So 1 foot would be about a third of a meter, right? So you'd need 3 times as many feet. So we're just going to use meters, and then I'm going to shut the grid lines off so it's a little easier to read and digest. Now we can turn the grid lines on anytime, obviously, just to make any distant measuring points. But I do tell you that you guys, we won't have to use math much difficult than what you would have learned by the time you were probably, for me, in like about grade 8 in Canada in the public school system. So don't be worried about doing too much math, because we're gonna get all the CPUs and stuff like that to do the math for us, just like your surveyor's probably currently doing. Okay, just to get into the gist of it, I'm just gonna have my location as the Amazon rainforest. Why? Because that would be a really hard place to set up and have a battle, guys. And there's not really a lot of political conflict in that area for anybody that would be able to do this, I guess, other than maybe areas that there is that I don't know about. Like if you're talking Venezuela or something, I don't know. I just chose the Amazon because it'd be really hard, and you have an easy to get to water source probably anywhere, which you'd likely have in North America or anywhere like that. Um, the other thing is, I'm going to have to walk you through some of the technologies we use later. But before we even get to the Amazon rainforest with our 2 highly loaded out helicopters, which have everything we need to survive for 60 days, resolve a conflict, and be out of there, we're just going to have to assume some things. Okay, first of all, I'm Métis Indian, and that means my ancestral land is in the northern part of the United States primarily, and Canada. However, that would relate me to 2 major groups of people, and that would be Europeans that taught me seignorial mapping systems and how to lay out land so that you have low frontage, low backage, long sidage, which means you have a good available amount of land, but it has water access. And that was kind of how Métis people were able to develop such good land that really European settlers wanted, and were able to, in most cases, swindle them out of, and they could not get it back. So with that being said, we're gonna say that ancestral Métis land will stem all the way through South America, because there was no Panama Canal, and for natives that were occupying all those regions, they were able to get to them by foot, and without the Panama Canal, that would be okay. Now, the fact that you have different languages like Spanish, because of the Spanish influence and conquistadors who, with military influence, were able to rule a large amount of people with a little amount of effort, although it would have been a lot of effort given the technology of the day. We are going to consider the fact that natives from South America and North America are related, because they were attached by land and it was easy to get through that land. But the Amazon rainforest, guys, it's a big and deadly place, and I don't like big snakes and bugs and stuff like that. So in order to get into this, we're going to look at this thing. It's called the deployment portal. And what is the deployment portal? Okay, that's going to be everything I have my soldiers do, and have like basically everything they're going to have to be done and trained in before they get this equipment and move to this location. So now the deployment portal is actually a big circular object that looks like this. And if you guys ever seen them maybe in a department store, it is a body scanning device, and it uses surveying technology and robotic technology. And all it's going to do is you get in it, and then here I'll even draw a little picture of a stick man just so you know how it works. It's going to scan your body, and it's going to tell you how big you are in all locations by using LiDAR basically. So all the fixed access points that are in the machine have a known location. They shoot a laser to your body that gives a distance with very accurate measurement, and then it just creates a 3D view of your person. And now you can be outfitted. Okay. Now my stickman thing's not working out very well, so I'm just going to try and get through this just so you guys aren't absorbing too much. Okay. And he obviously has a head, but in this case, I don't want to take the time to drive ahead. So anyways, it's going to measure your body. And because this is pre-World War III and everything's going crazy, and I'm going to have to be able to make a lot of claims for what I'm going to be able to do in this situation. So just focusing on the pre-portal, I want to control some of the things that happen with my soldiers. So they're going to be body scanned, and then they were given their ASUs. And for those of you who don't know, your ASUs are your Army combat uniforms. So they're going to have to be camouflaged. I'm going to have tons of satellite data from this location, guys. So just as simple as matching a color for your house so that your fencing is the same. We're going to do that with our camouflage so that we have the best camouflage when we get to this area. So let's just say we have a 100-mile zone we are aiming for. We are going to find a camp in that location. So we already know the color of the trees and terrain and everything. So I'm going to have all of my camo match that. And I'm going to have all of my camo fitted to this body scan, probably with just a little bit extra room so everybody feels comfortable. And then it's going to be used as the materials that I want. And the primary material is going to be like a hemp for durability in the ASU, but it's going to also have some breathing holes and stuff like that. Maybe some other comfortable materials. You guys would know about this if you're in the military, but it that'll be for you to decide how you develop and build this. But I'm saying body scan because it uses survey technology, and you can get it to fit snug properly and not have to worry about anything else. So the other things that you would have to look for is like, okay, what happens if somebody gets shot in this uniform, or what happens if somebody gets lit on fire, or anything like that, right? So this personal loadout is also going to solve some problems for you in not having to make so many different uniforms, predicting the size of your applicants. You'll only have to make one, and it'll only change over time, probably with these deployments, depending on how much weight they gain or lose. So you won't have to produce as much to get the same and better uniform in a lot of cases. So, and the other thing that you're going to have, and so for that I will draw the head, guys, and that is you're going to have a helmet that's going to have dual GNS capabilities, and it's going to have a laser mounted on the side or somewhere on it. It's going to have infrared goggles, thermal goggles, and then of course regular sight. And then of course it can be broadcasting one of these meters or decimal feet from your hub locations. Each hub location will be the helicopter you load out on. Okay, so just getting into this, guys, is typical mask you would use in construction or helmet with those technologies where you could virtually produce your site and walk around and view it. However, when you're doing this with a GPS base station, you'll find that it vibrates a little bit and you're not able to say build to the precision that you see in front of you because of your GPS reception quality, whether you're in a building, etc. And so we're going to be able to get rid of that because our helicopters are going to have these capabilities, because they're not going out till we go out. Everybody on these helicopters is going to be an operator of some sort or infantry. And their main role is going to be winning some sort of conflict. Okay. So, Okay, so just sticking to the deployment portal because it is the pre-portal kind of thing we have to go through. So now we got our ASUs, we got our loadout, and so our loadout guys would include any of our automatic weapons that we use in hand-to-hand combat stuff. They would be, in this case, what we decide is the Métis militia to carry. So we're just going to assume you went to the gun show and you were able to load. Um, you were able to get the engineering schematics for your rifle or weapon, and you're able to load dual GNS sensors on it, and you're able to load a laser on it, and you're also to have some sort of tilt sensor technology, etc. And a lot of this stuff you guys have already seen has a lot of you guys have already seen how it's been put together, so that you can basically in some situations shoot over 1,000 yards just by tagging a point with a laser that has all these technologies in it. Or more or less, maybe not the GPS, but the tilt sensors, and some sort of an EDM that can measure azimuths or something like that with a laser distancing device. Okay, so with that portal layout, we got all our stuff that we need, and any of the stuff that's on us will be broadcast from these two helicopters. They are going to be like our homes, guys, because we're going to land them in a permanent spot that will be fixed and it will not move, and it will have our base stations already on it, and we'll be using them before we even hit the ground, because to decide to hit this point, we are going to have the helicopters fly over location, and they will have LiDAR on the bottom, and they are going to have a map location that will be given to them by calculating all of the data they need to determine some of the following things that will make it hospitable for them. And so in LiDAR, the way that they'll be doing that is any flat surface that would be represented as water would be clear. But anywhere light can really go in between trees, and we're going to see this is very densely populated trees. um, you're going to have to find the biggest landing zone that you can clear in a minimum amount of time, that you have fuel and you are able to land. And if you run out of fuel, you're going to have to be able to make fuel and get fuel to leave. But just for initial landing, we're going to just say we have lots of fuel if we have to leave. But in a worst case scenario, you'd have to be able to make it in a suitable amount of time to get out of there. And you'd have to make quite a bit of it. So we'll cover every scenario, but we want to keep it to how surveying ties into it. But that's all we're using so far is going to be surveying technology, and it's going to involve our weapons, our own personnel, and then the helicopters and kind of everything that they do. Okay, guys, there is some things I'm not going to know enough about, and you're going to have to fill in the blanks. And the first one is going to be fuel. I know hydrogen is about 130 octane, which makes it an extremely explosive fuel, and it has to be compressed to store it. So I'm going to say it's a perfect world. We have this technology already, which we do, but it's not highly employed. But I'm going to just venture to say that and also, you got to remember some aviation fluids are different than hydrogen, meaning they are more like a diesel and they're capable of that more afterburning technology, and it's because they have longer molecular forms of fuel, guys. So they burn differently. They have different densities and that. So something you would put perhaps like in an F-18 jet, or even in our case Chinook helicopters, depending on the type of fuel. I'm assuming they have turbines in them. Um, that would be high horsepower turbines, and they would run off more of a jet fuel like thing. So before you get started, let's just get it off the bat. Whatever you're using, my fantasy involves two Chinook helicopters, because I'm going to need them, guys, because they're big enough to carry in my equipment. But if they have to be used in an attack situation, they're versatile that way too. But I'm going to assume they can run off hydrogen. And if they can't already, and you're in the military and you know a way you could make them run off hydrogen, that's going to be essential, because we're going to have water in as a source of fuel, and we're going to have to turn it into hydrogen oxygens, which means, guys, we're going to have to be able to get and make a lot of electricity. So to start that process, we're going to have a generator on site. It's going to be 10 kilowatt or more. I'm thinking 20 kVj will be fine. But everything. And we'll go through this list and kind of what's here and why I got it, because some of it's fun, and like I said, it's fantasy, so you guys can go with whatever you want for your scenario. So like, say we didn't have this river water source that is nearby in our scenario, and we had to land in a desert bowl, and our two helicopters sit stationary. They have all our equipment for 60 days, but we need water. And there is a way that you have maybe a light drilling technology, or shallow drilling technology, which would be something you'd see in seismic maybe. But it would take a considerable amount of your load out in these helicopters, so everything has to be light. And so if you have a technology where you could get water access in the desert by maybe drilling a well, and you don't need something the size of a typical well drilling truck that you would see like in Western Canada where I'm from, and you can employ it, then that would be great. You're going to need a good amount of water. We are going to dig a small reservoir, because wherever our water's coming from, we're going to want a lot of it for um, consumption, fire protection. Any of your medical is going to want clean water supply. So I will describe some of these technologies as we go along, and how you'd have to incorporate what you know. But sticking to surveying, I'm gonna have to get to that. On the helicopters, your personal loadout, like the helmet and guns, etc., and what they can and cannot do, etc. Okay, because we're talking about the technologies that you're going to be able to fly and have available, we're going to also talk about one that's important here, and that is where do I have it listed? Oh, LENR, it's right here, and that means low energy nuclear reaction. For those of you guys who know, that is cold fusion. And what cold fusion basically means is a lot cooler. Okay, in my mind, this is what it means. It is a lot cooler than a hot nuclear reaction, like an atomic bomb or something, but it is still nonetheless a nuclear reaction. But it is a much safer an enclosed system, and it can make a large volume of water 120 degrees continuously for 6 months, basically using like $10 worth of nickel. Okay, so that's going to be the main source of energy for your plant to keep you going for 60 days, is that you can make 120 degree water in a large volume from one of these helicopters. And guys, you don't need a lot of room to do this. And if you're not carrying in the water, then it's going to be even less. So you're just going to immediately put water to that system when you get it, start your nuclear reaction, and boom, you got 120 degree water all the time. And you're going to need it in two places. One in your base, and one for your MRAP, which is going to be the one vehicle that you guys all have to share. And it won't fit all of you all the time, but it is going to be for moving to a faraway location where you maybe need to engage an enemy or something. We're gonna assume that in our location we're gonna be quite a ways away, and it's not gonna be easy to get through all this bush. So you're gonna have to assume maybe that there's a local mining road that's been abandoned or something like that, or forestry road, and you're going to be able to go where you can with a UTV or ATV type vehicle. And it's going to be an MRAP, because if you encounter IEDs, then you're going to be able to let them explode, and you're going to move away from them. So now this involves some really tricky stuff, because you're going to have LENR on your vehicle, which means you're going to have 120 degree water all the time. So anything that surface gets put to is going to be very warm. And so with that, you're going to be able to make steam. Okay. Now, if you also have generators in the wheels for kinetic energy, you will be able to make electricity, and that electricity can be converted into hydrogen and oxygen. If you take the hydrogen and use it as a fuel in a piston-like vehicle, in this case, which would be our MRAP, you're gonna have 130 octane fuel. Okay, and when you have 130 octane fuel, it's gonna be even more explosive when you take the separated oxygen and reintroduce it to it in combustion. And so you're gonna have a very, very high octane fuel, guys, and and you will also be able to put steam to it, and you guys will have a very efficient vehicle. Because just the way this hydrogen oxygen behaves, once it becomes burnt in the combustion chamber, it will create water or water vapor or whatever it is that you want, but it's basically going to be pure water that is going to come out. And so you could keep it enclosed in the system, whether it is reheated or whether it is electrified to be turned into more hydrogen and more oxygen. We're basically saying that if you can incorporate this properly, and I can't say how you have to do it, but if you do, you will be able to operate this vehicle for a very long time just using water. And so if we can get our MRAP and our two helicopters using 130 octane fuel or whatever transport vehicles we use, and we can create that fuel with electricity, then we're going to be able to do everything we need to do for as long as we need to do it using just that main water source as fuel. Okay, guys? So there's different ways to get that started and how you would do it. This is how I would do it. I would have my both helicopters equipped at the router, at least with a GPS sensor, however you would do that. And you would want something like a Google technology where you could take pictures and then orientate those pictures using a laser to that GPS position. Now, once you guys have this whole place mapped, okay, and you do the LiDAR before you land, you may have to deploy several of your soldiers before landing to cut, and you're going to need chainsaws in your loadout to do that. And this is very common in seismic, guys, where people get out to a location and they cut a helipad. And on the helipad, you're going to need a safe place to land. And we're not going to use wood for that because we're going to need something even better. And that's what's going to be hauled under the aircraft on the way there. And that's going to be a large, flat like pontoon like dock like device, just in case you are on a little bit of marsh but you are mostly on solid ground. We're going to assume that all that's programmed into your LiDAR when it finds your location. So the location that it's going to find is worst possible case scenario in the middle of the Amazon jungle. There's critters and stuff everywhere, and you guys got to get in there, cut a helipad, and then you're going to be set up shop there for a long time. So in the programming for your LiDAR, it's going to look for things like this in a helipad. It's going to look for the ground base. Is it solid? Does it tend to be a original ground? Is it up high, a little bit away from your water source? Maybe in the area you want to have a vantage point where you can see everything. It's going to have all that programmed in. And it's going to figure it out by shooting lasers off the bottom of the helicopter in a wide enough pattern that it can cover a lot amount of area, and like any typical LiDAR you'd see in a seismic project in Western Canada. And it's going to tell you the lay of the land, and it'll also tell you the density of those trees and how many you'd have to cut down, within a reasonable calculation, so that if you ran out of fuel and you didn't have a helipad cut yet, you would go down and your crew would be left on the ground with no way to get out. So you're going to have to be able to calculate those things. And if you guys haven't figured it out already, you probably would be able to, because it's gonna come up with the possible solutions for you, and you're gonna go with one, and it's gonna be based on how far you are from your water source, and then also how much high density polyurethane piping you have. Why we're doing high density polyurethane, guys? Because we're going to be sucking water out of the water source, and any of you know that if you go too far or of a too high elevation and you are sucking at no matter what rate or in what capacity, you may boil the water and it just won't come. So if we use a very small diameter, it's going to have small volume and it's not going to cave on us because it's high density polyurethane. You could bury it if you want. That will show scarring of the earth. I would leave it above ground, but you could have that rigged out right away by your crew from your safed out helipad. And what's going to save it out is you're going to have automatic weapons that are correlated to all your survey technology, so they can scan the area. So this is just like if you're playing Call of Duty, guys, and you set up a tripod and there's a big gun on it and it tracks movement using light, infrared, whatever it is. And you're not going to want to be shooting a bunch of animals up, which is why I included this fun part. I have a steer named Jake because I'm going to need something to eat for the first month at least before I have to hunt or fish or whatever it is I got to do. And I got 2 border collie dogs because they're the best. They're the smartest dogs. They're the fastest. I know you guys like the German Shepherds and that for military, and then also the labs and whatnot for policing. Those dogs are fine. I personally have had a border collie mixed with a lab. It was smart, it was fast, and it was an awesome dog. Miss you, buddy. Anyways, You could have mixes, but Border Collie, you guys, is the smartest dog, and I've been through it with surveyors, and I know it. And because I'm in the Métis militia, and these are my homies that I'm going out with, we're gonna have two Border Collie dogs, and they're gonna be trained in hunting and then tracking trails because they will have GPS on them, so they will track all of the trails if they have already not been tracked by the original lidar. And so you're gonna want to know gaming trails and all that kind of stuff because that's where typically your enemies may be moving or not or close to, and you're just going to want to know all that stuff in the area. So I got two Border Collies, and they're going to be outfitted with a GPS probably between the shoulder blades and some sort of a wrap vest, and they're going to be able to do a lot for us, but we'll get into that later, right? So the main thing is that I have to establish to you that if we had LENR and we had this continuous supply of water fuel that we can make because we have electricity, which we have because we have a generator that can also run off it. The key is we're always going to have some sort of heat source that's at 120 degrees, whether it's on this base or at our MRAP where it travels. And that's going to be the lifeline of our project, you guys, is water. And so we're going to leave very little environmental footprint. We're going to try and use diplomacy before we fight, but because it's a Call of Duty scenario, we might do some fighting or have to, or somebody will. And the whole system, as you can see, is designed so that all the people that are involved in it, and they're any age, sex, location that happen to join the Métis militia from either at this point would be ancestrally Canada, the United States. We're going to need two pilots. Everybody's going to need to be a rifleman or some sort of infantry because this is a last standing kind of scenario where if there's only one of you left, you could at least get out with a pilot. And still be able to defend yourself and not have it just turn into a kamikaze mission. Okay, guys, I do got to backtrack a bit because I got to keep you interested, and I also have to make this pertain to surveying. So, going back to our deployment portal, I just want to say, as that has to do with surveying, there's a lot of little tricks that I have with surveying in Western Canada. As you know, a lot of those tricks could even be used in a March on Moscow type of environment where it is very cold all the time, and you still need to be able to employ all this technology. So, the big thing to remember about the outfitting and the gear, which we all have an understanding of, is when I'm surveying in Canada, I always have big winter boots for the winter, obviously, and they're insulated and they got a rubber exterior that's robust because you got to keep your feet warm. If your feet and hands are not warm, you're not good. So, assuming it would be a cold environment like I work in the winter, the number one thing I'm going to have is some sort of animal skin glove, and I mean that by like a leather or deer hide, or in my case, I always, and have used these since the beginning of my career in surveying. So if you want to do surveying in Western Canada in the winter, you should get bison skin mitts, and mitts are better because your fingers are closer together and they stay warmer. You can drop a couple of hand warmers in these anytime. And if you're ever working an instrument where you have your hands elevated towards the instrument, the blood's going to drain out, they're going to get cold. But if you have those mitts, you got those boots, and you have a pair of overall bibs, you want to have bibs all the time, preferably something where wind doesn't go through very much. Then you could just have your regular jacket and sweater, and then if you really need, you can go with the like the fire retardant jacket to go with it. So that would be my real life loadout for what I'm going to do anything winter, anytime, any surveying in Western Canada in the winter. However, it's going to be a little different when it gets to the spring and summer for obvious reasons, because it's going to get hot still in Alberta where I'm at. And if I'm surveying in British Columbia where I have surveyed and it's hot and there's bugs, I'm going to want a couple things for that too. So first of all, I still want to be able to wear a t-shirt. So you could take that into consideration when deciding your ASUs. But if it's the Amazon jungle and it's going to be hot, I'm going to want my clothing to be as breathable as possible and as flexible as possible. So I'm going to want everything to be, in my case, in what I do in surveying in Canada, is I'm going to have all my clothes be like a flex fit type of clothes. Like, for example, my jeans will be flex fit because just because of the movements I'll be doing throughout the day, like digging large holes that are subgrade, anything like that where it could wear down your hips, or you're going to be carrying material or anything like, or equipment, you're going to want like a flex fit, highly breathable clothing. In my case, I would wear a t-shirt and something like that. Now, if you are in northern Alberta or you're out in the Rockies and you notice the mosquitoes or the black flies are bad and annoying, and both of them will be the two that you encounter the most of in northern Canada or in the bush, you're going to want to protect against that. So my advice is get a small non burner like device, and you can get them at any store really, and it's going to have citronellin pad in it, and it's going to have a burner that uses probably butane just like your lighter. And what it's going to do is heat up that citronellin pad or whatever you use to keep the bugs away, and it's going to give you a zone around you constantly where you're going to be able to function without the bugs bothering you. And this is going to come in handy when you're surveying, but also if you're like some sort of sniper in the situation and you don't want bugs biting you and messing up your shot or whatever, whether we can't get it down using our technologies or not, you're going to just, I'm telling you guys, bugs are going to be bad in the Amazon, and we're going to have a way to deal with the critters and leopards and everything else, etc., with doing minimal amount of damage or cause of death to any of the wildlife or locals. Because we're going to also assume that when you come into this drop zone and you have to cut down, we'll say, a few trees to make it, and and stay there for 60 days as we've proposed, we're going to assume there's some locals there and they don't have a lot of clothing. They don't have medicine supplies. They don't really have a steady supply of food other than that river maybe. So for some fishing, some trapping, a little bit, things along those lines. So it will come in handy that you have the steer named Jake, because the first thing you're going to probably do when you get there is slaughter that steer, and it's going to be your food source for 60 days. It might not last 60 days for this number of people, and that's fine, but at least you're going to have food right away. And whether you got to hunt for a little bit or utilize the locals, you're going to have good rapport with them, because they're going to try some AAA steak right when they get there. So that'll take away your cannibalism tendencies, if there is any in the neighborhood. And also you're going to have a little bit of salt on this loadout, so you're going to be able to make food that'll last if you have to go on a long type of reconnaissance trip or anything in your MRAP. So I know this is all really fantastical and it works good in my little book that I'm putting together in my mind, but I'm going to have to be able to sell all these technologies and stuff to you guys. So I've basically told you what I would do if I was surveying in Canada and how those things relate, like especially to our little deployment portal with clothing. The other thing I'll mention, that if I was in a terrain like this and I was surveying, which would be similar to a forest-like terrain, which you might encounter like in a place that I've surveyed, although I didn't survey in the bush on Vancouver Island, I'm familiar with it all over BC. And because on Vancouver Island I was doing high-rise surveying, so or not even, but just witnessing, so that's my least experience. And then also oceanography surveying, which I've never done because I get real seasick, and so the ocean is the biggest surface area on the planet, so you're going to want to know a little bit about that. But a lot of our technology still will work there. It's just you have to take into account the movement of the water, etc. Okay, so I got what I would dress like if I was surveying here. The other thing that would be involved in that is, guys, I wouldn't wear a steel toe boot anywhere, anytime that I'm surveying when it is spring or summer. And is because as a surveyor, you're going to do a lot of walking. So you're going to want a form-fitting, hiking, waterproof boot that you can get wet pretty much at any time and not have to worry about trench feet throughout the day. Even if it gets water in it, it's just a matter of drying it out at night and your feet will dry out and you're good to go. So it's going to be a high quality hiker. Not in the winter though, because it won't be warm enough. Winter won't really apply here. I'm just talking about my surveying equipment like that I would wear in Western Canada. If I ever had to go to a site where I needed a steel toe boot, I could obviously switch to that, in which case it would be an iron worker boot, which is banned in a lot of places. Again, I'm going for comfort, but the thing to note about these boots is, even though they are steel toe, they have a very flexible, form-fitting sole that is broken in from the day you get it, and it won't freeze in winter. So, or at least it won't get very hard in winter. So unlike most boots that have a plastic rubber combination in their poly, they're going to get really hard and not likable during the winter. So That's just in case you got to do that where you're at. Okay, the other things I've talked about is how we're going to use water as our primary fuel source by turning into hydrogen and oxygen. This is going to do some good things for us, but the other thing we're going to notice is that there's a few different ways we can accomplish this. But before we get to that, guys, because it is a big claim, and I've went over a little bit, but for you guys that are in the military, you're going to know that your number one problem to solve when you're doing battle anywhere is going to be your POL, and that's your petroleum on land. It's availability, and if you don't need to have petroleum, that's fine. But because we are also covering some other forms of surveying, we are going to incorporate a seismic survey, and we're going to do some uh, drilling for resources, etc., in our area, because we're going to help out the locals so that when they're gone, they're going to have access to these technologies and stuff, so that they're going to be like, yeah, we're glad these Métis militia came. They helped us solve the political problem and they got out. And so in order to do that, I have to develop some policy, and I have to tell you what kind of soldiers I have available. So the policy is going to be diplomacy before military action in all cases. So this is like if we have a bunch of local guerrillas and they're armed and heavily dangerous, and maybe they have some of the similar technologies that we do, we're going to have to outperform them in any situation for the sake of the local population. So we're going to kind of incorporate something that's called the 3 block war. It is kind of a Marine thing, and it was developed primarily, I think, by Chuck Krulak, who I really admire a lot and would have been the reason why I wanted to go to the Marines had I decided to, or if I was able to, based on being Métis and having heritage land in the United States, which is true. And my mother happens to be American, and my little brother was in the United States Army, in the airborne in particular, stationed at Fort Bragg. And he was invited to go to RASP, but he turned it down because of clearance issues and losing his Canadian citizenship. Okay, so, and because he wanted to come back to Canada, right? So I do know a little bit about the military, but I'm not highly enough qualified. I have not made it through boot camp or any of these things. So I'm just going to develop policy based on what I know about them as a layman. And the soldiers that I've been given aren't going to be in too great a shape. And that is a big issue that besides POL, Army, Navy, and Air Force all could be having. And that is having soldiers that are what I would like to call super soldiers. And that means they could typically run 3 to 6 miles a day and recover enough the next day that if they felt like doing the same exercises, they wouldn't be worried about it. And that would be like the most they would have to be doing in the running department or hiking department, because our MRAP is going to be able to go long distances, and it's going to be able to carry the loadouts of several soldiers in case they need to. Also, our helicopters, one or the other, will be able to leave in local deployments, and it won't be both, because if both go down, we do not have a hub and we can't get out. The reason why I wanted the helicopters to land and stay is because immediately the helicopters, if you mount on top of them at some position, particularly maybe the back rotor in the tape of in the case of Chinook helicopters, you can have the same technology that we would use in surveying, which would be a total station. So it measures azimuths very accurately, or angles as you would put. I would have all your angles broadcast in decimal angles, so like to 3 decimal places would cover your 3 to 4 decimal places would cover your angles all the way to the second, degrees and minutes, or minutes, degrees and second, or degrees, minutes, seconds, sorry. Just based on their fractional value, it would still be accurate enough. And the reason why I say that is because when you're computing a lot of data, you keep it in the same format, it just streamlines better. But that won't matter. You guys are going to all know about that if you're in the military and how it works for you. But so for this situation, we're going to say we have a total station technology. So it's going to have a laser, like an EDM that includes a laser, and an angle measuring device that can do slope distances and all that kind of stuff. This technology has existed since the 1980s, and something called the theodolite is basically a laser. And then you have an azimuth measuring technology. Typically, I would assume the best for this would be like a laser etched glass. And excuse me, and it would be like a protractor in nature, so that it can just measure accurately your distances. Now, The tolerances that we have in machines like this in surveying now for robotic total stations is a 2-second gun, meaning whatever distance that it is measuring. And in this case, we're going to have a small area to cover because it is going to be just our circular drop zone that we call our forward operating base. Um, it's not going to be it's definitely not going to have to be greater than that, guys, but we can go 2 seconds to 5 seconds quality. And above that EDM measuring device, you're going to have a GPS sensor that will relay to your position, your 0, and then it will also give you the location of your copter, whichever one you came on, and essentially that will be your 0 for your base station. Each person's copter may be different. Maybe you design one that holds the value. There's another way. Maybe you could do a little bit of a trick, and so it halves the distance between both base stations and creates a 0 in the middle of your pad, and in which case you could mark it. You might need that for a drop zone for future materials or equipment that has to come into this pad for you to either grow or decrease your operation. So to be able to give you an idea of how you do that, first of all, the most common cargo plane that you're going to have that can get anywhere in the world in 18 hours or less is going to be given to you by Airborne Ranger, the 82nd Airborne. You're going to have similar capabilities with maybe Rangers if they're using the C-130 Hercules or anything like it. And you're also going to see maybe the 101st Airborne, the 101st. They're going to be more tactical with their choppers and whatnot. So great allies to have would be like the 75th Ranger Regiment. Anyone with Chinooks, which would be like definitely Army, or anybody else that has similar capabilities, whether it's Marine Corps, or Air Force, or anything like that. So in developing my policy, I know I jump around a bit to kind of keep you interested, but it's usually because I'm covering subjects that are interesting to me. And that surveying technology that you're going to have on the top of your copter is going to be that robotic total station like quality, and it is going to also have to be linked to a server on the copter. And it's also going to have to be linked to your LiDAR system that is on the bottom of the copter. So this is like the brains of the outfit, guys. It's going to do everything, all the calculations for you that you have to do in any situation. Your position based on the sensors in your helmet will always be 0 compared to, your copter will always be 0 compared to your location. So for example, I'll just show how that will look. If I change the view and I put my grid lines back on, and my own location being 0, and remember, it's going to be meters for you guys that are in meters, and it's going to be decimal feet for you that are in decimal feet, and you could have it convert to either one, because I'm going to assume we're going to have Canadians and Americans that are Metis on this trip. So all that's going to do is just broadcast the information they need in feet or meters to their helmet, so that they can make up in their mind what it means to them. So if it says 5,000 feet, they know they got a mile with whatever they're messaging or they're measuring. And then for anyone that's in meters, if they see 1,000 kilometers, then 1,000 meters, then they're thinking, oh, that's about a kilometer. Or I'm just assuming you'd be able to get how that goes. So basically 0 will be this copter, and this copter, depending on how you designate it, will be up to you. Just keep in mind, you're going to want a large position in the middle, because these C-130 Hercules will be able to drop airborne material anytime. And I know you guys are already thinking like, okay, so judging on the size of this circle right here, we have about 100 meters across. I don't know if that'd be big enough for the two Chinooks. You're going to have to decide for yourself. It's going to be a combination of a few things. The size of the rotors, the distance between the front rotor and the size of the rotors on top, the distance between the very front, the sides and back of all rotors. And you're going to have to add a certain amount of distance so that a pilot could safely get down. Um, but as we said, everything is going to be scanned, and it's going to also look for the lay of the land. So when you do land a helicopter, somebody's not going to get off one side and start walking uphill and then get their head chopped off because there's just not enough walking space. So all those things will be considered when picking this, and a lot of them will be similar to if you're laying out a seismic project and you have to get heli access. Um, I want to take this fantasy to the next level. I'm going to say that once we get our little drop zone cut, there's some locals there. We're going to need to give them medical supplies because we're doing 3 block war, and then we might have to engage an enemy later on, maybe in the first few days or not. But we're always going to try a diplomatic action before that happens. So our general policy is going to be we're going to use tungsten or something equivalent or better for all our ammo, whether or whatever happens to be in our loadout that's available at the time. Um, the reason why I'm not going to use depleted uranium for my 50 cal or anything like that, guys, is because I want the locals to be able to have babies after I leave and have them not be highly deformed, as well as my men when they get back to their home. If you use depleted uranium, you're going to get infected and it's going to pass on to your wife or family if you're a male. And you don't want that happening because it is a killer. And it has been a big problem in other areas of the world where it's been used because of extreme birth defects, abnormalities, etc. So I want to make sure that I'm not leaving anybody any more worse off than when I came. What is this? This is kind of my HSE policy, and you guys have to adopt that how you would wherever you are discovering, exploring native land. And there is some things that I would do differently. Like if I was in northern Canada and I was doing SAGD oil sands, and so I would be looking for that, how to get it, and I would use in particular like a directional drilling technology, which you guys might be familiar with. However, I would do a lot differently. I would utilize the water source as getting hydrogen as my solvent. I would put it into those oil sands, and then I'd make sure I recover the most of it at the end of the riverbed, whichever the formation is in, and it will be typically in a riverbed in that area. So let's just say all these grid lines are something I can map out. And let's just say the grid lines each happen to represent 10 meters or 100 meters, whatever it is. Wherever I have a weapon that gives off vibration and say it is being used, like if I had, let's say like a howitzer, which I don't believe we would need to use, but we could, but it would be giving off like a very large low frequency sound, which would penetrate very deep into the earth, and you'd have some refracting and reflecting. And let's just say on one of these helicopters you had recording equipment so that you could set up geophones, and those geophones would receive all of the vibrations that were given off from small arms to large arms fire. And because you have the location of all of them via weapons and sensors in your helmet, etc., we're just going to say that we know the source point, and then wherever we laid out geophones in the vicinity where we chose to, because they are going to also do some other things for us. We're going to have them hooked up to a seismograph, and they're going to track whether there's footsteps, anything like that in the area besides animals, machines. They're going to be able to detect a lot of things. So we're just going to say we're going to spray out these geophones. And now all these geophones, guys, are the cutting edge. So if you are doing a seismic project, it's going to be a geophone with a GPS sensor mounted to it, and it'll continuously relay its position for as long as it has to establish it, or just keep it going all the time, because we're going to want them to be able to notify us anything that's happening seismographically. So I don't know if that's a word, but I just mean like for that a geologist could use to discover or interpret what kind of resources are available. So anything like the small arms fire, or like say we had a shooting range and we had to stay up to date and we were just practicing every day somewhere here on the back of our we're calling it the spawn location for Call of Duty, guys. But any of those lighter arms fire shots that will be tracked to our geophones will give us a more shallow idea of what the resources are, because they're going to be more high frequency, guys. So That's the kind of seismic data you'd want to get if you were doing like a shallow oil sands type formation. So remember, high frequency for subsurface, and that's just like a guitar. If you're playing the high stringy, and it's not going to go through as many walls, but it's going to really ping inside the room you're in. If you play the deep, the low E, it's going to be deep sounding, and it's going to penetrate through the house, and people aren't going to like it as much when you're playing power chords. And so it's going to give you greater detail of what's really deep, and it's all just based in seismic. Any of you guys that are familiar with it know how that goes. We're not going to be drilling for those resources, but we're going to assume eventually maybe we could. So in the Amazon jungle, it would really be hard to have, like, say, a Caterpillar drop in and work off our base station. But let's just say we were in an area where we could do that. We're going to go like this, and we're just going to draw a line, and that line is going to be our runway. I don't know how long a C-130 needs to take off and land, but I'm going to assume that we'll just say if we're looking at these and they're 10 meters a pop, that means right off the bat our landing zone is a kilometer. You guys aren't going to be able to clear that many trees to get in, so we're going to keep it to like that 100-meter plus area that you calculate for the area of your planes, and then workroom in the middle. You can always expand a little bit outside the zone because you're going to have the chainsaws and all that. If you want to like hide your where you're sleeping at night or whatever, but we're just gonna assume that you have the ability where you're at to make this runway. So I'm just gonna make here a large size line, and then we're gonna say that they need if each of these increments at the top right here represent, say, 100 meters, so each of them are 10 meter squares. We're going to just say they need, and we could look this up online, but I'm just doing this hypothetically so that you can get an idea of what it would take. But any runway that I've seen that even has a smaller vehicle, or maybe a cargo plane, could land or take off on an aircraft carrier. So we're just going to say we have 300, so that's 100, 2, 3, 4, 500 meters. So 500 meters is about 5 football fields. So you could calculate how long of time that would take to make. It would be a lot longer, and I don't know what you'd have to have for material. You're going to probably it's basically going to look like a high grade gravel road, and they're going to need to be able to take off. They're going to be able to turn around at the ends pretty much, and then somehow park near this zone. Now, the reason why I bring that up is because if you're going to be making this forward operating base last long, and you are going to need big reinforcements, you're going to want none other than the C-130 cargo plane or anything like it, and it's known as the C-130 Hercules. There are more advanced planes that are similar, but that's just our benchmark because it's highly available and usable, and it could get anywhere in 18 hours. Now, as far as dropping all your equipment in the middle of this zone without it landing on your helicopters, etc., there is a way to do it, and it's not really being done, but I'll explain it to you now. Let's just say you have a large pallet of ammunition because the guys have been fighting for days and they just need ammunition. Maybe it's past day 30, and we already ate our steer named Jake, and our border collies can't find the food we need. We've been tracking the trails, and it's kind of become an issue. So we're just going to have a whole bunch of MREs maybe dropped off. We're going to assume that everybody can cook a little bit. We have 100-degree water on at least one of these helicopters, 120-degree water all the time. So we can disinfect. We can do a lot of things with that, but we can also cook because anything that it passes through will make the water on the outside of it boil. So we're gonna just say that, eventually you're gonna have to drop material in here. So if you have a large pallet and then you have a quadcopter delivery like device, which you could use in civilian life, and here would be an application. Say your wife wants something from Amazon. You have a large hub in your city that has a plethora of these helicopters, and what it is guys, it's gonna be a medium-sized fuel-operated quadcopter that has GNS technology, most likely dual 2.4 if you need it because you have the 4 rotors. but you'll only need really dual in most cases because it's going to have your accuracy down. And 2 cell phones would be able to do this in equivalent technology. Um, but basically, if you had a hub in your city like that and you had a small, medium sized gas powered, or fuel powered, in this case would be like a hydrogen fuel powered, quadcopter, and your wife had a large yellow square that's made out of foam that she just throws on the front lawn. She takes a picture of it. The GPS in her cell phone tells her position and direction. You already have the civil address on Google, etc. So the quadcopter flies over. It recognizes this big yellow square that you put on your front lawn. And because you're using a quadcopter that can fly, we're going to just say this medium range quadcopter can fly a minimum of 60 to maybe 160 knots an hour. Somewhere in the middle, we'll say, but we'll just say it's slow for argument's sake. At 60 to 100 miles an hour, it can get anywhere in your city to this yellow square in your front lawn, drop a package, and be gone, usually within the 15 minutes that it would take to get there and get back. So right there, you don't have to worry as much about automating driving as you thought you did, because all your wife had to do was take a picture of the lawn with a big yellow square on it. That position gets sent to, in this case, we'll say a company that delivers goods to your door when you're shopping, and that'd be the quickest. Now, to keep to automated highways and stuff like that, because I do have to keep this video interesting for anybody that's interested in surveying and understanding that. If you wanted an automated highway that is solely just for traffic that is automated or driverless, everybody knows that it's hard to establish this technology and application of it, and there's people trying to get it, and I'll give you all the secrets of it now because you're going to probably want to know them. First of all, if you wanted to take a nation like Canada, who has a low population density per the amount of land we have, and the largest amount of our population lives towards the U.S. border, we're going to say that you need a large dedicated highway that can go back and forth, where you can have transport vehicles, in particularly like Super Bs pulling 2 trailers or 3 trailers, just max load. It's almost competing with railway in terms of loads, but railway is just so big and awesome. So if you had all your railway systems, which can haul way more because of just the locomotives and that, and you had them all dedicated to resources only, like hauling oil, or where pipelines weren't applicable, or maybe you're hauling potash and all these things like fertilizers, all that kind of stuff. So if you kept raw materials to trains, that would be the biggest improvement, which I think in most cases it's already done like that now, whether it's lumber, anything that you're going to sell or export or use to manufacture within the country and resell. Okay, so the secrets of the transport are, if I was the president of the Metis Nation and I'm already going to war, and I decided I had allies like Canada and the United States, and I said, hey, if we could get automated transport going, that means we're going to have a hub to be able to continue conducting these operations. So if in your city you had the quadcopters that could deliver to a large foamy like shape on your front lawn just by sending a picture, you could get a lot of resources into the area of a city, and then just have quadcopters controlling the airspace, and then you just have no fly zones over the city. I don't know, in my particular city where I live, which is Red Deer, Alberta, you'd be able to access any part of the city fairly quick with a fast machine that could go cross distances like this, and it would only be occupied for a minimal amount of time as compared to the current delivery methods that we have. Okay, but as for getting your product from a hub or manufacturing location to the end user location, you need a large dedicated highway, and it has to be fairly well above ground, and it's going to have to be for a lot of the reasons. First of all, if you have an automated transport vehicle and it's pulling a Super B, and somebody jumps out in front of you on the highway, and even if you have recognition software and everything, you're utilizing all the capabilities of survey on that vehicle, it's going to be very problematic. And there has been times when people have been struck by driverless vehicles. So when it comes to animals, they will usually look at the vehicle. You would be able to identify the animal with the technology that we have now. You'd be able to project where and how it's standing because of its eyes, and this would be the same case with the human if they were to stare at your headlights like a deer does. This creates a lot of problems, guys, because it's going to slow your transport. It's going to make it a little bit more unpredictable. So wildlife, the human factor, other drivers, all these things really degrade the ability for people to implement this kind of technology. So if I was going to do it the way I had to do it, I would just go to the government Canada and say, we will try it in Canada, and we already have the corridor to do it. And because we are going to be using vehicles that have about the same speed specs as everything that's on the highway, we're not going to need to deviate from this corridor very much. However, at times it will widen and change. And guys, that's none other than the Highway 1, or as we call it, the main highway that goes from eastern Canada to western Canada, covering all the provinces. You would also be able to get it going up to the Alaska Way if you went through Dawson and tied into the Alaska Highway. You may or may not have to do that, but I don't know. In my situation, I would, because the Alaska Highway is already there, but it is not all double laned. We're going to assume that we have a double laned highway like Highway 1 from end to end. And it's going to be efficient enough to work for 30 million people that if you had a larger amount of people in a less amount of land, it would be even more highly efficient, like in a similar case to the United States, where they outnumber Canadians 10-1. So what would the highway have to avoid all these things? Well, first of all, we're going to take the Highway 1 corridor. The government of Canada already owns Highway 1. It is typically dual lanes, so we have 2 lanes on each side. So that means we have a large corridor in between all these lanes in a lot of places. Wherever it is single laned or just double lane two-way traffic, it wouldn't be as applicable, but you could still use the right of way in the ditch. And at times you might have to go through the middle. Maybe you come through some swampy area or some mountainous terrain. You're going to want to hug this and use it to the best of your ability. And you're going to want to put your highway above ground. So that means you're going to have the ability to make a structure that is kind of like for a high-speed train that's going to be highly above ground. It's not going to have to contend with transformers in any case or power lines. And so because we're only going to be using typical vehicles on it that will be able to be transformed into automated vehicles, we could use almost anything, guys, that we could get to shift automatically using some sort of sensory technology just based on the power band and how it's hauling to get max of fuel efficiency. We're going to have the most longest consistent road. The super elevations, meaning like the grading going around corners and all that stuff, it's going to be virtually the same as the highway design because that is all based on data and how vehicles work at certain speeds. The thing that you're not going to have to worry about is the human element factors. So this would be a highway above ground, sitting on piles. The piles would have a large collar around, probably 2 or 3 of them. In most cases, probably 4. We're talking like a 12 to 24 inch pile, depending on what you want to go with. I'm going to go with something big enough that can be helically screwed in and not have to be driven in with gunpowder. So that way, if it's not big enough on its own, by the time you put a group of 4 of them together and then you wrap all 4 of them with, say, a few feet to maybe 10 feet of concrete, it'll act like a collar and just holding those 4 piles together. You could have anchor bolts in the concrete, whatever you want to get your bridge system up to manage this highway. So the highway would go from pile to pile. How far you have these apart, I don't know. I just think helical would be the quickest, and where you put them would be the quickest. Anytime you have to do something else, you would do it. So now I have piles, and then I am going to have to put a road on them. And I'm guessing the best thing in this situation would be some sort of precast concrete that you could just fly in from the existing highway up onto your structure. Remember, you guys, you're going to need workspace, and typically it is going to be your highway, and so it's not always going to be cost effective to reroute traffic, etc. So you're going to want to be able to build and go, and all of that's going to be based on like the distance you can have between piles so that your road can be structurally sound. So you might want steel between these piles in some cases with concrete on it. You probably don't want to have to pour on site, but if you, because it's going to involve a lot of framing and stuff. So that's why I say precast, maybe concrete with steel in it, so you could have these coming from a modular building facility, and you could actually as built the pile caps and the uprights that the road will be going on in real time into a cloud, which would pump out the engineering schematics for the road and where it has to be placed and when. And so all this is just getting the calculations and stuff down so that when you procure for your EPC project, that's engineering, procurement, and construction, that you're going to be able to have as little effect in the area that you're at and still maximize construction. So let's say you have this highway and all of a sudden it is done. You've built through the corridor. You managed to make this above ground highway and no civilians are going to be going on it. It is only going to be for transport. What does that mean? Well, that means everybody that's on the civilian road now doesn't have to worry about trucking traffic. Anybody that was a trucker, they only have to truck really in their local area for needed for, and it'll mostly only ever be for commercial purposes because we're already delivering everything personally for personal shopping with quadcopters to the lawn with the big square that your wife takes a picture of. Now, that means there's going to be lots of jobs, but guys, for every technology I'm employing, there's going to be a creation of jobs that is bigger, because I think surveying is really undermanned in a lot of fields and it is overpriced. So that is why a lot of people don't order it as much as they can, even if it could be used, because it's a big ticket item. So even once you get through this video, you'll have enough knowledge that you could go and bill yourself out for a good $200 an hour just setting up machine control and showing people how they can get their site on track. The other thing is, if you had this automated highway, you would probably make it about 4 lanes wide. You'd have similar speeds, but better speeds than typical traffic. And the reason why that is because the speeds that you use typically on the road are designed for like reaction time, the ability of current vehicles to go around corners, etc. And a lot of them are based on older data and older vehicles because they were built a long time ago. So while sticking similarly to those standards, you'd have areas of the highway where the vehicles, in this case the large hauling vehicles, they would be able to go at speeds that they wouldn't normally be able to on a highway because of all the unseen conditions, including weather, etc. The thing that you're gonna have to remember about your highway too is it's not gonna be sloped as much with a crown like the roads that we typically have, but it will have to be because you're gonna need to get rid of rainwater, etc. And then you're also gonna have to have a large barricade type structure, probably reinforced concrete on each side of it so that nothing ever comes off your road. But with the automated technology that we're going to have for tracking all of these for all of these transport devices, you're not going to have to really worry about that either, because we're going to make sure that we're tying in either horizontally to under 2 centimeters for staying on that road, and we will be able to do that very amply based on the GPS sensors in the vehicles. But in case we need a fall safe for the big ones, we can also mount a 360 degree like prism like device that can shoot from a specific location where robotic total station like technology receives that vehicle at a certain distance and guides it till it's no longer able to see it anymore, in which case another robotic would pick it up and go with it. So if you have a very high volume amount of traffic, you would need a bunch of these sensors in locations where you just have to decide how many are going at one time that could be seen from the same position or more, and guided if you wanted to with this technology. That technology is already available to use in everything from paving to making curbs and all that such kind of stuff. So it would just have to be a dedicated highway without all these foreseen elements, and that's kind of how I would do it. So in my highway, I would be 4 lanes, so I'd have 2 going each way so that I can manufacture in any location I wanted to based on population and deliver to any other market. So right off the bat, if you take a place like Canada, most of our manufacturing is in the east, in particular like Ontario and probably even Quebec, and we'll just say even into the northern states. So a lot of our traffic might be going one way most of the time. So you might have to dedicate 3 lanes one way, 1 lane the other way. I don't know. You guys would be able to track and figure this all out in this system. But what's important is that you would be able to get a lot of vehicles that are existing onto this technology just by installing the 2 GPS sensors, maybe sensors at the back of the Super B if you're pulling 2 or more trailers. And then I would have my 2 main center lanes dedicated to this traffic going each way so that it's only high up vehicles that are pulling lots at a fast speed, and they will be continually maneuvered by GPS or sorry total stations and or GPS to line of sight or to GPS quality. So anytime you'd have to go under a tunnel, you definitely would have to switch to the robotic total station for navigating. And anytime you lost GPS or anything like that at any time, you would have to switch. You would have to have that technology available to keep your vehicles going. Otherwise, they probably shut down, stay where they are. I don't know what the protocol would be, but it would and could create problems if the corridor wasn't totally working in proper manner all the time. So you might see some issues that I haven't seen. But how mine would look is I have the reason why I'd have the higher up trailers and main vehicles going on the 2 inner lanes is because I would probably have smaller transport vehicles, like kind of like a FedEx style van or something like that. And I would dedicate those to the outside lanes. No matter what and where they get, they're gonna they're going to be able to use the quadcopter hub for delivery to location when they get there. But just on this large dedicated highway, we are going to be able to transport those types of goods. So these are like finished product goods that consumers might want. They could be for commercial, industrial, etc. We're going to try and keep it a non-dangerous goods route because it is above the highway. So you might still have to have those hauled by specialty drivers who can adhere to all of the signage and get through cities as we already have set up. But if you had the smaller vehicles and you kept them to the outer lanes, you would never have a visibility problem tracking the middle lanes because they're going to be much higher vehicles, whether they have a 360-degree prism on them that has to track them with a total station. All this equipment, again, would be up on the highway. It would have to be protected from line of sight so that nobody could tamper with it or... and then it would have to have some other features on it that make it highly reliable and untamperable with, but it is possible to do. So what happens when these vehicles get to a city or a place where they can load off their material? Well, that place would just have to be another designated highway or laneway, or maybe it's just a place where a driver can come up, shut off the automatic tracking on their machine, and then manually haul that vehicle. So that would get all of the main heavy hauling traffic off of your roads that you can use just for civilian life that would be patrolled by police. And I'm pretty sure you could make it all work. The bridge would like the road itself would be hard to build, but it would need the general characteristics of of being free from animal, wildlife, the civilian factor, and then other drivers and all these types of things. So I know that's a lot to digest, but it could be done. So you just need the main corridor to be dedicated only to automated traffic, and then it would have to have eventually have a location where either links up with a driver or just somewhere it drops a product at like a central warehouse. So, for example, in Western Canada, there is one central warehouse in Calgary that delivers all the Walmart products using just typical drivers. So you might go to a place like that and imagine you could have all of that done automated, and all that you would have to do is ship the the products to the actual store location, where you would need a user friendly kind of ability to do it like with a driver, but all that kind of that infrastructure and everything is already in existence. So it would just be conventional driving and that sort of thing, right? But like I said, if you wanted to just deliver those products directly to homes, the quadcopter system and airspace in the local city would be working, or would work, just because it is reliable, predictable, and it could fly in a lot of different weather conditions, whether there's snow or not. The other thing you'd have to note about this highway is it would have to be able to be free of ice and snow all the time. So some of your automated vehicles would be for clearing snow, and you probably would want salt, because salt is just the most reliable thing to keep the road from freezing or getting ice and stuff on it. So you're gonna want like salt out of it. It's like assalting and clearing dedicated kind of vehicles on this road, and you're gonna have to be able to pick a way you monitor those type things. So if you get rid of the weather, the human factor, and you would be capable of going through a project like that, that's kind of how in my mind you'd have to do it, just because of all the existing infrastructure we already have. Another option would just be to pick a large right of way that's existing, like a pipeline right of way that maybe it's been abandoned and it's already cut, and you can go through there at times. Once you get through the mountains, a lot of the longest and best tunnels would be for railways, and you couldn't go through those because there wouldn't be enough room. And the driving ways would be fine, like say if you're going through the Rocky Mountains into BC, but it would be very costly to make dedicated areas of road for transport in these areas. So you might only be able to go from like Alberta to the East Coast and then use typical transport into BC. But nevertheless, those roads going through, like, say, the Rogers Pass in British Columbia, they're very predictable and highly engineered. So you might be able to use the automated technology on them. However, then you have the traffic problems, and definitely the weather can be a big cause of concern when you're passing through the mountains, just because of avalanches, copious amounts of snow, all kinds of stuff like that. So the dedicated highway is the way I would go, and it would be from hubs to hubs. You could also extend it further north and south of your main highway, and then you just have to have the appropriate entry and exit points that either go to a place where the real driver takes over, or the product is delivered by a different means. Okay, guys, I think that's most of the information you need in the highway. But either way, let's just say you needed your own landing strip. This is how we would do it. We would have a large, like, or a cat-like machine or bulldozer that would have to come in and clear bush and make a high-grade gravel road using the original ground and materials to the best it possibly could, so that a C-130 could land on it. We're assuming that he's got about 500 meters to do it. I'm guessing that would be a lot of room, but I don't even know. It could be only half the room you need. You would be able to find out easily just using the internet. So I'll leave that to you. I'm going to say it's this, and I'm going to say it has to be at least like 30 meters or 30 meters. 30 meters wide wouldn't be enough. That'd be too narrow, I think, for the size of these planes. So I'm going to say it has to be like 60 meters wide, and then you would be able to fit in. So I don't know how long it would take a cat to cut that much bush in the Amazon rainforest and make it flat enough, but it might be a long time and you might not be in a location where this is practical. But if that was part of your deployment or possible deployment, you would also be able to measure that with your original LiDAR that you did before you created your drop zone and you got in. So if you couldn't do if you could not do the air runway, but you still needed help from, say, the 82nd Airborne and all their cargo planes, whether it was soldiers or equipment, we're just going to say in this case it's equipment. But if we needed the soldiers, they would be able to drop into. Guys, I don't like floating in on a parachute. If somebody has anti-air technology, as in like high-powered guns and high-powered stationary guns that would be able to pick you off as you're floating in on a parachute, if it was night or day. So if it was night, you'd be silhouetting against the backdrop of the stars and moon. And if it was day, well, obviously you'd be able to be seen very well. But with infrared or thermal, it doesn't matter night or day, whether we do this, we're going to try and make it so you could drop in and do it at any time of day or night. So I am jumping back and forth with these subjects. I'm trying to stay with everything that's on this page. So if you guys want to just give me like a little break, and I'm going to keep on rolling. Okay, so we gave something to the delivery companies for this automated highway and how it would work. We've done a really big thing for military guys, which is their number one problem, and it will be if you're doing seismic or oil or anything like that. It's going to be your petroleum on land or your petroleum fuel source. And right now, for like we'll say the U.S. Army, the everything but the lawn mowing is done with diesel. And sometimes that's just done with private power because you don't go to church, I guess, as I'm told. So that means you're clipping the grass with your hands, and everything else is used with diesel. So we're going to assume that we can get rid of all that with hydrogen. There's going to be two vehicles that make that for us. One is going to be in our camp, and it's going to be one or both of our helicopters is going to have LENR on it. That's low energy nuclear reaction. That's our 120 degree water. That means, guys, when you get there, this system will be empty. So you will need somebody with scientific capabilities that can prime it with treated water and make it run, whether like getting the catalyst going that keeps it going. I don't know. I know there's some nickel involved. You guys would already know if you're in that field. And I can't give too much away on here because, again, this is just going to be on YouTube. You either found it through my LinkedIn or Facebook or anything like that. So I don't want to get it removed, but I'm telling you, the possibility exists to make your number one fuel source hydrogen. And if you could make that hydrogen from water, you're going to have the oxygen. And if you have LENR, you are going to have 120 degree water. What that means is when you land in this location and you are out of fuel, you can immediately put your high density polyurethane piping, which is going to be like 1.5 inch to 2 inch. And in this case, it's going to be how many meters? So if I look on the side, on the left side, I am just below 400. So I'm about 370 meters, and I'm going to go up to less than 300. So that's about 100 meters one way and a little more 100 the other way. So we're going to just say 150 meters, guys. 150 meters mean you're going to probably need more than the 300 feet. So that will also be calculated when you originally get to this drop zone and you guys have to do a LiDAR over your whole zone. Guys, the things that you will be capable of doing with that LiDAR is the GPS total station like quality products that you're going to have on top of your on your helicopter when you're flying around and your vehicle is on an angle and you're doing circles like this. You're going to be able to either have that technology mounted on the bottom, whereas you can still land with it, and on the top. We're going to want it on the top for when these vehicles are stationed. But the LiDAR itself will give you the lay of the land, original ground, like unscalable material. It'll probably even be able to give you traditional like hunting paths, like if they are worn down by cattle or animals. It's going to give you a lot of information, and it's going to do it quick because your server is going to break it all down for you, and it's all going to be calculated and given out to you locally. So every operator will have it, and everybody that has the outfit that we got in the pre-deployment the pre-deployment portal. So if these claims are true and you can do it, we've solved a huge problem for military guys, and that is they're patrolling on land. We're going to solve another problem right now. And guys, that's disease and illness, and it's going to have to be how our medics can give the locals in this area any type of help they need, because again, I'm sticking kind of the 3-block war policy. 3-block war policy is where you're going to have to be able to engage the enemy. You're going to have to be able to do humanitarian need. And then I can't remember the third one is, and I will just have to check it. But basically, there's just 3 components to the war, and you're going to have to be able to do all of them. I'll check right now. Okay, guys, I just looked it up. If you want to check it out, 3-block war, Charles Krulak goes through it. It is to be able to do humanitarian need, mid-intensity conflict, and keep warring factions from hurting each other in the area, which would be peacekeeping. The mid-intensity conflict, obviously, to deter attacks or aggression of the enemy. And then the humanitarian need, which we will be able to do right away with these locals, is be able to get them some food, some water. And we're going to assume they don't need all these things, but we're just introducing our own land, language, and culture, and in this case, the Metis militias, to this local population. Just so you guys know, largely in part by U.S. forces, the 3-block war has been kind of abandoned, but I do like it because Mr. Krulak is somebody I definitely look up to. He was somebody, just so you guys need to know, he was a commandant of the Marine Corps in, I believe it was the early to mid 90s. He did serve in Vietnam, and if you ever want to see an awesome video on loyal dissent, and you will need it if you work for a boss you do not like, or that does not listen to anybody and doesn't get things done, and you just are wondering if you should quit or not, well, you could employ this, because Metis, General Metis, who was working for Mr. Trump, he decided to quit working, and my personal belief is he based it on the theory of loyal dissent, as Mr. Krulak lays it out for the Marine Corps. And guys, the basic gist of loyal dissent is this: if there's anybody on this outfit of all the people that we put in it, and you can see them on the side, we're going to have the 2 pilots, medic, operators, 2 surveyors, engineers, 2 special ops with dive training. The dive training is going to be for the waterway, obviously, and not everybody likes to swim. So let's just say we picked up 2 Navy SEALs that were going to do any of our diving and booby trapping. They're gonna probably have fun. I don't want to dive in it if it's a river in the Amazon, because it could have really big, ugly animals in it, and for Navy SEALs, that might just be fun for them to ride around on, because they are dangerous guys and they like to get stuff done. Okay, guys, so we have a policy that we're developing for conducting our little war here. We're going to have to incorporate all these forms of surveying that I promised in the original part of the video. So I've already covered what I'm going to wear in that when I'm surveying in my local area, and how I'd want to be down here. That's all going to be based on the materials you decide and load out. My policy is I'm not going to use any depleted uranium whatsoever, because it's so toxic to my soldiers. And when they finish winning this battle, they're going to want to go home and be normal. As for the soldiers I have available, typically all of these ones are going to, other than the special ops, maybe medics and pilots, I'm going to say that I can get 10 guys that can spray ammo. They're my infantry, or primary infantry. They're the operators. The 2 surveyors are going to say one of them is me. And on the other plane, I got a buddy that can do surveying, and he's a Métis. And we're all Métis because we're from Canada, America, and we just claim Métis heritage because it's ancestral land from North America to South America, as we discussed already, because there was no Panama Canal, and it was all accessible by foot or horses, etc. So I'm going to assume that anything can be grown or used in any of those places, whether it's North America or South America, is going to be legal for our soldiers to use. And I know this is where it gets hazy, because we were talking about drug policy, but if you are in oil field in any of the areas anywhere in the world, you're going to have a drug policy. You're going to have a health and safety and environment policy. So we're covering kind of all those as we go. And I'm going to assume that I have a bunch of operators, maybe even surveyors, and maybe our special ops, but whoever it is, whether it's our cow or two border collie dogs, we're going to assume that they have all of the plants and whatnot available that can be grown in North or South America. And so one of these plants that we won't be using, you guys, is probably for a notable reason, but in this case, the locals might have it, so we might get some anyways. And because we are going to share our culture with these people, we're not going to despise what they provide in any way. We're not going to chemtrail their fields of cocoa plants. If anything, we'll just help give them the resources they need to maybe make some money off of it by selling it to our boys. But in any case, the coca plant, or cocaine as it becomes, is not going to be really an acceptable part of anybody's loadout. However, we will say that, and typically for pilots and stuff that are in U.S. Air Force or Canadians or ones like it, they will have they will have something else that is kind of similar, and that would be amphetamines in the form of dextroamphetamines. So those will be legal for our operators and pilots and whatnot to use, because when they get onto location after they have already flown, and we're going to assume it's just the other side of the world they've come from to get here, they might have had to be up for the last day or two. They have already quarantined for 14 days because it is 2020 and we have COVID. And in that 14 days, I'm going to have to make them into some type of a super soldier. And so we're going to use all the technologies that I provide, that have to do with that. And some of them, believe it or not, have to do with surveying and the medical field. So primarily that will be infrared lasers, guys. If you've ever heard of cold laser technology, that is what this is. And it is very valuable. I have used it before in sports therapy, and I have had NHL level trainers training me in order to get me ready for basically an NHL tryout. That never happened, and I'm kind of glad it didn't, because I ended up getting bipolar, and the money and the fame would have been a wreck. But just to give you an idea of that, when you shine a cold laser, which is basically just the kind of laser you have in your pocket, other than the fact that it would be infrared in nature, meaning the light spectrum would be a little bit different. And what that does is enable it to penetrate your skin at like 3 to 4 centimeters, depending on power and the amount that you have. So the one I had in particularly that could get rid of viruses, and when I say viruses, I mean mutating genetics. And so a very common form of that, and if you want to be able to try this out for yourself, and I was a surveyor and I had a planter's wart on my foot since I was like 15 or 16, and it eventually began to spread. How did I get rid of it? It was with a vetro laser, and all that is, guys, in simple terms, is this is a lithium powered battery that can power a laser long enough, and by shining it on the problem area, being the planter's wart. And we're talking, I had used almost every form of medicine available to try and get rid of this, from everything from freezing it with liquid nitrogen, to using the acid type medicines that you would put on it in order to kill it. Really, from just cutting the surface of it with a knife, trying to get it down, and then just using dry ice on it. Like, I've done everything, guys, and nothing worked as good as a cold laser for strengthening the DNA output and getting rid of the virus. And if you want to know how this works, there's a lot of theory involved, as there is in a lot of other things that I've described. But here's basically how it goes. When you shine the light on the virus, kind of like the planter's wart in my case, which would be mutated epidermis and maybe some of the flesh under it. I'm assuming it's just epidermis because it's a wart. It is a really hard thing to get rid of. And I got rid of it, and it's basically little brother warts very easily, and I've never had them again. So I used the Vetro laser. You could look that up too. It's basically 200 milliwatt lasers, and they're all infrared. They say do not shine them in your eyes. I have used it on my forehead and eyes, and I had no problems. But you guys, do not shine lasers in your eyes no matter what, because I didn't ever directly put it on my eye, but that is you could get problems with that, and they're 200 milliwatt infrared lasers. So basically, if you could see them at night and you're using infrared, they'd be very visible and bright, and you could probably look at the stars with them, etc. But in the case that I use them, or you would use them like perhaps on a horse, because it was a veterinarian grade laser, and it's great for healing flesh wounds. Like, for example, if your horse hit barbed wire or something like that, you kind of want to help get the healing done quicker. So not only can it get rid of the virus in the case that it got rid of my plantar's wart, but it also is really good for your skin, healing inflammation and stuff like that. And the best way to administer it is an expensive way, but we're assuming that I'm in a really good position these days because the world is going down, and we're going to have a good budget, and I'm going to get my soldiers into a 14-day quarantine, and they will have a bed available, which is called a quasar bed, guys. That is somebody's name of an actual bed that is being used. As far as I know, it is made in Arizona. Maybe Scottsdale in particularly, it might have been sold, but I have seen them before, and it is loaded with infrared high milliwatt lasers that you can lay in, and you will feel exponentially better. I honestly believe it would get rid of some forms of cancer and highly energize you. There's people that have used it, and they are pain free when they get out, but that's not enough, because diet is really also important too. And these guys are only going to have one steer, and it's going to have to last them 60 days, and maybe some locals. So I don't know, maybe we have two steers, guys, but I'm just saying that you're gonna have a large supply of like readily available meat. But the other thing that you're gonna need is some carbohydrates. So finding things like honey and having some sort of sugar on board might be beneficial, but we're not going to go with granulated sugar because it is part fructose, which is poisonous. So we're going to go with just having some sort of good honey on board that is stocked. I don't want to load bees and try and like make our own honey, guys. It could get really carried away, but you're going to want a good carbohydrate. You have the protein. This could keep you alive for a very long time, especially you have a clean water source. The clean water source is going to help you immediately do your humanitarian part of your 3 block war. And so when you get there the first day and all this material has been covered, and you want to slaughter your steer because it's time to eat, and you're not going to war the first day because that'd be just a little too aggressive. The enemy's a long way away. You're setting up your camp out of visual or sound range of your helicopters, so it's going to be like a very remote location, but it's going to give you the ability to either get on our local abandoned mining road and get to the town you need to, or whatever has to be the scope of your battle and what you're doing. So that could involve maybe having a small missile launch location on your pad where you could shoot a short range missile that would be GPS guided to a location if shit really got out of hand. And that is the first time I swore in this video, so it won't be a kids video, I guess, anymore. But it is really hard for me to not swear and get through all this material because I just worked in the oil pass and construction all my life, and we swear a lot, so it might have that David Goggins element to it at some point. Okay, so I can hear my brother talking in the background. He is in the other room and are based out of our home office here in Red Deer, and he's playing Call of Duty. So if you are and you like our scenario so far, that's great. I'm going to change the subject matter shortly. Excuse me. I am going to change the subject matter shortly so that we can move along. The picture will primarily stay the same. Basically, we've already achieved our ability to get into our landing zone by either bringing in a few of our operators off the plane, primarily the surveyors. Typically in Canada, you could have a legal surveyor that does have a saw ticket, can fall trees, and we're going to pick an area that doesn't have a lot of them to fall to safe our zone. And it will be last ditch effort. As you can tell, we're in very sporadically placed weird trees. I just drew green all over because that's just supposed to be dense rainforest, and it would be hard to land in anywhere. These trees would be big and hard to cut down. So whatever we have as our LiDAR system on the GPS is going to be able to track this all for us. And then also our total station GPS like technology that will be mounted on the rotor that can see and take pictures and do all this. If any of it hasn't been done prior to getting there, it will be able to calculate and land in this drop zone that's decided, because the people that will be cutting it with chainsaws will be outfitted with a helmet that gives them the location of this zone that has already been pre-calculated based on the data that we input. And so far, that's going to be just the ability for the rotors to drop into that landing zone without hitting any trees, and not have the elevation of the land be so far out that the rotors would touch ground at any time or cause people to lose their heads by walking away from the machines if they were still running. So with that covered, you're now in location. You have these machines on the top of your rotors that can take pictures of the surrounding area, identify wildlife. If you see, for example, an alligator on site and you see a leopard, they could be probably dangerous. So these computers would basically be able to log in your server what they are and how they identified them, where they're at on site, so you can go deal with them, whether it's an operator having to down a dangerous animal. For example, if you got to Western Canada, and where 40% of all the grizzly bear attacks in history have been on surveyors in British Columbia, then you would need to know like how to deter wildlife on your seismic project to put people at ease, because right now they could have a job playing games on Call of Duty and make $4.6 million in a tournament, and you're going to have to convince them that they can go get out to your project, do some of the same interesting things, make some money, and get home. So in that situation pertaining to the seismic, I would probably have guides with all of my crews, and I would make them Metis surveyors or Metis militia or whatever, wherever I am in Western Canada, Northern United States, where I had animals that could be problematic to my crews. We already said that if we were doing seismic, we would have some geophones laid out. They would be already tracking the positions uh, of our recording locations if rounds were to go off of any type and we just wanted to collect that seismic data. However, we probably will have a lot of dynamite and C4, so we can go around just for fun and dropping it in holes and recording the data for the locals. So when we take off, they might want to fly an oil rig in there later and make a bunch of money and thank us because we helped them. Or maybe we found gold or limestone that they could use for concrete, or maybe we drilled for our water because there was no river source and we were able to give them well water. In any case, we were able to treat it, turn it into fuel, and not hurt the local environment. So our HSC is so far spot on in everything we're doing, everything down to the ammo we're using, which is not depleted uranium, which can cause a lot of problems, and we just don't want to go there. As far as anybody that is of any age, sex, location in our buddy system, we are going to say, for hypothetical sake, I have been at home for a long time and I decided I wanted to become a woman. So I now have breasts because I've been taking lots of estrogen, and I'm going to lead the outfit or somebody like me, but everybody generally will be of the same rank and abilities because they will have to be able to be the last man standing. But I'm just going to say, for crossing all genders and sexual orientations, I'm in the process of changing my gender, and I now have breasts and I am going to lead the outfit. So that's the other reason why I need my deployment portal to scan me and give me the proper fitting clothes, because I wouldn't be able to fit what I normally was supposed to be able to fit. Okay, so our policy includes everybody. Nobody's excluded, and we are just basing our ideals off of our constitutional requirements, whatever they may be for the Métis Nation, or the constitutional requirements of Canada and the U.S. where we stay from. So in that situation, guys, we are finally in the position where we've been able to make our pad. We got our copters down on the ground, but we need to do it safely, and we need to have a pad built. And if you're just down there with a chainsaw, the easiest way to build that pad was just lay out logs that the copter can sit on. We're not going to use that method. It has been used, say, in seismic a lot, even in northern BC where I've surveyed. But nowadays, guys, you can get a large grading platform or large platform. And if you are in industrial construction, it will look like this. It'll be grading, the same thing you use for any access anywhere on a plant anywhere, probably in North America. And under it, you're gonna have or platoon. Sorry, they were gonna be pontoon like technology, meaning the thing will be able to float on water if it has to. We're not going to put it on water, but we may be challenged with some marshy area or something like that. But we still want it to be able to settle. If not, we will have to reinforce it very quickly in some way that will make it landable on by these helicopters. And the best way, guys, is to have a heavy, not a heavy, but a steel-like grading structure. And I have seen them made, and they are basically like a dock, and they can have a helicopter land or take off from them from any time. So those will be swung from the bottom side of the helicopter. Whether we have gear on that or not, it's going to be unknown, but I would say for the time being, no, because as soon as you drop these into a pad location, they're going to stay there. They're going to be permanent, and they are going to be what our helicopter lands and takes off from. But we're going to assume we're not going to move the helicopters for a while. So they are going to be also base stations for us and our equipment. And they are going to each have their own 0-0 location, depending on which one you get off of. Or you're going to have a shared location, like I stated earlier. Just for all intents and purposes, when you have 0.000 meters or 0.00 decimal feet in surveying, that's what surveyors will call balls. So your balls position is always going to be on your gear, which would be your sensors on your head. It'll generate your positions. And that position will be relayed to your helicopter, which will be at 0-0. So that will always be your hub. Of course, if you're moving away from that location, your man, this little red dot, and there's going to be, according to my calculations, 2, 4, 6, 7, 8 plus 10. We have 18. We got a steer and 2 dogs. So the steer is not going to need GPS, but the 2 dogs are going to definitely need it for the tracking they're going to do in the area. So there's going to be about 18 of those dots. Now, in this case, we could figure out what the position of this guy's dot is fairly easily. And the way we'll do that, first I'm going to switch to a pencil so it looks a little easier. You can see my location is on this grid and on this grid. This is a very easy calculation because it's only 1, 2, and 1, 2, 3, grids up. So it means we're about 35 meters from this helicopter, but it's going to be at 0-0. We got off of it, so it is going to be telling me that I am now 30 north, 30 east of the helicopter approximately, and we're just saying that for easy math's sake for those of you who can't see it or whatever. So it'll give us a straight across distance from the helicopter, and then it'll shoot us the new location we're at. So if we happen to be up here alone, but we don't work alone, we always work with a buddy, and it's relaying our position. We already know we're going to be at 300 and 220 on this map, we'll say. So it'll give us a location cross distance from there in a coordinate that we could apply to our instruments, guns, or anything we want to use. And as I said before, the guns are going to have some sort of tack laser or laser measuring device. They're probably going to have 2 GPSs, one mounted on the barrel, which is just the sensor, one on the butt of, or on the back of the rifle or gun, and it will probably have to be exposed, which could be problematic in some cases. But guys, we're never going to just use 2 GPS sensors to project a location. This is just for your location, how your weapon's operating and the capabilities it would have. But for the weapon itself, it would have to have tilt sensor technology, and it would have to have a mounted laser. All the schematics would have to be known when these things are installed, including on the helmet and wherever else you had the sensors located. So that's how you get your position of your balls, your 0-0-0 location, which in this case on this helicopter and or this helicopter or the middle of your land out, whatever you decide to call it, it will be 0-0. And so you will always have a distance from your 0-0 in your visual, like in a Google type glass vision that would be able to give you that information. So you're like the Terminator, right? You know how far and at what angle you are from home base so you can get there. I don't know if that can be any more straightforward, but say you get there on the first day, when these two helicopters land on your platoon, on your pontoon like grading subjects or grading platforms that you hauled in under the helicopter that you dropped after you cut your zone at a minimal amount of effort because you don't have much time because of fuel, with as much help as you needed. Let's just say you had to down 10 good trees and it took you 2 to 4 hours and everybody's beat. Nobody's going out on any night raids or anything. They're just going to be setting up camp and they're going to be killing their steer, and the border collies are going to go out and track all of your local game trails and everything like that. You're going to be plenty away distance from the enemy because the most we're going to have to be able to walk and travel to do recon and get back is only going to be 3 to 6 miles, guys, because every mile you get away, you're going to have to come back to your food and water source. However, because we're going to have the same technology in the helicopter that we do in the MRAP, you will still be able to probably even take a warm shower from your MRAP because of the LENER. And you're also going to be able to have enough fuel to go a very long distance and make it back as long as you can get to a water source. However, the hydrogen oxygen that you will make for this vehicle may not be able to be made in there because of the weight of the electrical generation equipment. However, you could if you had generators in the wheel collecting kinetic downhill energy. But you would also need to separate the water and oxygen and have it in compressed tanks. It would have to be blast safe, and that includes all your lines that have vapors or anything in them. So this could be very complex, guys. So I'm going to just say for now that you just run off the hydrogen and oxygen. So you have two containments, and it is fueled by the plant that you have in either one of these helicopters, which is represented by this little purple square here. And what does the little purple square have? Well, first of all, when you get in there, if you have free flowing water, you can install with your mini backhoe because it already knows all the location and layout of the land. It could automatically be programmed to work with automatics using GPS or even one of the laser guided robotics on top of your helicopter, which is now stationary permanently because you are on a flat steel like platoon structure that won't sink in the water because of the ground you've chosen, and so you won't have to worry about any type of flooding or anything like that. Will it be able to keep you above ground if all of a sudden it did flood everywhere and your helicopter started floating? Well, chances are no, it wouldn't, because the weight of your loadout would be too much. All it's designed to do is keep you from, like a snowshoe, keep you from going too deep and from your location changing a lot. But it doesn't matter because you're always going to have a new refreshed location if that happens from your GPS base station. So in surveying, the red dot is you. The helicopter will be now your base station. So anywhere you move on this site, if you're the surveyor, you could have the laser that's on top of the helicopter tracking to you because you have a GPS. It has a GPS. It knows your general location, and it has a spot like sensory a sensory ability on it, and which is called ATR for surveyors that know. It's automatic tracking, and all that does is it locks onto a prism that may or may not be attached to your equipment if it needs to be, but it can also get your location a lot quicker by getting into the vicinity of it because you have a GPS on you. So I'm not going to say we need a 360-degree prism on all the helmets because that might not be practical. But if you had the dual GNS, this would be able to get close to, that it could take a picture, identify you, and all those kinds of things. You guys will need an understanding of crypto technology to make all this work because all of the ammo, ammunition, and all of your loadouts will be safed out with fingerprint technology like you would see on your cell phone in order to activate them. Because let's just say you dropped into your zone and there were snipers everywhere and they were invisible to the infrared that you use to track the area and the thermal sensing, and then the two 50 caliber or like caliber machine guns that you have on the outside of that Chinook, which will be facing the outsides of your tree line when you land. let's just say these ninjas were magically able to get in there and everybody got killed but one person. You will be able to go in one of these helicopters, scan your fingerprint in a evac like situation, get anybody you want into it or onto it, and it will automatically fly and retrace its steps, meaning its location, like you pulled a string line to get there and you needed to know how you got out. If you're not a pilot, it would be able to get you out and get you back to the aircraft carrier you got off from. And the reason why I say you came from an aircraft carrier, guys, is because in particular in this situation, we're in the Amazon. A Chinook's probably not going to make it from a typical base in North America down in one flight with all this payload and be able to get back. So we're going to say that we got off some sort of carrier like vessel that could carry this in the vicinity of, like, let's say a few hundred miles, if that's how far it could travel based on its fuel. And then immediately we will be further than any enemy could be because we are going to make our fuel on location to get in and out. So nobody's going to be on your tail for long enough to get to where you're going, and they're not going to be able to stay there because they're not going to have the same food source and energy source that you have. And so we're going to assume that we are in a very remote location and all we have is that water and some land, and it's going to be the most difficult to get in. So on top of this, on each of these helicopters, you now have that survey like technology. What else can it do for you? Well, because it can take pictures, it's also going to be able to identify wildlife that is on your pad. You're going to also want to be able to set up some structures, most likely, and you're going to want them to be on probably a flat type terrain. That's why you guys have this here, and that is our. Let me just scroll. That is why we have our small dual GNS track hoe, 3D digging capabilities, and a small grader on the front of it. And that is just for pushing and moving dirt. So technically, if you were going to be here for 60 or plus days and you were going to leave this water filtration system to the locals, and it had the capability of making these fuels and stuff, it would seriously bring them to a new level, and you won't be leaving any military technology. So it will be just like digging a humanitarian well and giving people the ability to have fuel and heat. So everybody's worn out the first day. You're on location. You've cut your trees to get into this landing zone because you had to cut them manually. You're in there. You're sitting. You have this technology on both of your helicopters. They're not leaving for 60 days. You're not leaving for 60 days. So you slaughter your steer to make food. So what you're going to make into it is whatever you want to eat for the following days that's kind of fresh or whatever. I don't know if you have a deep freezer or not, but we got some Metis Indians on board, and they know how to cure meat and with a little bit of salt, and definitely with your 120-degree heat. But say we cook it all, we put it in some sort of maybe even a deep freeze. We are in the Amazon and we have enough energy to make that because we have a 10K. I'm going to say I want a 20 kVj or more watt generator, and it's going to be doing our pumping. So it's pulling from this water source, guys. And that means it's going to have to be relatively same to this relatively same elevation. That's why you don't want the distance too long, because if you pump water too hard by pulling it, you're going to boil it and nothing's going to come but air. So I hope that those specs are good enough for you, 1.5 to 2 inch, so that your line doesn't cave. It's got to be high density polyurethane piping, or however you say poly piping. Just I said polyurethane, but I believe that's more of a insulation thing. So we'll just say poly piping, so you know it's black and it's very thick. They would use it in industrial applications, and I've seen it in industrial applications. For example, if you are on a large facility that produces oil or something and they need fire protection, they're going to have high density poly piping for the fire water protection. In some cases, the reason why they're going to have that is because if the water in it ever freezes, which it shouldn't, because whoever installed it will probably get sued, but it can expand and contract a little bit without failing, unlike steel. The other thing is it's going to have almost the same weld strength as steel, and you won't have to do any traditional welding to get it together. You will be able to, however, fuse it with energy and like a bonding type substance, which is a chemical reaction based substance, not just a glue. but it would act in fusing any joints that you would have to. Hopefully you wouldn't have to, but you might have to use a little bit of rigging technology to get it to your genset filtration system and fuel production, etc. So one thing that you could do that would be an idea if you have some sort of a uh, poly blanket or material that would not let water through it or anything like that that you could put at the bottom of a reservoir. The first thing I would do on my pad was I would take my 3D digging machine, and it would be automated, but you would still need somebody in it operating. So in that case, guys, even though it has the GPS technology and that, it wouldn't have all the same technologies that every other military vehicle would have to have. For example, your MRAP, because your MRAP would probably have a 50 cal in my case with auto aiming and firing capabilities, so it can identify enemies and mess them up without even you having to pull a trigger or be aware of it, as long as it met all the automated criteria. And for that, you would need crypto. Guys, the reason why I say you need a good understanding of crypto technology is because everything you do will be based on crypto technology, whether it's authorizing weapon use. It's going to have to be on fingerprints or eye retina scanning, and you won't have time to map your DNA. So these are the next two ways that you would be able to put into your server on your helicopter what weapon was activated at what time and for what purpose, where it shot to, what the use was. Um, if you're outfitted with the infrared goggles, camera, or anything like that, it would be able to record what happened, just so if there is anything that happens that is outside of the basic engagement rule or basic rules of engagement, in which case we're going to develop them for us. But it's going to be pretty simple, guys. If you get shot at or somebody's trying to threaten your existence, you're going to defend that, and you're going to make their day, you're going to make their day very difficult with all the technology that you have. First of all, you only have so much ammunition because of your payload that you can bring in, so you won't be able to set up a gun firing practice range like I was talking about in order to record seismic. But that was just so that you would know you would be able to do it with the sensors on your gun and where the geophone sensors are that you place around your camp, just to detect any enemy movement or seismology information that you might want for resources, etc. Okay, so as things come to my mind that I haven't described, I'm gonna have to give them to you. Um, we are going to just take a quick look back to our deployment portal. There's one other thing I've talked about, and that is creating the super soldier using those laser technologies. We have the quasar bed, which is going to give us energy healing to a capability we've never known before and get rid of viruses, as I've been able to show it do for myself. I've never used the quasar bed myself. However, if I would have had the money to get one, I would have. They run anywhere between $10 and $20,000 US, but the technology, when you compile it all together, is worth a lot, much less than that. It just has to. You just need the manufacturing process, of which is already there. The demand we have. So we're going to use that quasar bed. You guys, another big problem military has had in the United States, especially in the last 10 and 15 years, is maintaining the health of soldiers. So I have needed to practice this one on my own. So in the last 2 or 3 years, I've done over 500 to 700 miles of running locally here in Red Deer, either on my treadmill or across the city regularly. So this would include like a run that's about 10 or 12 miles monthly or semi-monthly or something like that. And then a bunch of typical runs would be like 3 to 6 miles on a treadmill or a local asphalt. So what I've had to be able to do is replicate that. If I could run 10 miles in one day, could I do it the next day if I'm fully recovered using my methods? If I had the quasar technology, guys, in and what I mean is the laser infrared bed, this would have been much quicker. However, I've been able to do it without it. And the reason why is because I've had two other forms of research and technology come before me. One of them is an ultimate zapper. If you've heard of zapping, it might seem a bit hokey, but guys, it is great for viruses, and in particularly, it has been proven to be able to get rid of malaria within 4 days of treatment. We're gonna want that on top. You can research the ultimate zapper, and all it is, guys, is it sends an electrical pulse through your body using all the water and everything that's already in your body, and it can make the membrane on your cells dilate, so you take in more nutrients, get rid of more toxins, and ultimately it just oxygenates your blood cells in particularly. And if you try it, and I've let people try it on site when I've worked either industrial construction or not, and they've enjoyed it to the point where they were able to sleep better than they've ever been able to before. There's tons of testimonials on this, guys. You could look at it and try it. The way I stumbled on it is that some members of my family and the household, say like 6 or 7 years ago, I believe, may have been infected by like a gut parasite, and they wanted me to take antiparasitical medication. And after I researched a bit, I thought, there's no way I'm putting that in my body. I stumbled across something that could kill parasites using a square wave electronic frequency, and basically it just electrocutes the foreign virus or whatever it is in your body. And the reason why it can't mainly survive is just because, and the reason why the uh, antibodies that you have can survive is because they primarily live off of your own food and nervous system, the ones that you have that are good for you, and the ones that aren't attached to a robust nervous system in a similar manner. So when they get a little bit of that electric shock, they can't go. This is not like electric shock therapy that people have used in mental illness, and I've heard of it. I've seen it even be used for people that I was being hospitalized with, as I do have bipolar. And that's not something we're going to bring. It's not going to work. This thing, you don't have to feel it. It doesn't work. I got one in my bathroom. It works, but it doesn't have to hurt or anything, and you can barely feel the pulse. But it's going to help you take in nutrients and stuff easier, get you healthier and recovering faster. I've used it. People I know have used it, and it works great. It's called the Ultimate Zapper. You can find it on the internet under looking up Ultimate Zapper by Ken Pressner. He's the one that makes the best one I know of. There are others. It was originally developed and invented by a lady that went to school, I believe, in Saskatoon. Her name is Hulda Clark. You might have heard of it. It might seem hokey pokey, guys, but I've used it personally on a knee that was not working very well because of my hockey days and driving in the oil patch days. And just because I am a big guy, I'm 6'7" and I'm over 235 pounds, or in that area, the running and all that has taken its toll. So I have used that, and then I can still run well to this day at 34, better than I could even in my teens or early 20s when I was training for maybe hockey or whatever. But that's just because I did have to learn how to do some suffering. I thank David Goggins for that one, because even though I've been in running and that since I was a very young age, and self-directed running even from the age of 12, I did have to learn how to do some suffering to get through the points that were mental breaks for me in previous times. I do honestly believe, guys, if I was using these methods when I began a career pursuing hockey or anything of a physical nature, they would have worked very well. There is not a lot of information in these sports that is nutrition based and stuff. And so what you see happening is what's happening with the armed forces in the United States. And if you want to research this yourself, you can look on TED Talks and look up, I can't remember the actual name of the commander, but you would be able to find it on TED Talks. And it's really based on the state of health in the military, and based on the food and nutrition they're getting and how well the body's performing. And in the past 10, 15 plus years, the Army in particular, but I'm sure many of the branches of the military have noticed that the PTing is harder to do because of the diets of the people that are doing it. So they've had injuries, and a lot of them that cost a lot to fix, including one of the most expensive ones, and that is the hairline fracture in the top of your hip bone. It will put you down. It will hurt. and it's hard to fix through surgery, and it costs over $1 million a pop to fix. So the third thing I need besides the weather wear, the super soldier stuff, is going to be what helps the super soldier maintain his abilities. And guys, that's going to be all based on Dr. Wallach's information that he's got through over 3,000 autopsies, plus could be 9,000, whatever, autopsies on zoo animals about the number one cause of death. And guys, it's the same in humans, and it's going to be vitamin and mineral deficiency. And that's also going to include essential fatty acids, etc. So in my 14 days prior, I'm going to need my guys isolating. I'm going to be turning them to super soldiers. So they're going to be running. They're going to be getting involved. They only have 14 days because I said it's pre-World War II. They're coming from all facets. And I'm going to assume, again, when we get back to my drug policy, that they all use marijuana. We're not going to allow cocaine, and we're going to assume they need amphetamines to stay awake. So right off the back, I'm going to need a prescription for depression because they are going to be in war, and there will be times when they get down and depressed, and they won't have any fighting to do, and they're going to need to take a puff of the old reefer so that they can bond with their fellow soldiers and get the ideas they need to prepare for the following day. So that will also be a good bargaining tool with the locals if they have some really good primo marijuana on this trip. So we're going to bring that with us. Again, we have the honey because we're not going to do any fructose because it is poisonous, and that is anything that would come from high fructose corn syrup or anything like it. It's great for flavor, guys, but it's not great for your liver and your body. We are going to need glucose for all of that, so it's either going to be maple syrup if you're Canadian, and then honey if you're American, I guess. Every cell in your body can use glucose. So if we have that protein from the cow on board, we have that honey or maple syrup, you're going to be able to survive a long time with just those two things and your vitamin loadout. And Dr. Wallach is the best for vitamin loadout, and that is going to be, guys, 90 for life. And why do I say it? Because I take it myself, and it's really what's helped me to recover from all the workouts that I've done, which has been a lot of them, and that's including everything from weightlifting, push-ups, and all these things to just vast amount of running over the past few years. The thing that you have to remember about his studies and research is that he was able to get to the point where he realized that the human body needs 90 essential vitamins, minerals, and fatty acids in order to operate and build all of the material that it has in it. So for that, we're going to just take his simple mixture of the 87 minerals that he has minus the 3 fatty acids because they wouldn't mix in the solution, but you will need those, and we'll talk about how to get those right away. But the first 87 minerals and vitamins you need, there's going to have to be a prerequisite for you to be taking these, and this is why it's going to be 90 for life, because nobody will tend to have any allergies to this product because it's all minerals and stuff that you have or need. If there is any allergies that are in it, we're going to do the best we can to get you the same minerals and stuff that your body needs. Everything from lysine, vitamin C, which will stop your heart disease and veins from eroding, to selenium, which will keep your heart from shutting down under duress, especially we'll have also other vitamins that aren't included in the 95, like ubiquinol, which is basically coenzyme Q10, because you want to have a strong heart and liver in these areas, because if you do have to take amphetamines and you are on all these vitamins and you need to be able to stay awake and operate, I'm going to want to know you didn't fall asleep when you were on patrol or duty, and that's the way I'm going to be able to do it. And the only way I know you're not going to tweak out like some sort of junkie is that if you're on all these minerals and vitamins and you're taking amphetamines, you're not going to be starting to mislabel targets or use your weapons for things they're not supposed to be, because we aren't going to bring any of our boys to court. We're going to win our battle. We're going to do decisively and well. And the people at home are going to love us for it because we did it in that fashion without hurting anybody and forever creating an ally with the locals. Even those who may have formerly been an enemy, and that is basically by not having to discharge any firearms or anything at all, but have a complete show of force and capability that knows that if it were to be unleashed, that it would be an absolute massacre for them. So we're not really worried about numbers because we got enough ammo and weapons and technology that's going to do anything that'll any situation where we may be outnumbered like 30 or 40 to 1, they could converge on this location. um, the instruments are on top of the helicopters will be wired to your turrets that are on location. The turrets are pretty much going to be the guns that are on the outside of the helicopters already on initial entry, because you're going to have to make sure that zone isn't hot before you drop in your slashers to cut the trees. But we'll say we got to that point and everything. What one of your machines is going to do to the other one is also in that setup. You're going to also have your GPS sensor, but just below that, in between your distance measuring machine, you will have a 360-degree prism. And why do I say that? Well, because one machine will be able to look at the other machine and shoot that 360-degree prism and be able to stabilize all the information it's collected to that location in a very stable format. So guys, this is like the equivalent of being able to tie your LiDAR, all the trees and everything in that you're going to experience into a virtual environment that would be replicated in your helmet, just like you would on a construction site. The only difference is when you're on a construction site, it's usually operating off of a base station that has corrections, so it will hop around a little bit, and it's not accurate enough for you to build material to. Although you can clearly see the layout of them, in some cases it will be accurate enough. Like for example, if you were going to put in piles, etc., you would be able to do that with the helmet. I wouldn't recommend it because there's a few different things that you would have to be aware of, like getting the offset information for somebody to wear a helmet. But if you wanted to use a helmet, for example, to say go into a location where you were going to build a large central processing facility, you could walk through with it and know where everything's going to go very easily. So I do recommend it for management, quality control, safety, and stuff like that to foresee issues. But as for building to it, you're going to want this stabilized version of the program working in the mask. So it's going to have another dedicated set of numbers that it relays to you, and those are going to be based off of our total station hitting this prism. So we have those two locations, 1 and 2, helicopters 1 and 2. One or the other or both could sight each other on this prism, and then so it would be able to broadcast a location that is much more stable in your helmet. So all the LiDAR information that you've already collected, you're in there, you're day one, you're set up, you got your turrets watching the tree line, you don't feel unsafe at all. The locals are kind of coming in, checking you out and your equipment, and you know what, everything's safe, no weapons have been armed. You basically slaughter your steer. You can build a fire, I guess, if you want, but you would have cooking capabilities with your machine. So your first shift's going to be long. It's going to be maybe a first 24 hours. You're going to be up a lot, getting from that aircraft carrier into the location with these helicopters. So now you got your helmets, and now you have a base position on each of these helicopters. So what does that mean? Well, anything that has to run off a base that's going to be automated, for example, in this case, our small dual GNS track hoe with 3D digging, it's going to be able to move around on location with the assistance of just the GPSs, and it's going to have access to the LiDAR that you've already taken to scan the location, and it'll just find a best fit location to maybe make a small pad for a tent that you can set up. Tent's probably going to be the most practical thing. It will keep you out of the water, and if you cut the grade properly and slope it, which the machine will all be doing on its own, other than the fact that it will have an operator who can see what it's doing and how it's doing it. That guy will be the guy that lays out the base for camp, and camp could be close to this our basically what you would call in our scenario our central processing facility, meaning it's giving us our food and our water. In order to do that, it's got the piping going, guys. That's the first thing you have to lay out to your water source, unless you're drilling in some other sort of like desert location and you just need to hit water down. I don't know what the details of that would be. If you were in a desert location, obviously you could bring more equipment with other helicopters if you had to get water down. But that's going to give you the ability to give your medical clean water, and they're going to want clean water. And so for your water filtration system, guys, There can be some big systems that handle a lot of water. And for example, if you were like desalinating because you were near seawater, you're going to need a system that is highly efficient and doesn't weigh a lot. A lot of the piping in the modern desalination technology would be plastic or poly of some sort. We're not going to desalinate because we have a fresh water source. So you will have to think about desalination, but not in this situation. But if you're close to ports, warm water, and you didn't have the ability to drill for it, you could think of desalination. But ultimately, we are thinking more like double reverse osmosis. If that system's too big to fit in there, we're gonna still probably want it if we could, but if we can't, based on design, the front end engineering and design, we're gonna go with something that has like a ceramic filter that was designed ages ago. And guys, if you have a ceramic filter and you pump water through it, it will get rid of almost everything you possibly could want to get rid of and clean your water. So the ceramic filter, combined maybe with a double reverse osmosis, whatever it is, you could have plumbing set up. As soon as you prime your LE-NER and turn it on, it's going to have 120 degree water in it. So all you have to do is have that connected to your plumbing and water source that you're going to use. So you would need another tank so you would be able to have a hot shower the first day you get in there. And guys, you're going to want a hot shower any and wherever you are. So we're just going to say that you get that set up the first day. Say you run out your poly piping to the water source. The reason why I have piping and electrical on here is because, let's just say, for example, you guys are able to put in a small in this area, you're able to put in a small generator like spool. It would be, well, it's going to be like a little whirlpool that works off of a small causeway of water that converts it into electricity. The amount of electricity you could run from one of these small generators, guys, which will have to be cut out in the bank by your 3D digging machine. You might need a little limestone to either make concrete, or you have some prefab concrete. I don't know. As far as I know, you'd be able to probably just install the prefabbed concrete structure into this area, and you'll be wanting to think of that if you ever end up with runway capabilities or the ability to make a larger camp where you could run approximately like 60 homes off the electricity from this. I don't know how permanent it can be, whether you leave it to the locals or not. I would recommend doing it because it'll be an excellent source of electricity when your power generator that you bring with you is gone. The power generator you bring will just be so that you could pump water and put it into your tanks right away, and being able to start turning it into fuel, so that like in the most minimal amount of time, if say you have enough fuel in your copter that you can get off right away, but you need more to get back to where you're coming from, that it would take a small amount of time to be able to top up with fuel and get out of there if that was the case. But in this case, we're going to say we're staying the full 60 days till conflict is resolved. So you have water right away, and you have fuel, and it's being made through electricity. So things you'll have to know is you're going to need a large vat that has specific types of steel in it that when electrified will create your hydrogen and oxygen that take. The hydrogen and oxygen will then have to be separated into two other tanks, where you're going to have your hydrogen for fuel and oxygen for fuel mixture. Or in any case, you would be able to use the oxygen because it would be clean enough for medical purposes if it was needed. You'd also be able to make other things, perhaps that would give you disinfectants or anything like that for for example, if you made like hydrogen peroxide somehow from it, and the locals needed to disinfect it for something, or maybe you made something else with it that was similar, or for your medical staff. So as I'm jumping back and forth, as I get bored, I will probably switch subjects, but right now just sticking to that electrical generation system. That's why it says piping and electrical, but initially all you'll need is piping to pull water, because you will have electrical generating power with your 10K, or I'd say in my case, what I'd like is like a 20 kV generator. uh, for for creating power that will run all my site, my tent, my water, and cook my food and all these kinds of things just on location. Um, okay, so now we got our tent set up. It's already had the location smoothed out by our small backhoe, and everybody joins hands as they set up the tent. We got somebody cooking our beef. The dogs are out tracking trails and mapping them, looking for hazards, other animals. They're on stand down duty, meaning if they see anything that gets them into trouble, they're coming back and maybe telling you about it. And the camera that's on them will identify what the problem is so you won't have a problem needing to know. This is all going to be done in your hub. So, and it's going to be sent to whoever's closest. However you guys organize the pathway of your information is going to be completely up to you, and in a military sense it's going to be totally classified. So this is just for a fantasy novel. You guys, there won't be very many pages to get through to do this. But there's going to be quite a bit of talking because it is an audiobook. So soon I will kind of delete everything that's on the side as I cover it, and then we'll move on to the next subject. The map will probably stay the same so that you guys can stay current on what's happening. So the thing is this electrical generation system, if you were to install it, most of the stuff you would be able to carry with the machine to get over there, whether it's some prefab concrete and then the whirlpool generator itself. Like I said, it would be able to power a big camp, but off the bat you will be able to use your own generator, and that generator will have to make enough electricity to make fuel, clean water, and then also you got your hydrogen and oxygen. uh the great part about having LENER, you're going to have it in two places, and it's going to either be at this location that came off the helicopter, or it's on the helicopter, depending on how whether you leave it or not. It operates for a very long time, and it uses a very small amount of nickel as a catalyst. I'm supposing you guys would have to research it all for yourself, but it is documented on online, YouTube, everywhere that LENR does exist. It is cold fusion for those of you who don't know. So with that kind of technology, you would be able to make this sustainable because the 120 degree water can be applied to any of your processes. It's going to also be on your MRAP. And the reason why is because do you guys go do some sort of a night raid or visitation maybe with locals, and you're way out there, and like, guys, maybe you got like a portable shower going off the side of it, so you got a little bit of water on board. You definitely have hydrogen, oxygen, and they are going to be liquefied, and they are going to be so they will be compressed. You guys, to do this all in any situation where you got to compress, it's going to take a lot of energy. So the other thing that you're going to have on here, which I may or may not mention with your generation system, would be filtration. We talked about that, the ceramic, etc. Or double reverse osmosis, whatever keeps you drinking out of the shower and out of your little reservoir that you have for fire protection, which will be able to be dug by your machine. So I'm going to say you want some sort of a thick poly material that you could lay out in a small reservoir that you dig, so that when you bring this water in at high pressure, whether you pump or push it, and that just depends whoever wants to run a pump to the water line or just pull it in with your high density poly piping. I'm going to pull mine, I assume, because I'm going to be within 100 meters or closer, and it's not going to boil on me. My line won't collapse because of the material that it is. So it would be maybe problematic for everybody to roll this out and pull some cable, but it's not different that you would see on an industrial site if you had to pull cable through racks. So and these guys are tough, and they're gonna be able to get it in there. So you got your piping, it's bringing in your water, you're turning it into fuel, you're turning it into clean water, and a few other things. But you also have that capability on your vehicle. The other thing that your generator is going to be attached to immediately off the bat is it's going to have a light plant on it, just like you see lots of generators running on sites around where I've worked a lot, whether it's Alberta and beyond. And that's going to keep you with lights 24 hours. So If your light plant generation system, all that has absolutely no water and you can't turn it on, you will need a little bit of fuel to start it initially to get electricity going, and enough so that you can create enough fuel to get it back into the machine and continue creating electricity and fuel to the point where you have enough to power your helicopters and get out of there. This is possible. You're going to need a few empty fuel tanks on the way, but that's still better than managing POL, guys, because you're going to need a lot of petroleum on land to do your night raids if that's what you're doing, or visit locals. And your MRAP's going to be able to do all that. And same with your helicopters. So because we want our helicopters to stay on this position the entire time and broadcast and monitor the turrets and whatever we have on location to safe it out and protect it, we are going to assume that some way we are going to get a path out of here, and it is just going to be either a path we create with a machine, which would be hard in this situation. So if we created the runway, we would then have a cat that would be capable of creating some sort of road. We'll put it in brown, but let's just say it was an old mining road and it was a cat cut and it existed in the last, several decades, so it's not too overgrown. We have a way out on our MRAP to get at least to some sort of abandoned mining or forestry road. If that doesn't exist, guys, there's not going to be a way to cut really through the Amazon jungle and get across rivers, lakes, build bridges, and all this kind of stuff. I'm just assuming for the scenario it would be practical, but we did choose a very difficult scenario. But say it wasn't, and you could cut and make a road that would be accessible by your all-terrain vehicles, in this case the MRAP. The reason why we want MRAP, guys, is because if we hit IEDs and they explode, we're going to want to be able to get through them. That means all our fuel tanks, our LENER, and anything on board is going to have to be blast proof. You're going to have to go through that on your own. MRAPs have already been developed, and all that technology I can't really get into, but it's basically you're going to need a blast proof technology if you want to have the LENR on there, and you're going to want to be using hydrogen and oxygen as fuel sources along with the steam to boost it. This will make you incredibly efficient. So all you'll need to be able to do is go up this road and get back to your water source to refuel or recharge or resupply, because you'll always try and maintain the amount of fuel in the vehicle you need to get where you need to go. But also, as you're burning that fuel, which is a high octane, high energy fuel, in your wheels or your drivetrain system, you would have an electrical generation system that would create drag. So you only get it to create drag when you're going downhill and collecting kinetic energy. So whenever your foot's off the gas, you'll have some drag, but it's going to be creating fuel for you at the same time. Because you have 120 degree water, you're able to put steam to your fuel and get more explosive power from it, mainly the hydrogen. And you could also add in oxygen at a certain point that you also be getting from the fuel source to reburn it. Now, why are we separating the hydrogen and oxygen through an electrical process? If we just put them back together, won't we lose energy? You guys are going to have to check all the coefficients. I've done enough research to know that I believe it would work. The big problem is the blast proof part. It can be done, though, if you have enough research, because there are a lot of vehicles in military that carry very highly volatile fuels. So you're going to have to adhere to all your HSE for those. All I'm saying, guys, is if we got water and we got electricity, then we're good to go. And if we have LENER, as in the cold fusion, it's going to help us enough that we won't have to get any POL from our aircraft carrier, which we're coming in on, or any other source for a very long time. In which case we do need supplies, and in those three areas, supplies, whether we have this runway or the drop location. And as I said before, we're going to be using the quadcopter drop location because we want to get our stuff fast. And if it comes in on a parachute, it could be dropped anywhere in, let's say, a few mile zone, or 100 or few to 10 mile zone, we'll say. And that's not going to work for us, because then we're going to have to hump it or drive it back to location. So if you have a big pallet that drops out of the back of a C-130 Hercules, for example, and on the top of that pallet there is a small to mid-sized quad helicopter that could navigate and carry that load, it would just have to basically cut the parachute at some point and take over control of the load without getting pulled down in a real big jolt. And so you would need the combination of the parachute, etc. If you had to send in personnel parachuting, they could get to this base and it would be safed out and they would have all the information they need on it, and they would already be basically accepted onto the location because they have the same sensory technology in their loadouts and weapons. However, they would just come in on the airfield, or you could send and retrieve them with the Chinook. But if you wanted to get them there from anywhere in the world, let's just say you're on the opposite side of the world of your 00, which means you're going to be roughly, not doing the math very well in my head because I'm forgetting some of the information I need, like the size of the equator and that, and not with having to look it up. We're going to just say that it is the diameter of the Earth, whatever that is. And they're going to have to get to where you're at in 18 hours and then get on the ground and into control very quick. So for that, we're going with what my brother was in. That's the 82nd Airborne. That's the paratroopers. Guys, paratroopers were invented really by the Nazis and copied by Churchill. And what it was a way to get infantry into an area very quickly and take it over. It was part of their warfare. The other thing that you're going to have to consider is Blitzkrieg, where they went through the Ardennes Forest and they didn't march in traditional columns, but they were in columns in the Blitzkrieg form, which means they were all behind each other instead of beside each other like in a traditional chess match. So a lot of that stuff will be helpful for you to utilize if you understand the history of war. At this point, I have to start getting this tying back to some survey terminology so that all of you guys can use it. So anything on site we know can be laid out or as built from these two base locations and the laser EDMs that are on top of them under the GPS sensor and under a 360-degree prism. So one of these will be broadcasting all of the information about location in a very finite form, and that'll be the location of the prism and the total station's information. And then the rest of your information will be coming from GPS satellites, and it'll be relayed through your base station to you and correcting your position. And under canopy, guys, it's not going to be as high as you think, but we'll just say your 2D quality is typically going to be the size of one of these squares. A tenth of one of these squares, so a meter by a meter. In these cases, these squares are 10 meters by 10 meters. So is going to be a very small area. If you're in open countries, for example, you get up to the north here and there's a large Serengeti and there's low-lying bush and stuff, and maybe perhaps, I don't know why you didn't choose that location in the first place, but say you didn't, you would be able to get sub-centimeter quality with your GPS. The further you get away, it is going to diminish a little bit. But based on my experience in seismic, if you take a large balloon and you fill it with your radio and maybe you use the hydrogen because you want it to float, but it is going to be very explosive, so you might not want that either. But say you just had helium and you floated a balloon here up above your camp, above the canopy, and you had a radio repeater or just the radio for one of these GPSs that's going to act as your base station for all your GNS equipment, then what it's going to do is repeat the signal, and whether you're down in a valley or up high, you're generally going to be able to get that signal and correction from like 20 miles or more, so depending on how high you put this radio. And so I have seen it done, like even someone that I worked with that worked in Texas did the same method. They put their radio in a balloon, filled it with helium, and stuck it like below aerial requirements in the sky. So I don't know if it was like 100 feet or 30 feet or whatever, but they just put their lithium battery in there. So all they had to do is tie a rope to it and then it would work. In this case, you might want a communications port cable going up the rope into it, keeping it going day after day, and then just working off the electricity you have from the plant. So That repeater or radio setup will get you very far away from your base and give you corrections. However, if you get too far, you still will be having like about a 5 meter quality on your GPSs. So everything could get a little bit different in terms of the use of your weapons or automatic tracking weapons. They won't be really useful anymore because they won't be able to get the precise locations of what they need. For example, our 50 cal mounted might have a GPS sensor on the front and back and then it'll have laser and tilt sensors that override certain calculations, and all this technology is available. But basically, you would be able to fire at an enemy remotely and be able to get it into a good general location by having two sensors on the gun if they were bumping around sub-centimeter quality. However, your azimuth might not be too tight from these two sensors on the gun, so we would have to have laser and tilt sensors to override certain calculations. That all could be done. How and when, I'm not going to describe because, again, it's just too much information to get out on the internet. But for some of you guys that are thinkers and think ahead, you could probably see how this could be done. But all I'm saying is if you get too far away from this radio location and you're relying on GPS sensors to do it at all, you're going to either need a repeater on your vehicle that can repeat this signal. And remember, the farther you get away, it's going to be a little bit less accurate. So you're going to have to watch out for that. But for the most part, you're going to be really good for miles with the radio going up in that location. And those are things you're going to have to decide in the original drop zone creation of your forward operating base. Okay, I think I've covered enough of the information on here. Like I said, the two special ops with diving training are going to have to do with anything with the river. And so, for example, say you had an enemy that was upriver and he wanted to poison your water source, and he didn't know, and he knew about this line or whatever. You might have to booby trap up a river, or you might have to have some sort of a detection device in the water that can measure toxicity and other things. I would just avoid that altogether and just assume you're going to have the worst sulfur water that's coming in. You can't drink or use or anything, and you're going to have to treat it in this system here. We're going to assume it has beaver fever, malaria, and anything else, but in it, it's got fuel and it's got clean water and all these things. And because you're highly adaptable, you're going to be able to make it work. I believe you can. Okay, so one of the last things that might have been glaring on your screen is this resolve a genocidal conflict. The reason why I chose resolve a genocidal conflict, guys, is because it's the most controversial conflict that you would probably have to solve with the 3-block war while you're doing humanitarian aid for someone who you may or may not know could be your enemy. Getting into mid-intensity conflict with somebody that you may or may not know is your enemy. But when it comes to mid-intensity conflict, it's going to have to be decisive about who your enemy is, because otherwise it will be peacekeeping, because you're trying to keep locals from going against other minorities that may not be able to defend themselves. So in all intents and purposes, we are basically playing Big Brother, helping out little brother that can't defend himself because he is being he is either being murdered basically through a genocidal kind of pact from some faction that has the weapons and abilities to do it. And because the Métis Nation had signed the genocide pact, which all other nations have signed, and usually in the Western world and other places, meaning that if they do find that genocide is happening, or they're aware of it, then they are obligated to fight against it and deter it. And so there has been a lot of major nations that have avoided calling genocide when it's happened, but the Métis militia doesn't give a shit, because we are not other nations. We are the sons and daughters of Gabriel Dumont's nation, and he was one of the best military generals in history, in my opinion, other than Alexander the Great, which is a hard thing to say. But guys, if he did not have a religious despot political figure like Rial running the show, Dumont would have been able to really establish the Métis as a nation that would be in existence today. However, in my opinion, and if you read the book on Louis Riel and Gabriel Dumont, the two primary political and military figures of the Métis, basically resistance or provisional government that was recognized by Canada, one thing you'll know is that Gabriel Dumont was a very, very smart general and tactician when it came to war, but he also had to rely on a political figure that was very unreliable and did a lot of sporadic things that were outside the elements of their plan or their ability to kind of maintain a nation. So that gets back to the loyal dissent factor, which you could learn from Chuck Krulak and that Mattis most likely used with Trump, in my opinion. And that is, guys, loyalty is not blindly following anybody in a compulsory manner just because they are above you. And nobody in the Métis militia will do that, because we will call you on your bullshit as soon as we hear it. And it seems like already I've been giving you a lot of bullshit, and so I don't want you to call me on it. So I hope you get through this video. I hope I can get through it too. It's taking some time. So the other side of that loyal dissent is that if somebody is in a position to lead and they are doing well, it is your responsibility and obligation to let them know there's a better way of doing something. And if they do not, and if they are not interested in that information, then you already know some way or another they're compromised, and it could just be by a bad attitude. So you're not obligated to really follow them. And so mutiny is a possibility on this this deployment, but guys, it's all going to be agreed upon before you deploy, in your mission, in your training, in your ethos, whatever it is. So we're trying to make up as much as that to make it realistic. So to get back to surveying, because I got to relate it to surveying, you got your water source. Now, let's just say you guys are SAGD, like I have worked on steam assisted gravitational drainage in the Fort McMurray region. You would know that pumping water under the ground to get oil is not really the best way of getting it. And guys, I could trump that right now with one example. Just go to your local neighborhood kid in Canada that has legal weed, and maybe he is over the age of 18. Well, for sure he is, because that would be the legal age, depending on if it's 19 in the area. If he wants to make a oil with any type of budded material like marijuana, he's going to have to apply a fuel to it that will dissolve all the oil, get it out and away from the bud so you could use it for something else. And it's going to have to be a solvent that can dissolve something that is already a hard caked on kind of oil, which would be like bitumen in our example. And then he's gonna have to be able to recover the fuel, dissolve it, get the bitumen, and maybe upgrade it again with a solvent for transport, or just upgrade it into the sweet crude or whatever it's gonna be, and transport it via train or pipeline to an upgrader who could turn it into all the products we know and love, or fuels. So with that being said, things you need to know about seismic if you're recording it in any facet, because this is our first main form of surveying, is I've already talked about the frequencies and how you find things at extreme depth and that are shallow. So because I did do exploration in the oil sands south of Fort McMurray, I would tell you it's high frequency charges for the shallow stuff, guys. It's typically in riverbed formations. So if you've seen a riverbed and you live anywhere in like North America or anywhere there's a good sized river, you'll notice that all the land that's adjacent to it is much higher and out of the cavity of the river, and yet it may have been the same at one point before the river formed. So I'm just assuming that there was some dry land, the river formed because of all the rain that came, and it had to find the easiest place to travel, which is the lowest lying place. But because all the topsoil and sediment is very, in some cases, a lot of it's dissolvable or can be transported down the river system back into the ocean, it will have cut a large cavern some way or another, whether you look at the Grand Canyon, which could be hundreds of thousands of years old, or you look at a more modern river that may not be as old, but excuse me, may not be as old, but you would see this kind of same pattern. So if you look at your river that's in your local municipality while it is at low, you're going to see lots of rock and stuff, and it's probably going to be on some sort of a clay bed that is relatively waterproof. And I say relatively because it holds a large body of water, and it's relatively waterproof, likely on some sort of limestone or clay or whatever it happens to be. I'm not entirely sure. I'm not a geologist, but I could tell you it holds a lot of water, and it's generally waterproofed because the river flows down it and it doesn't continue to keep going down. So it's kind of found its like last little corridor, and then you'll notice up on the banks or coulees that are around it, a lot of the topsoil and everything that originally was there would have eroded away, leaving all that rock to gather up in the bottom. So anything you need to know about SAGD is that generally south of Fort McMurray, you're going to have rivers underground, very deep underground, but not deep enough that you can't drill to them and harvest, but deep enough that you wouldn't be able to take all the top off and mine them and mine the bitumen the same way you would north of town. So, now that you know you have a natural riverbed, take that riverbed in your town and fill it with sand and bitumen, okay? So basically that is all dead animal matter that is turned into bitumen. I've learned this, guys, from geologists that I've worked with up in Fort McMurray and in the area, and one thing I tell you is all of the mining north of town, if it doesn't get done, eventually the oil will decay and dissipate and be not worth anything because the amount of clay that was above it at one time has fractured and opened, and it's just kind of like leaving the marijuana out on the counter in the sunlight. Eventually it won't really do much for you because it dissipates over time. Whereas south of town, you could actually do some damage, make some money, and recover a lot of bitumen if you were to take your only source, the water source, like in this case, turn it into hydrogen fuel that you would be able to pump into the bitumen and recover it at the end of the riverbed. Guys, the glorious thing about this is it shouldn't make any caverns any more than high pressure steam would. The other thing is it is an actual solvent, and the closest technology being used to it would be high pressure polymer injection for recovering bitumen oil, which has been used in other places. I wouldn't want to go high pressure polymer just because of the amount of volumes that you can get back, but it is also doable, and as I believe more profitable or sustainable in some cases. But nevertheless, you have to understand that if you're pumping high pressure, very high concentrated amounts of high temperature steam into the ground, you're going to have virtually the same problems you're going to have if it was a solvent, but even less, because it will be able to dissolve all that bitumen and bring it down into the river formation where you could recover it at the end of the river. However, when you're using high pressure steam, it can go in any and all directions that steam would want to go if it was high pressured. So then you have caverning, and then you also have compression of the outside of your formation from the steam, which is going to make it harder for it to infiltrate and grab. So if you just had the LENR technology where you had 120 degree hydrogen fluid going into your formation, and you had a way of neutralizing it at the end of the riverbed, you would have an incredible amount of bitumen that you could recover. And then you could either upgrade or you could transport it with like a naphtha, which would be similar to your hydrogen. The reason why, you guys, this has to be done to revitalize the whole SAGD process is because I happen to know that when you're getting water back with bitumen in it in a typical SAGD operation, it is only going to be roughly like 1% bitumen and 99% water. So if you're talking about recovering anything in the billions, and that's how many billions of barrels of oil are in these formations, which is a lot. You got to remember the Fort McMurray region has more proven oil reserves than a lot of places in the world. It's just the recovery methods that make it hard, and the way that you have it treated. So if it was my plant and all that, and I could do it, first of all, you're going to have some regulations that you meet with local authorities based on what you're allowed to put in the ground and what it's doing. However, in my mind, if you're dissolving bitumen already with high pressure steam and water, it can still get into any waterway, and whether it's filtered by the sand or not, it could contaminate the waterway. So you might be doing that already. But the problem is you don't really have enough water to get enough bitumen back, because there has been people, and I repeat, there's been people that have been sent to jail for running projects in the area of the oil sands that this is, for rediverting water sources that belong to locals, especially the native Indians to that area. So you do not want to be taking water that isn't yours. But if you could turn it into a high yield solvent, get it back and neutralize it, and also be putting oxygen into the air, cleaning the water, putting oxygen back into the water. Because north of town, guys, the Athabasca, well, in all cases, there is a continental divide there. The Athabasca will flow north. And so what's happening is there is plants north of town that actually pull water out of the Athabasca and they put it back in. And as I've learned from an engineer that I went on a date with, the water is actually cleaner when they put it back into the river. So what is the problem really? Well, fish need oxygen, and you got to oxygenate that water somehow or another, because it's been going through babbling brooks and rocks the whole way on its trip. And so when you deoxygenate the river source, or you refine any of the water in your system, whether you put it back cleaner or not, all the microbacteria, or sorry, all the microbiological material that the fish would need to eat or whatever, or if there was a fish in it, it's dead. And I'm sure you're not sucking fish into your water recycling process, but I'm just saying, if you were, it wouldn't be faring too well, especially because it probably reached a very high heat at some point before you put it back, which means you're not going to have very much oxygen in it. So that to me would explain a lot of what's happening with any type of contamination. So, like I said, if you're going SAGD, you could switch a plant over to using a heated solvent that would get way more bitumen back, so you wouldn't have to buy bitumen to run your upgrader, as is in the case of some people or some outfits. I hope I've described enough of that for you that it makes sense, but you guys could take it from there, and just use the natural riverbed and go from there. Oh, another thing that would help you guys, if you're in Alberta and you were in a SAGD operation and you decided to go this route where you drilled the wells into the oil formations in the riverbeds, and then you put solvent in them, and you had to recover the solvent at the end of the riverbed or wherever else it ventured to go. What you would also need to do is what you would also need to do is track that solvent, and the way you do it is just by continually having those seismic recording devices set up on your project all the time. Could people take them or steal them? I guess you would have to lock out your land, but you would never have to stall them again. And in doing the geophone recording process, just by law, you're supposed to be tracking the steam and all those kinds of things in case of caverning over the next 40 years anyways, which is why a lot of your flow lines are above ground with helical piles under them, so that you could dismantle the plant when it becomes inferior. Uh, in which case you would all probably just have your flow lines underground anyways. I don't see why it'd be harder to reclaim those if they're only going so far anyways, and you're never going to be able to get the casing and stuff out from the drilling anyways. So a tool that you could use if you wanted to punch a lot of holes and not have to worry about the quality of the formation. Some of you consultants from Alberta might know that if you use a coil tubing single rig, like in that they have in a litter of yards laying around, from everything from service to, like I said, a single shallow gas drilling rig, like a coil tubing rig, you could easily employ those into that system to just punch into that formation as many spots as you're able to. In a lot of places, you would have existing lease sites already built for the core holes. If you do half the amount of the core holes and then you do seismic for the other half, it's great. Just make sure your parameters on your seismic are proper, meaning you're using the proper frequency of charge and distance apart from shot points and recording points, namely the receiver points, because you're not going to want to waste $10 million like some people in the oil sands have, and just create a big picture that nobody could read because it was too fuzzy and out of date, or not out of date, but just unable to read. So that could be a big cost, and the big cost is basically you'd have to do your seismic over again. And other reasons you would have to is if you had a lot of your shot points move and you're unable to track them and they weren't reshot, you're going to have a lot of pictures that you're not going to be able to assign to a location or an origin point for a source, and then basically piece it together after the recording's done. So in short, you're going to take a really big picture into the ground, and in order to do it, you won't want to have to do a lot of surveying. So you're going to get rid of half of your survey on your grid right now, and that's going to be the grid we're going to use here if it was a seismic project. So we've already described some of the ways we would do that, but half of your half of your survey could go, because all your survey receiver points now, guys, you could put in with a geophone that has the GPS mounted on the top, so it has a continual location very accurately, and you won't have to survey those points in. Whether you install them with a surveyor or a line crew member, it's up to you, or both. I just recommend in wildlife zones having some sort of guide with that crew that can get you in and out, because there's countless times, guys, I've been surveying in the field in places that I could never get out of or know how to get out of. And typically helicopters do not fly at night. So if you cannot get to the helipad quick enough, then you're going to be outside overnight, and that's where there's bears and 200-pound wolves and stuff, and you're not going to want to have to mess with any of that. So you're going to want to have the guide, and I've talked about that before. It is just an idea that I have, but if I was doing it all over again, I had to go to northern BC to survey where there's grizzly bears, and being the fact that I'm a Metis Indian and that Western Canada is my ancestral land, I would just choose to carry a 12 gauge shotgun with shot and slug combo, so I could put them down and stop them as fast as I can. That's just the way I would do it. Again, I'm retired. I'm not surveying again anymore in these capacities, so I just want to spill all my secrets. Some of them are theoretical, but a lot of them are real. And one of them is you could get rid of half the surveying for all your receiver points, because you would be able to have the GPS installed on the geophone, and they could stay there for as long as you want to track any of the steam and production. And so in most seismic projects, you would not leave these there. But in the case of SAGD switching over to a solvent like material, you guys, I would want to be able to track the density of my fuel and bitumen wherever it is, wherever it's pooling, wherever I have to drill to recover it. Now, in a lot of places where they might have electrical submersible pumps, it would be able to retrieve the solvent and bitumen, and it would be in a higher concentration and higher flowing than if it was steam and water. Guys, I hope I've explained this enough to you, because I do got to get on to the next subject, but the seismic and everything is pretty much done. All you'd have to do is be able to hand that information over to the legal outfit that's going to be doing the leases for the drilling, and you would have to make the requirements for how many leases you could have in what area. In case of SAGD, most of those places have core hole leases that were already drilled, and they know where and when they could get the oil. All I can say is, guys, you want to be very finite in how you shoot your project, because the data you're going to want is going to have to be accurate. And the reason why I say that is because in my career doing legal oil field, we would just go out with a consultant and spot the wells in the quarter section that we were working in, or the LSD, whether it's a smaller part of the quarter section. And we would basically spot them on the following criteria, and it was provided by the consultant, and that was basically going to be the lay of the rig and how he wanted it to access in there. So you're going to have things like access road, and on the access road you might have workspace incorporated, which would be temporary on the access road or permanent, depending on whether you stipulated it in your lease or not. But basically you're going to be thinking pipeline access road common is going to be 15 meters wide. Any other workspace, you're going to add 10 or 15 meters to certain portions of that access. The lease itself is going to have to be able to fit the rig. In our case, if we were just using a bunch of out-of-work rigs, like a single coiling tubing rig that can do shallow gas, it would be perfect for SAGD, because even when you do shallow gas with a coil tubing rig that is a single, guys, it is known that a conventional rig will outperform a well that is drilled by a coil tubing rig. But in this case, you're drilling into bitumen, and so we don't care if it is all messed up in the formation of your or in your drilling pattern downhole, because you're going to be pumping solvent into it, and it'll just permeate through all of that anyways. And there's ways you get around that, probably with some fracking, etc. But we're not even going to get into that. We're just going to stick to the surveying part of it. And now we're in kind of the legal side of it, where you're handing over your data. So in my experience, like I said, the consultant just kind of placed the wells he was drilling, and in this case the application would be southern Alberta, where we were drilling for shallow gas, and he kind of just put them where he wanted to. And that happens in a lot of cases without referring to the geophysical data or the seismic or anything. So what he had and knew in his mind, I don't know, but in my mind, I need that picture underground to tie into where I'm going to drill. And so that means relaying the area of these geophones that have the GPSs on them. Somehow you're going to have to get that picture and that information to your legal surveyors, so that when they put their wells in, it's going to be at the formation in the depths, like the beginning and end of the hole that they want, to be able to start putting solvent in that hole and not missing it. Now, in the case of a large riverbed filled with oil sands bitumen, like is south of town, you would find in some areas that has billions of barrels of bitumen in it, you're not going to have a problem where you walk 10 feet, drill another well, and it doesn't produce at all when the one that you have does. Now, if you're on the extents of the riverbed, yeah, that could happen and you miss the formation entirely. And in some cases, core holes will be instructed to do that, just so they know that they're finding what they want and not finding what they don't want, etc., or vice versa. So what you'll want to know about that is, if you were looking for a deep natural gas with a large triple rig, say out in the Rocky Mountains, like in Dawson Creek or something in the north, and you were going really deep, but you could go 10 feet and have the highest producing well in the world, and then go another 10 feet and hit nothing. That's what I've been told by professionals in the seismic industry that have been in the industry for 30 or 40 years or more. And I kind of appreciate what they say, because they seem to know a lot and have either put Cheerios on my table or vice versa. So what that means, guys, is in the SAGD situation, you might not miss your formation and you might still be able to recover everything. All I'm saying is a single coil tuber would be a great way to punch holes in this formation, get your solvent in, get it out at the end of riverbed, and be able to get a lot of bitumen back. Definitely a higher percentage that you would be able to get if it was in water, and oil and water just don't typically mix. So I'm going to go with the solvent if I had the choice. And it's going to have to be able to be neutralized or recovered and not affect the water table that locals might be drinking out of. And if you are already steaming bitumen and it's getting into the water table, then you're already polluting it anyways. And let's be honest, guys, you do not have enough water to get all of the bitumen that is south of town out of there, because there's not enough water in Alberta to get it all out if you're only getting it back 1% bitumen. So I mean, that's a rough calculation and it's hyperbole, but I'm just gonna say that's kind of how I would go with it. So you have to be able to track that over the years through seismic. So you would have these receiver points eliminated from survey. So all you have to do is shoot the shot points. And the way you get that, guys, is you give back the seismic surveyor something he hasn't had for a long time, and that is a survey rod with his GPS on it, because he's going to have to do some sort of physical marker, whether it's leave a lath, a stake, or something at his shot point, so that when it's done, you can verify the location a lot easier. Now, so for these large formations, maybe it is acceptable to be about a few meters, but the thing is, you can always be under a meter with 2D quality and never take more than a few minutes to get that shot and move on to the next one. So I'll tell you how you do it. You switch your GPSs over to 2D quality only, because you already have a LiDAR. So any of the GPSs in my situation on my location, they will be operating with 3D quality, but I'm only going to really pay attention to the 2D where it matters, because I already have a LiDAR of the whole layout of our land, where our forward operating base is going and stuff. So anytime there's an elevation spike or anything, it's going to be negated, because we're going to tie it to the LiDAR. So what that means is you're always going to have really tight elevations when you go underground, because you shot the surface of the earth with a laser from an aerial vehicle that had less than centimeter quality because it's up in the air, and it ends up so that you're anywhere light can pass that it hits the ground, you're usually going to be within like a few inches or like a decimeter, and in my case 10 centimeters of the actual elevation. Whereas when you use a GPS under canopy, your elevation can spike by meters, right? So it'll be helpful to you to have the LiDAR and all these kinds of stuff, which is pretty common in all oil field now already in Western Canada, or seismic projects, at least for the last quite a number of years. So because your data is allowed to be a little bit more out, because it's such a large formation and you don't have to hit it on right on the head like a hammer on a nail to get it. We're going to say you can go quick and dirty with a lot of the single coil tubers for the steam injection. Use the existing directional wells that take up most of the formation. Electrical submersible pumps would get it out easily. Right now, in a lot of situations, they would be destroyed because it's like sucking concrete through a straw. So you're going to have to track all that. There is a chance that you would have some sort of caverning, and so it's going to matter where you put your CPF and all that kind of stuff. You could look into it a little bit further, but I just want to get the survey out of the way. So now that it's over to your legal, and we're going to assume that you just tied to ASCMs, which are just Alberta Survey Control markers in say the oil sands, and you just handed that information over to the legal surveyor, he would know what ASCMs are, and he could tie the project to them in order to spot the wells. And then you don't have a consultant just spotting them without geophysical data, because it's going to make the geologist look bad if he can't meet his requirements. And it's also going to make the consultant look bad if he's spotting wells at a whim without using the geological evidence. And then, you're just overpaying for a consultant because he's not really using the required information to maximize the profit of the shareholders on the project. Okay, so that's enough for the seismic in northern Alberta and how I would apply it in one of the most difficult situations. But yes, I would use a solvent. I'd collect it at the end of the riverbed because that's what it's like under there. And then I would track it for the years that the plant's running using the seismic recording technology. Okay, so if we had to do that in the situation we're in, you'd have to bring something in to drill, and it would be really hard, and the fuel wouldn't be really useful to us because we're already making it. So our POL is pretty much done. We got our super soldier because he's using the laser technology bed to lay in. He's in there 14 days. We get there, and guys, these Amazon natives are very have a very old culture, and it's unknown what they're going to be like. So we're going to just say that they happen to be prone to cannibalism because of their food sources. So we got our steer named Jake that we're going to slaughter. Everybody's going to have burgers or whatever the first day. Nice barbecue. The whole area is going to be protected by our turrets that are wired to all our survey technology. So everybody's going to be safe. There's going to be clean water. There's going to be warm showers. There's going to be food. And so now everybody's not pissed off when they have to negotiate with the guerrillas, because by the time that happens, they already have the loadout where they can send a lot of them back to the Stone Age. And that's not what we want to have happen, because we're in the public eye, and war is a very public event these days, especially after you've seen it on TV for maybe a very long number of years, especially Iraq and Afghanistan. So... But because we're just learning how to survey, we're not going to really worry about all that too much. But it is good for an audiobook, and so I am including it, and we're going to go from there. Okay, guys, now that we covered the seismic, we're going to cover legal, and we did it in the situation where the data has to be handed over in a coordinate system where it can be reviewed and implemented by a consultant, so that when you'd have your lease site and you go downhole with your rig, you're going to be able to hit formation properly. And that's just giving that picture that you made underground to the legal crew so they can tie into ASCMs, because that's all you use to do seismic, because it's all required in Canada. And then they can correlate that to the section evidence. And then when they're looking for formation, they refer to the ASCMs and where you took your picture and where you have your recorders, etc. But the other thing is, they're going to be able to still adhere to their legal standards and create the leases and pipeline access and all that according to their own HSE, and that's going to involve a whole bunch of other people and stuff. But basically, they're going to be able to do it really quick because that's their form of surveying. Now, the seismic surveyor, he's the most productive when it comes to laying out line because he may lay out thousands of kilometers of line on this project, and he might not even have to go more than a few miles to do it because they're going to be really close lines and close shot points and receiver points. So, getting on from that, you're in the legal, and he's able to tie formation so you can get as many of these wells going as you want to get your carrier agent, and in this case, my solvent under there to dissolve bitumen and get it out. And then you're going to have to track it through seismic for a number of years so you know where it's going when it is. So all of a sudden, maybe you have a pool of bitumen and solvent that's residing in one little area and it is worth money to you and you can't get it. So you go throw your single rig on it after you get the well and everything done and the lease passed and all these kind of things. And you're able to get a big bunch of pay dirt or bitumen in this case because you were tracking the seismic on a yearly basis and not just assuming you knew where it was going to go, when, how, or why, like the consultant may have done in cases when I was in the field. So now that you're onto the legal, there's a lot of things that you can do that will help you. So I'm going to say, guys, in this example, well, it wouldn't be in this example, but the one that's comparable, like I said, if you would have a large cat machine that was able to cut in a number of days and create a road here for you that you could land your cargo plane on, that would be great. But if not, you're going to have the parachute pallet coming in. It's going to have a quadcopter that can take over load. That quadcopter is going to either have to be stored, given to these people, or hauled out. And given the technology that's on it, how much it costs to make, I'm going to venture to say you're going to want to take it out. So you got to remember, you're going to have to be able to make room for that to get it out unless you plan on donating it. But and in a lot of cases where people have like explored the Arctic and that, there's large machines that are either there underwater or on ice that were never moved out because it was too expensive to do it. And in the northern Arctic, there is a lot of natural gas and resources, you guys, and nobody's really developed it because the pipelining technology wasn't really available when it was explored, or it's too expensive to get back to the mainland, so there wasn't enough demand. But I'm telling you, there is a lot there. But nevertheless, that's an 18-hour delivery via 82nd Airborne or anybody else that would have the Hercules planes. I'm sure Air Force, 75th Ranger Regiment, anybody that uses Airborne or would have access to a cargo plane that could drop you a pallet that would either be guided in by a parachute, in my case, a parachute and a quadcopter. I could have the quadcopter and it goes up and it cuts the cords on the parachute and takes over. All these things would have to be in place. It would be very hard to make that happen, guys. So I'm just going to assume that you can get a drop zone within a reasonable amount of space that you wouldn't have to either travel far to get it and get it back to what we're calling our spawn location for you Call of Duty people. But you would have to think of that if you weren't able to put this runway in down here. I will just take a minute to label a couple of things just so that anybody that's coming in now won't be too confused. Okay, so guys, I did quickly label that runway. Not a big deal. I do have to take little breaks here and there. I haven't checked my total recording time, so I'm going to do that right now on OBS. And it says on the bottom, I've already been on for 3.5 hours. So it's quite a long audiobook, but actually I'm doing a lot better than I thought. I'm already through seismic. If at any time you've got the information you needed, you could easily proceed to the beginning of the video where I do have my PayPal pay code and make a donation. But if not, we're going to really get into the legal side of surveying, how it will pertain to our wartime or pre-wartime mission or during wartime, whatever it happens to be our scenario that we're kind of making up. And that next thing in legal is going to be a lot more difficult for this application because we don't have just pins in the ground from known boundaries, and we're not really going to establish any land of our own other than our kind of temporary drop-in zone. So if we do any legal surveying, guys, it will be in this situation stuff that is agreed on by the local municipality and or type insurgent type people that are resisting us, and the locals who are being either killed in genocidal conflict, and you're going to have to be able to differentiate them. And so here's all my advice on that matter, and I don't know enough, but if you know more, then you'll probably be set to go. But for the legal surveying part of it, maybe we will establish boundaries with some pins, but I don't want to carry a whole bunch of pins in my loadout because it's going to be a lot of steel that I could be using for either ammunition, and that's what we do as combat in this situation, or it could be used for other more important things. So in order to mark those boundaries, we're just going to have the agreement of the location from the locals, and we'll mark them however they want. If we had to have some sort of pins, guys, we could carry a load out of them. We won't need many, but is basically going to be able to get a clear land layout for whoever the minority is that is being persecuted, and land to those who are already controlling it, maybe forcefully. And there's going to be all kinds of negotiations in this process, but one of them is not going to be them attacking us or the minority any longer. So the first thing you're going to have to do is give them a clear show of force and capability, and your unwillingness to stand down in the face of a fiery conflict, whether it is mid-intensity or it escalates to an all-out intensity where you are going to have maybe your runway put in and continual amount of drops to your spawn location with supplies, all whether it's ammunition, but it won't be your POL fuel, it won't be anything to make the super soldier, it won't be any kind of personal loadout equipment, because we'll have already brought all of that. As I said in the beginning, when we go through our deployment portal, we're going to have the most accurate camouflage to this location that can be given, that'll mimic anything along the forest floor, maybe some of the tree lines for guys that want to perch up in there and keep watch at night or whatever. Of course, at night, the colors of the camouflage wouldn't matter as much. However, in some cases, they might be able to. So we're just gonna have the most realistic camouflage we can, and in any case it's probably gonna look a lot like what you'd see your local hunter have if he bought like camouflage that has forage and stuff that's on the camouflage. So it will be based on location, and it'll be the most accurate camouflage we can get, because we'll be deciding it in the original reconnaissance that happens before the deployment. And the deployment, like I said, because of the days of COVID, we're going to have a 14-day isolation period where you take all the vitamins that you need that are required to build the human body. And getting back to that subject, because it's one of my favorites, and that's the super soldier, guys, is once you have the vitamins and you're using the cold laser therapy for your healing and whatnot, then you'll only need one cold laser bed on location that you can rotate troops through. They don't need to be in it all the time. It's just mostly for recovery if they had to do a lot of running that day and they need to get a little bit of a recharge, so to speak. The vitamins also are going to be lightweight but highly nutritious. So whether you're just eating the steak diet for a while that you're going to have with the small amount of carbohydrates being the sugar you have on board will be in glucose form. Every cell in your body can use glucose, so you're going to have that. That alone could probably keep you alive for the 60 days. But if not, you could do a little hunting with the locals, maybe some fishing, or even roll into town and buy cookies and milk if it's close enough. Because your MRAP is going to be able to go very long distances with the technology we've already explained when you make it work in the order you need to. Because we're already getting into like the 3.5, 4 hour mark, I will say, guys, if you at all are a business contractor and you need a receipt for this consultation because it was just interesting enough for you, or you could get some information from it, you can always get a hold of me anytime. And if you really want to, you'll figure out how. But I could tell you some of the things you'll need to get a hold of me, and it's not going to really be email, but if you're on my LinkedIn and that's how you got this video, that'd be a great way to do it. My email has too many emails coming into it all the time, and I won't be able to check it like most of us are able to. So there is the LinkedIn. That'll be my primary way. And then you're able to, I do have an address in Red Deer, Alberta, the home address where I currently am doing all my recording with audio equipment and my laptop. I have some survey capabilities here. Like I have a truck. I don't even own my own survey equipment because, again, it's worth more than a supercar. But if you have to get it and you need the surveyor to run it, you would be able to use a lot of my methods, and I wouldn't have to even be there to train them. So if you do need a receipt for consultation because you made the $10 donation or anything like that, and you need to know how long, and you need to be able to tell your boss why you were sitting watching YouTube for like the 3 or 4 hours it takes to get through this audiobook or whatever it is, then I would be happy to provide it for you. But just downloading the video or making a link or copy of it and giving it to somebody else is a great way to do it. And so, without any more about that, we're just going to get back to our project. Okay, so we are in the legal side of things now, and we already discussed how making boundaries for the locals is all going to be had to be agreed upon. And in a lot of cases, you guys might have to investigate some historical evidence that the locals might have, and we're going to assume they have a very uh, primitive way of marking out those historical boundaries. Nevertheless, we're going to give them we're going to utilize that information, for whether it's landmarking certain items, whether it's like large mountains or rivers or whatever, and we're just going to be able to tie them in and make that and be able to give that to whoever the conflict and resolution parties for those people might be, of which we're going to know because they are either going to try to attack us or not, or the locals, and we're going to be ready for it. So getting into that situation, the legal isn't going to have a lot much more to do with the surveying we do. So I'm going to have to give you some tricks and stuff that I've used in the field to get through it. And so we'll have to assume some different things, and I'm going to need a little time so I can think about exactly how I'm going to apply this and make sure I've covered all of our areas. And just to finish with the vitamin nutrition thing, another thing Dr. Wallach learned about the nutrition in Africa is that animals tend to drink out of dirtier water because it was more vitamin or mineral rich. And we've seen this all over the world, especially if you live in Alberta or northern Alberta or BC or something, and you've seen a moose lick. It's basically the same concept. So that's why I have the soldiers on that vitamin regimen, so that they can recover from any type of uh, overexertion in the field and not be tweaking out because they need their amphetamines. So any of my soldiers would have a prescription for marijuana and for dexedrine because they need it to either stay awake or they need it for mellowing out in cases where they don't have battle to do and they need to negotiate with locals and they need something that would be good to negotiate with them. We could use that. So the amphetamines, however, we wouldn't negotiate with the locals with because maybe they're not used to them, but they could handle maybe a little bit of marijuana if we trade it with them. It's really going to be up to the people in charge, guys. And I know this might seem like we're going into a gray area, but it is not. If you look at the history of war, whether it's in Vietnam or other places like World War II, where the Nazis were using large amounts of amphetamines to be able to stay awake. We were just doing something similar. If you look at Vietnam, we know that heroin was a big problem. So opiates will be needed for our medics because they are going to need to give pain relief to anybody that is injured in the call of duty. So primarily we are going to have the opiates we need for pain. We are going to have the stimulants we need to stay awake. We're going to have marijuana as a traditional substance to barter with and use in cases of downtime and just needing to kind of bond with the troops or whatever. But we will need to always stay battle ready, so we're going to try and abstain from that as much as we can. But I just believe if you're an 18-year-old kid and you're away from home and you're fighting for your country and you don't have the right to smoke a blunt at any time, like ever, then I just don't think that's fair. So, and I don't think it's fair to say that you're not willing to die for your countrymen or to help out these locals just because you might happen to have a problem in one of these areas. So if you did have a really problem, you're one of my soldiers, so you're a chronic marijuana user and maybe you're a chronic amphetamine user. And what we know about amphetamines on the street in North America is all the time, whether it is some sort of a cocaine-like amphetamine to crack which is basically the same with a lower burning point, or methamphetamines. A lot of time you're going to encounter stuff like fentanyl, maybe bath salts, or worse kind of fillers. And in most cases, there's a lot of them anywhere you go. And I'd hate to break it to you, but for those of you who don't know, a lot of these fillers, especially fentanyl, are made and produced in China, and that's how they get here into outside sources, where the drugs are then mixed and stomped with these, and they come into the country where they're either mixed again or stomped again or whatever you might want to call it. But all I'm saying is, if I had a soldier that had a problem with all these and I put him on the dextroamphetamine as an amphetamine replacement, it would be able to, and he had all the proper vitamins and nutrition, including the ubiquinol for heart and liver, which is a big thing for your heartbeat, guys. And we had you on the laser bed, the quasar bed, and the vitamins and everything. We wouldn't expect you to be having mental illness problems with the amphetamine replacement, because you'd be getting all the nutrients you could. So with that being said, if you ever had to have a drug test to leave for deployment and you failed for marijuana being in your system, that'd be okay, because you have the prescription, and as long as you could pass a sobriety test, then you would be fit for duty. So it's only a 14-day prerequisite. That means you're on all these vitamins, you're doing some running, etc., and your body's not going to break down in combat. I do highly recommend that you have. Now, this is in case where we couldn't get people longer training in a better atmosphere. If you look at training that would take to become a Marine, or to become, like, say, in Ranger Ready and the 75th Regiment, like, this is extensive training, guys, and we wouldn't be able to do in 14 days. I believe RASP would be the quickest, like, Ranger Ready Ranger assessment selection process, and I think it is like 6 weeks, and it is to make you battle hardened in 6 weeks. It is quicker than most other training methods. I could be wrong about some of this. This is based on research I've done over the years and things I'm only recalling by memory in a lot of cases. But all I'm saying is that we wouldn't have the same rotations and stuff as the traditional army. This would be a smash or grab job, and we have to do it the best that we can without with adhering to all our HSE requirements. So the first thing I want to look after is my boys, and even if you look traditionally, like in, say, Vietnam, there were high-ranking officials even in Western armies, like the American. I don't know either how many allies they had in that war, who they were, but I can describe a few things that happened that people took heat for. For one of them, we would be talking about how Allied forces with, say, the Cambodians were working with the North Viet Congs to attack U.S. soldiers. In that case, I would have done just like Kissinger did and went across the border and messed them up, because they were working with the enemy, and I wouldn't consider this a wartime crime at all, because it was of necessity. And so in our situation, anybody and everybody that attacks me and my boys will be viewed as an enemy that needs to be stopped or deterred right away. And we are going to try and use as minimal force we can to convince them that what they're doing is no longer needed in a mid-intensity conflict. Because I don't have very many men, and they are all good, and usually the best ones go first in combat. So I want to be able to minimize all of that. So those are some things to keep in mind, guys. We're gonna have to appease a lot of people, and and as somebody that might be help running the unit or whatever, or somebody that is running the unit, and I'm just operating as the surveyor or whatever, I'm going to be able to depend on them to know these things and understand these things, because you're going to be a long way from home, and you're only going to have a few handfuls of people to be able to rely on for the next 60 days, if that's what it takes to get what done what you're doing. So far, we are only a day or so into it, and although we wouldn't have really been able to finish the seismic recording project, because maybe we don't want to start making blasts or whatever, we could just use something that vibrates on site to get different frequencies and still have those geophones set up. So that covers the seismic. We really covered the legal, and I'm going to have to give you through a few tricks along the way of how I do legal and how I would do it if I was still in the field. And I only left the legal field like over a month ago, so I really am up to date on all these things, but I'm going to have to share them with you, and so you could use the same technologies on your site or where you're surveying. Again, I do apologize for the length of the book. I've been going pretty hard here. As you can see, it is already 2 a.m. I got up quite a bit late today, as I told you before, I am retired because I do have a severe handicap, bipolar disorder. So sometimes I do trail off a little bit and it is hard to stay on subject. So soon I want to be able to delete everything that is on this page and then just move on to the next subject, keeping our map. And now that we've done kind of all the legal and you have an idea of what all these roles are and all these people are doing, you're able to look out for more that I haven't made you aware of or whatever. But you do have a good idea of the seismic survey and what you'd have to do in a similar application or something that would be totally different. And you could find that anywhere in this video. The other thing is the legal. It's not going to be as well used, like I said, but when we get to the construction, it might be really well used, especially if you're going to have to put up some structures with local materials for the locals, and you might have to do some construction surveying. So in that instance, we're going to look at things like when you do your seismic or whatever, and maybe you do have a local mine quarry where it has a lot of rock that could be used for gravel or whatever. There might be a situation where, you know, you could get your hands on a crusher and do a lot of damage for road building and stuff with the machines that you have if you had to build the runway and that. But if you didn't, you're going to be doing the construction surveying on site when you place maybe some tents or some buildings that you might build out of local materials. A good thing to know is where there is limestone that you could turn into concrete. For this, you would need some sort of batching plant and a place to make the concrete, which means you're going to have to use a lot of high heat to heat up the limestone, and then it would be able to react with the water, hence making your cement and then mixing it with any rock for your concrete. The reason why I mention this, because if you're going to be around for a long time, and let's just say the enemy is out over the hill and he's dropping he's dropping artillery rounds or something onto us, or maybe he's just firing randomly at our equipment and all that. You're going to probably want a nice good concrete wall reinforced where you can sleep in it and behind it during the day and nothing's going to affect you. This probably does give a lot of peace of mind to the soldier, and would in my case to my soldiers. So like if, for example, somebody was using like some sort of an explosive round, I can't remember exactly what it's called, but you got the pipe and you drop the little torpedo like round in it, and it takes off out, and then it lands on your camp, and then it shreds your tent. I can't remember what it's called, but they explode on site. It's like an artillery round, but you guys would know if you're in the Army. But like I said, I don't know enough, but I know when you drop one of these things on a tent, it shreds the crap out of it. It's not very fun or safe to live in. For you guys of you who don't know, if you want to research military conditions behind the front line, it is completely different from what you have been calling frontline workers in 2020, guys, because they are not frontline workers. They are flu line workers, and there is a cure to the flu. And so I have to give out the cure to COVID in this video, which is another really hard thing that I'm going to have to do. But I've already given you some of the things that you would use in an application if you had somebody with COVID, i.e. the zapping technology or the laser bed, in case I use them for super soldier technology, so that the body is very sound. When it comes to anything spiritual or books you have to read, guys, that's all going to be up to you. We're going to assume we have people of different race, religions in our army. I have already begun transgender movements in my personal life, not in real life, but for this scenario where I have grown breasts to be transgendered male surveyor, that is male and female surveyor, or female if I prefer to be called, in this situation. So that was the other reason why I needed brand new ACUs from my deployment portal, which again, for you guys that don't know, is just the scanning device that gives us custom fabrics on our body that fit at all times, given the weather conditions, etc. So with that all being said, we are now on the ground. We're eating. We have warm showers. We're assuming all the technology I've given to you could work and would work. And if I had the money, I could make it work, but I don't. And If you do, then hey, I'd like to probably meet you. But if not, I wouldn't worry about it for now. We're just going to try and get through the rest of this. We've already pretty much passed the legal surveying. I will give you through a few tricks to that. For the construction, everything you got to know about that is distances in construction are always higher than they have to be. And the reason why they have to be on structures is because we over engineer everything, especially in the Western world. So we know that if there's an unforeseen circumstance, we know that that structure will not fail. The most common place you see this, guys, is going to be in your home. So chances are, if you have a home that is sitting on some sort of foundation, in my case, in Canada, we tend to build below like the frost line with our foundations, just for a number of code reasons. But nevertheless, you might have a wall that is, say, like 6 inches to 8 inches thick that's supporting the structure of your house. In a lot of cases, if you have reinforced concrete and say you have fiber mesh in there, and it is mixed to a standard that is going to be really high density when it cures or whatever, and you got the mixture and everything just spot on, so that you could just howitzer this wall with like a pig machine gun, and you're not going to be able to get through it because there's still rebar and stuff in it. Now, if it was all done to that process and your house was sitting on it, you could probably go with a wall that was 2 or 3 inches thinner and an engineer would pass it. The only problem is a lot of these variables are so hard to determine sometimes, based on whether somebody waters down the concrete, or it comes in at the wrong temperature, or it doesn't pass proper slump tests, or whatever it is in your situation is probably over engineered. How can I know this? Well, first of all, my father has been a project manager managing overall trades on an industrial site, which had up to 400 men. We're talking welders, pipe fitters, everything. And now in my case, I cannot work with my father, so he'll be the one person that's not on this loadout or not on this mission with me. I don't know how I'm going to contact him to get a hold of him again. It'll probably be via satellite phone if I got to talk to him, because everything that we program into our equipment that's going to be running off of our 2 base stations, these 2 helicopters that are going to be stationary on the platforms we built and hauled in, which are essentially going to be steel grating with like a pontoon, like a technology, just something to keep it up and out of water or from sinking too much. Yeah, my father wouldn't be out on that expedition or anything with me, because we cannot work together. He knows too much about what he's doing, and I know too much about what I'm doing, and it doesn't really ever cross paths, because typically on a site, nobody really knows what the surveying is going on but the surveyor, and nobody really knows what the rest of the stuff is going on in terms of the surveyor, because he usually just deals with the numbers and stuff. So even though he's seen and everything maybe take place on your site, which is in many cases the reason why he might end up being a project manager, because he's from there from beginning to end, and he can tell you, we can't do that, we can do that. You will have seen a lot of surveyors become project managers, maybe in the Fort McMurray region, for example, because of this, because they visualize and see everything from beginning to as built and commissioning, right? So that was a position in particular I was being procured for when I was a contractor, and it was basically of my own design, because I was working with a really good project manager all the time, and I was in his office more than anyone else, and also in the field doing my duties. However, guys, like I said, I ended up getting bipolar disorder, didn't know I had it or was born with it, and I don't do field work any longer. So if you use any of the methods or techniques I give you, I will tell you, you can make up to over $100 an hour by the time you're 23 or 24, like I did. That is Canadian money. Or you could be making less than $20 an hour helping and not leading, just helping another surveyor, which is not great money, and it is a lot harder work, especially in legal, but you would still have the capability of getting all the information you need to do all of this kind of stuff. You already know what I'd wear for clothing and what I wouldn't wear. The rest is up to you. You know how I would do kind of the seismic and what to look out for, and how I'd record it, and how I'd do the shot points, etc. We've used some creative ways of establishing that here. We've already done our policy. We know what our duration is, where we're at. It's resolving a genocidal conflict. We've kind of resolved all of these things. We know that the position of any of these helicopters, or a combined position of two, is going to be at 0, 0, 0, which we have listed here, and the 0 is going to stand for 0.000 meters or decimal feet. And so we have stated already, whether you're on the Canadian or American side of Métis things, these base stations that are in the helicopters would be able to broadcast your position and any information you need in either meters or decimal feet. And I would prefer decimal angles rather than degrees, minutes, seconds, just for conversions and estimations, etc., like that you want to do quick in your head. We are not going to be doing a lot of difficult math, and we haven't so far, because I haven't in my career, because most of the information is processed by these instruments that we've been using. And like I said, I was able to do most of my job in the survey field in the past, whether it was legal or construction, with using very simple math. And a lot of the hard stuff is just done by an onboard program that you have to input directions and angles in. So getting back to where we're at, we've decided, hey, we didn't go with the runway. But we were able to get a trail or road that an MRAP could get back to civilization on, or to the local conflict or whatever it might be. And he's going to have a 50 cal on the top of that with auto aiming and firing capabilities. It won't be firing at anybody, you guys, if it doesn't need to be. It's just, all I'm saying is that we're going to have a camera on board with laser and azimuth measuring technologies. So typical EDM that you find in a total station, but in particular a robotic total station. And it's going to be on each of these helicopters with a GPS sensor. And if you want an example of it in surveying, you could see this with a total station robotic that has a GPS sensor on it and communicates with a GPS sensor that is over and atop a 360 degree prism. So what we said is we are going to use that machine to backsite the other machine's prism, so it could broadcast the location of all the surrounding information you've already collected in a very stable format, rather than have it bounce around based on GPS coordinate in your helmet. So you're going to have to be able to figure out how to do that, and that's not going to be too hard, but it's generally straightforward. So it just means that it has to be able to keep a consistent location on that other helicopter using that laser distance angle technology that you're going to want to be able to utilize, just so that all your information is stable in your helmet, other than maybe other people, animals, and stuff that might move sporadically. Now, where that will come in handy is if, say, you are on a construction site or a seismic site, and this is a great idea, and it would work if you had these helmets, especially as they're available in construction for supervision to view projects initially. Is, let's just say you know somebody in the video gaming industry, and he wanted to take all your ground information, structure information, and anything else you've been able to record with LiDAR or anything on your site, and you're not in a wartime situation, but everybody likes zombies, Call of Duty 3, and you want to have people on site with some laser activated guns, and you want to be able to 3D scan, know where everybody is, do all these kind of things. You would be able to stabilize the projection of your site and everything in the camera the same way you would with a video game, and it's only the individual himself that would kind of have the either lag or the bouncing around kind of quality, because they'll be using the GPS. However, if you use the total station to stabilize the projected site through a separate dedicated set of channels or CPUs, it would be able to stabilize it better than your typical GPS-based setup would. If you could figure that out on your own, great. If not, I could get into a little bit more, but it is pretty straightforward. It's just, instead of establishing the location with the GPS sensor that is only good for a certain amount of centimeters of quality when it's operating with the base, you're just going to have all of your information about the site or structures or anything in a different dedicated channel, and it's going to be projecting it to your helmet so that it doesn't bounce around in that. Now, it still might bounce around a little bit because you're comparing it to the receiver and that on your helmet, and you're not using the laser to directly sight your helmet. So there might be a problem there. I haven't been aware of it. All I know is I've sat down and figured out how I could play zombies on my construction site because I've been really bored, and I like zombies, or at least popping their heads off with a dingo light machine gun. And so if you actually had some laser tag guns and you could stabilize the vision of your project, and say that didn't work, at the very least you'd be able to get it in your helmet in GPS quality at base quality, which is the size of about a quarter when it's spinning, maybe a little more egg shape, but it would be fun, guys. And if you could do it, I'd want to see it done. So yeah, that's just a great idea that can maybe kind of keep you interested in this long video that's going on and on and on. Okay, guys, we're back down to who we have on this flight and why. Obviously, we have two pilots. It would be great if anybody could be a pilot, but like I said, you're gonna need a good understanding of fractal currency, because fractal currency is one of the things that will keep you alive in surveying in this situation. And I know that's an extreme exaggeration, but let me just give you kind of an example. So the first thing is all your weapons and loadout, whether you got them from a gun show or you got them from the armory on your base, or however you got into this Métis militia situation, you'd have to outfit them with either a fingerprint technology like your cell phone for unlocking them, which you could do in the mornings or at the end of the nights, and then after that, and then you're all good. The other thing is eye retina recognition technology. So that would be probably for to operate the helicopters. At any point, if you are the last man standing and everybody in the entire region hates you and they are coming for you, and there is rounds coming in from all directions, and you have to get out of Dodge and get back to your aircraft carrier, when you flew in, you would have pulled a string line of data from your GPS, which will get you out and back to that location. Whether it's moving or not, it won't matter, because it'll just recalculate the new calculation based on the location of your aircraft carrier. So somebody could scan their fingerprint in an emergency situation, or have their eye retina read because everything went south. They took your cow and your dogs and everybody's dead except for you, and you happen to be maybe one of the operators or medics, and you're not the pilot, and you can't operate this thing. It will have to be able to take off knowing its location and the size of the canopy that was cut for you to get in, which would have been able to auto land it as well, because you would have had the LiDAR and everything. So it would have been a very smooth landing, especially on your pontoon staging platform, that your helipad that you're gonna swing in there under you, that's gonna probably remain there if you ever want to come back or whatever. So that's where fractal currency is going to come in to play, where everybody on the unit is going to have to be able to access each other's weapons in case somebody goes down and they need to use it. They're going to need to know how to use them, which is why you're going to probably want a uniform type of gun or issued common combat rifle, or any of the type of weapons you'll use in your loadout that would fire and need some sort of fingerprint or eye recognition to operate. There's a lot of ways you could do that. You could have it with the helmet using optics, using your eye to approve all of these engagements, and you could use your fingerprint, like maybe for some sort of safe or vault that would have any of this stuff in it. There's a lot of ways you could do it, guys. I'll leave it up to you, because I can't get too much into all that, because I don't know whose toes I'd be stepping on. But not only that, I just don't know enough about it. I just know the technology's there, and there's some places we're going to need to use fractal currency, especially when we get into the issue of hypersonic missiles, so we know how to deter and not worry about them, or to make our enemies worry about ours. So just to give you a little teaser on that, you're going to need to understand that the moon is always facing the earth, no matter what position it's on, just because of the speed that it spins based on the speed it goes around the earth. So whenever you've seen like the moon, and it looks like there's kind of a calf on it that's jumping over something, and I don't know if that's where the nursery or I'm stuff comes from. The cow jumped over the moon or whatever. But to me, it looks like there's a little calf jumping happily on the moon when it's illuminated. So that is a fractal currency. So if you had a hypersonic missile and it was traveling through space and it was supposed to be in the right location, it's going to have to be on. It can identify and take a picture of the moon and know that in real time, based on the conditions of the moon, it would be in the right trajectory. And now it wouldn't be able to just use this because it would need some very fine azimuths to work off of, and they would be stars which have been tracked and able to be tracked for a very long time. The other thing that you might want to note is that you couldn't use the sun as a fractal currency in the same scenario, because it's entirely a light source, even though it does have fractal currency on it. It's rapidly changing so much and so fast, and it doesn't really get created or recreated, but it does, but it's just so hard to predict that it wouldn't be good enough sinusoidal data for you to use. In which case the moon and stars would be. However, the sun would be gratefully useful in determining your north. So I'll tell you how to do that right now, no matter what, when you're in your situation. And you'll learn this from any kind of Army survival handbook or anything. And so for surveyors that might already know, if you point the hour hand at the sun, halfway between your hour hand and the 12 o'clock is either going to be north or south, depending on whether you're in the southern hemisphere or the northern hemisphere. So now the thing to know about north and south in that situation is when you're using the sun to dictate north and south, it's basically based off of what we'd call like gravitational information. And why do I say that? Well, first of all, the Earth doesn't have enough gravity to pull the sun near it, but we are in the sun's gravitational pull constantly as we revolve around it. So it's a very predictable direction that we can predict. Is a direction that is very highly predictable, based on the position of the sun and the time of day. So everything that you have in your loadout will be getting information on this, and it will be based on we will use in our example, like and we'll put it up here by our north thing. Our coordinate system for everything is going to just be WGS 84. And the reason why it's WGS 84 is because well, that's just an easy coordinate system to base your information off, because it all converges at the north and south poles. And the north and south poles are going to be the truest form of north we can get, because that's what these meridians are based off of. So when we're talking like magnetic north, where you might use a compass, that's not going to be as irrelevant unless you know the deviation from the meridians at north, or the poles at north, because they will be different. You're going to have to know that correction. And because it's going to be different everywhere in the world, we're just going to stick to solar north, which means you're going to use the sun to get that northern direction. And when you get that northern direction, it should jive with your WGS 84, because it is based on the poles. So I'm going to have to break down how this works really quick, just for everybody who doesn't know, so that you know your coordinates and everything are jiving, just in case things go dark. Okay, so in case you don't know, there is a little bit of a wobble in the earth, and it takes place over a great amount of time, and it takes a long time for it to do that wobble, and it's moving basically for a whole lot of reasons. But just imagine all the water and ice, glaciers and stuff on the planet moving. It's going to change the center of gravity for the earth, and so its axis will change a little bit. This has happened I think about 10 meters over the past like century or so. So you have about 3 or 4 inches a year that this will happen. So what that means is, just imagine your body where you were working out one arm all the time and then not the other one. So one side of your body got big and the other side didn't. The center of your gravity would tend to dictate a little bit to your larger arm and say larger leg, just because of the amount of mass that was there. However, it wouldn't make the person that is across the room gradually gravitate towards you because you wouldn't be making enough gravity, although you do, but not enough to really affect the objects around you. And so in our theory of this war, we're going to have to debunk a couple theories, but we're going to have to make another couple theories very valid. And so just to do that, give me a second. I just got to pause. Okay, guys, I'm back. Our map is the same. Excuse me and sorry. But we are going to pay attention to a couple things, and that's what's here. So, our gravitational field that converges at the poles is will change over time by a matter of a few inches in a year. We're going to determine north by using the sun. I'm always going to go north where I'm at because chances are that's going to be where home is if I'm going back to Canada. Now, the North Pole, like I said, all you got to do is have a watch on the right time. And when you get into your zone, your GPSs should be giving you a proper time. So you're going to need a minute hand and you're going to need an hour hand. The second hand will make a difference, but not a lot. But we won't really need it in this situation. Now, you might be familiar with ways of determining east-west, whether it's or north and south, whether it's by just putting a stick in the ground, measuring the time that passed, and then putting another object at the end of the shadow for the same object that you started with. You cannot do that. That does not matter to me. All I'm saying is WGS 84 or a coordinate system that is like it or been based on it or similar to it since then, and there are a lot of them. You'd have to do the research. It generally uses longitude and latitudes that converge at the North Pole at center of gravity as it exists today. So what that means is the Earth being in the gravitational pull of the sun, if you use the sun to orientate yourself, is going to be fairly accurate. Now, to make sure it jives with the WGS 84, the thing you're going to need to know is the gravitational pull of the Earth is what dictates the rotation of those satellites. And so center of gravity for the satellites, if it does change and as it changes, would be able to be computed to keep your information up to date. And so I'm just going to say, I'm going to go out on a limb there and say, if you're using WGS 84 and you orientate to solar north, then it's going to have your camp and all that relatively aimed to the same thing. If I'm getting that wrong, somebody's going to have to talk to me about it. But the way I see it is satellites use gravitational sinusoidal data. And by that, I mean distance and time it takes to get around the sun in a certain measurable pattern. And that's based on the Earth's gravity. And then the Earth's orientation and its travel around the sun is based on the sun's gravity. So if you orientate to the sun and your gravity on Earth would be tied to the sun's gravity, then these things should always drive. So that means if you're completely lost and there's no way out and you just know your location from your balls point, which is going to be on one of these choppers, you should be able to navigate with just your watch and the sun or even the moon at night. You're going to have to do a little more research to know exactly how you do it. I've had to do it myself. It's too much explained, and this book is already long enough. But basically, we're going to consider our North Pole to be our WGS 84 North. So anytime we do construction or anything like that, we'll be able to jive very accurately, whether we're measuring with laser EDMs or our GPS corrections, like via a RTK type thing where we're using the radio correction from the base to establish our position in a more finite location. Now, because of the loadout we have is so capable with the lasers and or EDM, same they're with an angle measuring device. Then we have our GPS tilt sensors, LiDAR. We're going to be able to get anything really close, but because I got to keep this to legal surveying and that, there is kind of things you could eliminate in legal surveying that people are doing now by utilizing just the WGS 84 coordinate system and how you do maybe a subdivision. So to illustrate that, let's just say this is a big section of land. And so through the middle of it, you have a line, and then you have a line this way. And let's say it's perfectly square and is a mile by a mile by a mile, which means all the squares in the middle are a quarter section, or a quarter mile by quarter mile. And half mile by half a mile. And so you've seen this all in probably the area you've surveyed anywhere in North America, in a lot of places anyways. And if not, you could adapt it to something that's similar. So something that I will give you that is a secret about legal land surveying, especially in Western Canada, but it is pertinent to anywhere that they would have legal surveying. Imagine that this top line here had an angle and a distance on it. And so given the angle that we say that it's at on this page, it would be at 90 degrees from polar, or just this being north, 90, south being 180. And then to our west would be 270. So it's all broken up into 90 degrees. Now, I prefer to use decimal degrees, but you will never really come across them in legal surveying, because everything's done degrees, minutes, seconds, or they're done in something called like bearings, which means it's from and to a certain direction. So if it said like northing, then the angle, then southing, it would mean that you have to start at north and then go to either not the south, but east or west or whatever the next angle is. And you'd have to be able to calculate that. It's not really hard to convert these into just one type of angle, but just know that you might have to do it in certain situations, because bearings are a little different than going with north is 0, and then it also depends what your north is. So be careful when you're calculating any data off of a legal plan, especially if it's older than a certain number of years, and it's different in a lot of cases. But I want to show you how maybe you could tie in the pins today and not have to go back to ever tie that pin in again, and all you have to do is put it in the registry, and people wouldn't have to tie it in at all, because you used a WGS4 or WGS4 related coordinate system. So you didn't use a UTM. So because you need to know a couple things about satellites and how they project their position and your position, you might have to do a lot of research, but I'm going to give it to you as quick and easy as I can. And that just means you're going to have to assume a few things that we can all assume about them. And GPSs travel in a circular pattern around around the Earth, based on the Earth's gravitational pull. And so sometimes when they're lower, they might be moving faster. When they're higher, slower away from Earth. So it might be like an egg-like shaped pattern that they follow. Nevertheless, that pattern is circular, or based on a very predictable arc that can be measured. And so if you guys are measuring an arc and coming off an arc, and then you have to turn that arc data into a grid data, that means you're not losing a lot of time or anything in many places, but it just means that somewhere along the line, a calculator has to take a coordinate in a longitude, latitude, and convert it into a grid format. Now, there might be zero error between both of them, and it might not take very long for that to happen. But anytime you set up a base and receiver station and assume a coordinate and an angle based on local data, or you do that with a total station and localize through like a resection, you're only going to be orientated locally. And there's a way to be orientated to the UTM north, or the WGS4 north, have your data in that coordinate system, and it not affect your ability to calculate based on that. So we're going to say that there's a pin up in this corner. So in order to illustrate that, I'm just going to do what legal surveyors do for a lot of pins, and it's a circle, and the circle's filled in, and it means that you either placed or found a pin. So placed a pin would be an open circle. So we're going to say there's a pin at the northeast corner of our area. Of course, it's not going to be this big, and we're going to say it's a pin like you'd find in Canada where I'm working, and you need this information. If you go to that pin you're going to have a base station somewhere else set up. And in this case, it's going to be one or both of the helicopters, depending on which one you're working out of and how you decided to set up that 0-0 location, whether it's the middle of your drop zone and it's being calculated by these in real time. Maybe you have a physical brass cap that you installed, just like in British Columbia, right in the middle of your drop zone, and that's 0-0. But either way, your base is going to have to know where it is or whether it's it, and calculate the difference and project it to this corner where you're going to tie it in. And the surveyor happens to have a rod because he's doing some legal work for the locals, and this used to be an ancient boundary, and therefore we got to tie it in. And it just so happens to be a long red pin, just like you'd find in Canada. And I never ever want to go back to it because I had to dig it up in a swamp, and I want to know that the next surveyor knows without question where it is. So if I took an area the size of Alberta and I wanted to make it all geo-referenced, and I wanted to slowly do this over time and never more than I needed to, because otherwise I'd have to go back and change a lot of surveys in the data. But for the next surveyor, we'll make it easy. So all I'm going to do is have something called a rod and bipod. And then I'm going to prove my math is better than the traditional method, and then go from there. So my rod, I'm going to have, it's going to be a line, and here's my rod. It's tall. And then on the top of it, I got my GPS base receiver, which could be a cell phone. In this case, it's just going to be whatever is durable and works for the location. And then it's going to have a bipod, which means two rods that attach to it at some point. And you can just use two sticks for this if you want to hold it, but I want to prove that it's static, so we're going to use an actual bipod. The hole's down a bit. I dug it, but I'm on the pin, and so I got my bipod. I know it's level and plumb, so there's some things that I know here that I would know even if I'm doing legal in Alberta, and that is, one is if I'm not getting good quality because I'm in a lot of trees or something, I want to be able to prove that this point is relatively close to where I say it is. And so if I was laying it out and I already had my coordinate system and all that tied in, I'm going to be looking for under about a 2 centimeter quality. And I'll probably have to come back and later in the day to tie it in at a different time, which is going to take a lot of time, as you can see, because I drive up this road and I got to get access to it somewhere, and the locals have to be there because they're talking about it and I'm talking about it. Maybe it's on a farm in Alberta, and I have to make a subdivision and calculate off this line somehow and parallel it. So I'm going to let you in on a little secret about legal surveying and the plans, at least as they stand in Alberta and most places. And that is the angle and the distance that is on this line between the pin does not govern the boundary. And I know a lot of you guys are going to say, oh, well, we're getting into this. And I'm going to just tell you right away that any practice review board in Alberta will tell you that if you had a right of way crossing this property at any point, like, so we could draw that in, let's just say there's a big oil right of way coming across here, and there's pin here and a pin here, and I tie this in and I tie in all the corners. And I say, and I never actually physically go tie in the pins on this right away, but I just project them on my drawing. If there happens to be any reason that that is wrong because I didn't actually tie in the pin and the dimension or something on the plan is wrong, it's going to be on me for not actually researching that pin and make sure the right of way is where I said it is. Meaning, I can't just take these pins in the corners, assuming they would all be there in that fashion in any type of survey. Let's just say it was a lot that had a right-of-way crossing it and all four corners were there. I cannot just project where this right-of-way is going based on the dimensions that I get between these pins. Even though it might be right and accurate, it's not the proper way to do it. And the practice review board, at least where I live, would tell you actually have to tie in these pins. And why is that? Because it's actually the pin that governs the boundary. So anytime pins have moved, maybe in something like a like a shoreline, if there's pins near it, and I've surveyed these in BC in the Okanagan, they do exist. Up into like some sort of an accretion that's changing slowly over time, and the pin's position isn't good anymore, or anywhere it just might have moved because maybe a farmer wanted to take more land from his neighbor and he just slowly moved it over. a foot each year until he eventually had his 10, 15 feet of extra farmable space, which I have heard of from a consultant too, and I've seen other things similar. So, guys, I'm only going to give you something that would work. Now, let's imagine, for example, you're in WGS 84 and you're on this section, Alberta, and you're tying in this pin. Now, your base station is one of these over here that we've already decided is our helicopter, and it's going to be broadcasting your location on site for everything as 000. Well, as you could probably tell, once one of these helicopters take off or change position, those dimensions won't be good anymore, right? But we could still use the correction from them, and we can still because they are stationary, and we will be stationary with our bipod, and we will be in the WGS 84 system. So if we do tie it in the manner that I'm going to show you, which you could use, and it is crypto again, so you're going to need an understanding of cryptocurrency. All we're going to do is make a cryptocurrency in the WGS 84 coordinate system, and then that pin will always be known for that position, or as close to that position as we could possibly get, without having to go back there twice and waste a lot of time double tying. So I have explained this to some people in the past, but it is pretty straightforward. The reason why you have to go back and double tie is because the satellite geometry is unique and different enough that it could give you better resolution, or enough different geometry that if you still were getting the same quality under 2 centimeters, that would be satisfactory for your layout, and everybody would be happy. Unfortunately, not everybody had the same technology you did over 100 years ago or less, and a lot of township plans were all done using basically your eye, a simple instrument that would have a plate on it that could measure angles, and which we will get into later. But basically, a lot of instruments were like that for a long time, where you had to read the angles, degrees, minutes, and seconds. Whether you could read the seconds or not is another issue, or the minutes. But the most common survey instrument, like I said earlier in the history of surveying, is going to be the human eye gate. And I know this because I've studied all the instruments that have been used in Western Canada in the last probably 100 years, and a lot of them I had available to me through a wonderful guy I worked for in the Okanagan, who owned a lot of them, and he brought them out and showed them to me how they worked and what application they would work. So there'll be a lot of times you might come across a survey that's through the mountains, and you're on one of these lines and it says it's so long, and we'll say it's about a mile long or half a mile long, depending on the size of the district lot you're in maybe British Columbia or something like that. But the way it was surveyed back in the day, you might be like a meter out from it when you get to GPS and you shoot your distance and angle from this point to this point. And what that means is they are bang on, guys, because the methods they had to use were much more difficult. There was much more hand and brain calculations that had to go into doing that survey. So I'm just going to say that if their distance was out a bit, but their angle was really close, or maybe even not so close, but relatively close, that means the guy did his job pretty good, and it was just a matter of error that accumulated through the survey, like i.e. going up and down really steep terrain. That was what introduced kind of the error into the project. And I could prove that through a lot of different ways, but that's basically the gist of it. And it kind of has to do with the way when an instrument in the past that didn't have like a quad axle compensator, or any compensator other than just the vertical plane, when you aim your instrument really high or low, it tends to throw out the horizontal quality a great deal, just because when it's leveled and closer to the plane you're working off, like the height of your instrument, your HI, the horizontal is going to be a lot tighter because it's just level at that point. But when the scope rotates up and down really high, the horizontal is going to be out, just because of the way the angles work. I'm sure you can imagine in your mind, but if you can't, just know that a lot of the old survey data was done with an eye looking through some sort of an optic viewer, And so you tend to have good eyes and motor skills to be able to do any type of surveying because of this. And so that's why you'll hear surveyors sometimes say, wow, the old data we're getting here is like way tighter than what we lay out. And that's because a lot of what's been laid out maybe in the last 20 plus years with an RTK GPS system. Like, so if you have a cut corner on a lot, if you lay out both of those with GPS and they're only 10 meters apart, you could be up to, let's say, 18 millimeters one way, 18 millimeters the other way. And then with some rod error and instrument error, user error, and all that, you could be up to like 4 or 5 centimeters apart on 2 points that are only 10 meters away. Now you're still going to be very relative to like your 2 centimeters maybe on each point, and then like going to the ends of the other block or the next lot or wherever you're tying in. But nevertheless, it would be even more accurate had you used your eye and an optic with a crosshair in it, like it, to turn that angle and shoot that distance. Even if you had to pull a chain, it would be a little more accurate. The only thing is you're never going to be able to produce as much as the GPS is, and that's why we use it, because it is accurate enough that you could do these layouts and all your information would be congruent enough that it would pass the quality standards. That's something else I'm going to have to get into for when we're using the robotic total station and whatnot. But this method is something you could use. I know it's taken a while to explain, but here's how it goes. So you take your bipod with GPS, and we'll say you have a 2-meter rod. You stick it on your pin, and you let the bipod relax in a plumb position. So you stomp the little ends of the bipods, there'll be points on them, into the ground, and you tell it to collect a static position, so its best average position that it can get every 2 seconds for about 100 positions. So it would be 200 seconds. Now 200 seconds is going to be 200 seconds is going to be like a little over 3 minutes. So you could basically have a cigarette and never have to come back to that point again. And how you're going to document it is this. There's going to be 2 things that you're going to get. One is you're going to get a notepad full of positions, and they're going to be in northing, easting, and elevation. That's if you're working in a UTM or local coordinate system like we would be off this. But because we just want them in WGS 84, we're just going to survey in that mode, and what it's going to give us is a long and lat, and it's going to give us degrees, minutes, seconds, maybe fractions of it. I'm not really sure. I can't remember because I've surveyed in WGS 84 a lot, but basically it's going to give you long and lats, or a different coordinate system that's different from your typical grid, which is positive north, positive east, and then positive vertical up or negative down. In this situation, you're going to probably get some sort of projected elevation. I don't know what format that would be in. I honestly haven't had one in front of me in a while that I've done this with. But I could tell you the WGS 84 coordinate is going to be based on the same method that the satellites travel the Earth. And for me, that's going to be longs and lats. And then it is going to convert it to either that UTM zone coordinate or your local coordinate. So if you just keep it in WGS 84, you know that if you are anywhere in like Alberta or any place where you know that it's a location that only could be relative to that pin. So even if you had a pin a meter away and you could establish that this pin was within, like, say, less than a foot of where you say it is, that would be satisfactory enough to find it again, to do layout off it again. Because when somebody comes there, they're going to use a pin finder, they're going to scan, they're going to ping, and they're going to hear your pin, and they're going to set up on it, they're going to shoot it to all your stuff, and then they're going to say, holy, this guy didn't know what he's doing, he's out like 20 centimeters, and we're going to say, well, guess what, guys, the plan dimensions and angles don't govern the lot, it's the pin, and we agreed where the pin should go, that's where it was. And you will find times where pins are up to like maybe a foot or more from other pins. But generally speaking, this would only have been done in like a major error, which I've only seen once in my career, where like an extra chain was added in the original township survey. And so you're 66 feet long or whatever it is in meters. We're not going to consider those situations. We're just going to consider that if somebody ever has to come back and all they have is a WGS84 coordinate, they can get to it even with a handheld device within 5 meters plus your error, which would be like 20 more centimeters. So it's going to be not really good enough to find using a handhold. But if they do set up a GPS and they are in WGS84 and they pick a base station that's going to be different from yours, like anywhere, but you have that coordinate system in WGS84, they can set up WGS84 coordinate will be sent to their base station, and before you assign any coordinate system, you will be able to use that WGS84 coordinate to lay out off of. I've done it. It works, but this is how you would have to make it do. This is what you would have to do as a further step to make it work in for the next guy, so he wouldn't have to tie it in, but he could easily just take that point, take a picture of it, and then inpoint it into his gun and prove it and not have to go tie it in. And so this is how you would do it. The first thing, you would have to have a visual. So in the visual, it's going to look like this. You're going to set up for your 100, so your 200 seconds, which is a little over 3 minutes. And you're going to take 100 static shots. Okay, so if I take my pencil and I pretend that this is the shot here, I'm going to have first I'm going to make these a little bigger so you can see them. Can you see that? Okay, there we go. I can see them. So let's say you have all your points. None of them are lines like I'm kind of goofing up and making. And then you're going to have some of them, they're going to be a little more outside the center of your points. So you're going to have an assortment of points, and they're going to be anywhere from 3 meters from your pin to only millimeters from your pin, because you're noticed you're under canopy when you start. And by under canopy, I mean under a lot of trees. And for seismic guys, this isn't intimidating because you've taken hundreds of shots throughout the day under trees, and you know what your instrument's capable of and what it's not. So I'm going to say I never want to come back, and I want to get all the geometry I can. So that's why I'm using that 200 second method, or the 3 minutes, because a lot of these points are going to be so far out in the beginning or maybe by the end that they're not going to be really pertinent. However, they still are going to be part of the data that averages my shot to get the middle one. And the middle one and the last one will be a different color. In this case, we're going to use red. And so we're going to say of all these points, my average point was right here, and that is the red. Okay, it looks like somebody's shooting a gun and they hit the target some of the time. A lot of the time they didn't. So you're going to have to establish what percentile of the points you're going to use to establish your shot. Well, if just by looking at them, you could draw a circle around them, and you could tell, and I could tell you right off the bat that anything in this area here in the middle, and I got to change that, guys, because it's not working. So I'm going to delete. So what you could tell is that by anything there in the middle, which we'll circle like this, again, we can't do that because it's going over it, and I don't want that. This is the first time I really used paint for my notes, and I'm surprised I never did it in my career, but it is pretty much a fast way to do things. I have drawn with AutoCAD, like using Micro Survey, and you guys, this can do almost everything the same. Maybe not as fast in some cases, but it doesn't have to be to the same scale or accuracy, because you're not going to be using it for layout and that. This is just for note taking. And so far, it looks like a very young person with not very good legible skills has drawn this. Nevertheless, the information is written legibly, and if I want to make it to scale, I just have to use the rulers on the side and bottom. So if all your points look like this, and the very last point on your list is going to be the average of all these points, and you put it in red, you will also have your notepad set up, and it is going to have shots from 1 to 100, because we're doing 1 every 2 seconds. So you're going to have 100 coordinates in a list, and they would normally be in at least a CV or a comma delimited format, which means every comma is a new coordinate. And so they would be northing, comma, easting, comma, elevation, and you would be able to put those into any type of instrument or gun and be able to lay those coordinates out. However, because we want to keep ours in WGS 84, you're going to have a long and a lat measurement. And I think these are just better measurements, guys, and not and just because because a satellite goes in a circular pattern, it is unnatural for them to make horizontal information in a grid without having to calculate it. So all I'm trying to do is keep my data as naked as I can in the beginning. And so if I had 100 shots in long and lat, they would look kind of like this in the chart. Instead of the northing easting elevation, you would just have two things. That would be a long or a longitude and a latitude, which either be degrees, minutes, seconds, and then the elevation would be in a different format. Okay, guys, so sticking with this concept, I copied a quick example, and that's San Antonio, United States is located 29 degrees, 25 minutes, and 26 seconds north, and it's 98 degrees, 29 minutes, 37 seconds west in the WGS 84 coordinate system. Now, for these coordinates to align and give you this accurate measurement, you're going to have all three. Now, seconds as they go around the Earth aligned to these meridians are going to be like the smallest increments that you go east or west or north and south. Now, for WGS 84, I cannot remember how big this grid pattern is. I'm guessing it is in somewhere in the region to a few hundred meters or to tens of meters. I can't remember, but I know there is coordinate systems that are more recent that have the same orientation that might be more definite. All I'm using for this example is WGS 84. And so if it has any more type of a breakdown or fraction or anything like that, like I'm not going to be showing it because I think this would be accurate enough. Now, let's just say we use that San Antonio coordinate and it was the corner of this pin, right? We shot in these 200 points, and we're going to say like 66% of our shots are all within like our 2 centimeter quality, which could possibly happen because over the course of our 3.5 minutes, there's a very good chance we would at some point get a phased fixed solution, which means we're bumping under a few centimeters quality. But let's just say it's a real bad fixed solution and we're only getting like maybe 5 or 6 to 9 centimeters, which is pretty rough to see, which you would only really see from like radio cell phone towers if you were using no base setup in that situation, which in case would not be accurate enough for you to do your legal in like say Alberta for layout, because 8 or 9 centimeters isn't enough for somebody to come back and set up an instrument on and recreate your survey without having a lot of error. So you're going to want to see like most of your error so you're basically going to want to draw a circle around whatever your tolerance for error is, which in my case in Alberta, I think for layout is something like 2 to 2.5 centimeters that the pins have to be congruent within for distance. So angle is incorporated into that over distance, obviously. So if we have a really bad angle on something, it's going to give us distance way out of this. But nevertheless, we have this picture of all these points. Now, what is the interesting thing you need to note about this picture with points? We want it to encompass all the points, but there's going to be some points that are so far out that we don't really need them because they were just bumping really bad satellite quality. And some of the things that could give you bad satellite quality, and in my experience of taking thousands of shots with the GPS under canopy, is if you have a low-lying satellite, meaning the angle that it is from this GPS receiver, if it's skipping across terrain, the horizon, you have water in the atmosphere from clouds, all kinds of different things that could change it, that might mess up your quality. So what you're going to want to do immediately is have the angle of elevation for satellites you receive to be at the maximum of, I believe, 15 degrees above your projected horizon. Any GPS will typically go from 10 to 15 degrees in my experience. Could be more or less. All I know is it will get, if you have it higher, then you're going to get rid of these low-lying satellites that are going to not give you misinformation. But it's just like kind of think of like a radio station that you really like and you're listening to it and all of a sudden it's just going staticky, and that's kind of like what it does for your GPS. So you can make out some of the words and not some of the other ones. You kind of know what song it is, but you don't know all the words, so now you can't hear it. So you kind of change the station, or you can't really listen to it because it's not giving you as accurate data. However, your GPS is going to try and use that data too, and sometimes it'll bump your quality up, and you don't want that. So you want your angle of elevation high to the horizon. In some cases, I've seen a GPS in the middle of a courtyard with 4-story high walls around it, and there is only like a 20 by 30 meter space. And so it's not very much, and it worked immaculately because it cut out all the low-lying satellites, and so the only signals we were getting were clear from above us in the sky, and you would find that this works. However, if the trees and everything are above you, you kind of need to rely on some mid to low-lying satellites at times. And so the thing that you need to know is satellites travel at around 14,000 kilometers an hour, which we'll write in here. Which I can't because my num lock is off, sorry. So if they're traveling at 14,000 kilometers an hour, and keep in mind, not all of them do travel at this speed because there is satellites at different elevations and they have different paths around the earth. So, but we're going to just say for a benchmark, our satellites are traveling 14,000 kilometers an hour. And the reason why you want to know that is because all you basically need to know is they travel a really fast, a really long distance over a short amount of time. And what that's going to let us know is that our geometry is changing rapidly over a 3.5 minute period. So after 3.5 minutes at 14,000 kilometers, well, you can imagine we've gone quite a distance, and it's much faster than you would be able to travel in a car or anything like that. So when the argument for going back and double tying is that you have a completely different set of geometry, but you guys have to understand the clocks that are in satellites are so accurate and their positions are so accurate that coming back later to double tie does not make your geometry any better or less, because you could still have some of these low-lying satellites messing with your geometry and some of them not. So in order to get the maximum amount of coverage, we're going to just do our 3.5 minute, like 200 shot, meaning one shot every 2 second method. So we don't have to come back, and we have to turn that into a crypto coin like currency so that the next guy can just take a picture of it with his phone, put it in his instrument, or take a picture with his instrument if he has that. But like I said, you would be able to do these surveys, a lot of them with just 2 cell phones. And so it could then broadcast from that location if you set up on it, or if you set up from any other WGS84 coordinate system, which is the first coordinate that it's going to send your instrument before you create a coordinate system. Then you would know that this point can only be matched by this picture, which you could put in a program like this, which would measure longs and lats in a coordinate like environment. So really the actual distances in a scale of how far these are from each other would work in a CAD program or anything where you could visually see the distance between these dots. All that is a verifiable check. And then the red dot would be the average of all of them. So in a lot of cases, you're just going to draw a circle around the amount that you want to show on your picture. So you might exclude some points and whatnot. And when those points get excluded, they're going to exclude the coordinate from your coordinate list that you're not going to use. Or you may have it included and just not have the points in the picture, but you're going to want to have all that just to prove how you came up with it. So you're going to have a whole list of 1 to 100 points, because we're going to keep all of them just for reference. So all of them will be then in this Latin long format. So you'll have 100 coordinates like that, and then you're going to have a picture like this that shows the correlation of those points to the coordinates that you recorded. And they should match pretty closely because one is a derivative of the other. And although instruments have been known to lie and can lie at times, you're basically going to prove that you've had enough geometry to establish that the most of these points are within your tolerance and are acceptable, but these are all the other ones you got, and you're only incorporating them to because you've collected them in the average, and they're going to be part of your Bitcoin kind of type like currency that you create that goes along with it. And so if I took those coordinates at that point and I had a list of them in 100 longitude, latitudes, and I have a picture that correlates to it, those now correlate exactly to each other. And where there would be discrepancies, like I said, there could be some anomalies or things that wouldn't happen normally, but all of these coordinates are going to be based off the 100 shots, static positions you took, and you verified you were static because you were on a bipole or a bipod on your pole, and you were shooting them in at a stationary location. So if you're taking a static point, that means you must be static. So if you're holding this with 2 sticks and slapping mosquitoes and moving it around, and you hold it on there for 4 seconds to get 2 shots, your geometry only changed by the distance of the satellites and your 2 to 4 seconds of shots. That's not going to be enough. But when you come back later in several hours to double tie and you do the same thing, well, over hours, you can see that amount of time would change your satellites drastically, to the point where some of the satellites that shot the original point might be there, and some of them that weren't there are now there. Guys, that doesn't prove anything to me, because you're not occupying the time in between, so that is not collected data that you can reference. But to me, if you do 3.5 minutes over the 200 shots, it's going to be close enough that if you threw a frisbee on that pin, you would get to within that distance no matter what, and you'd be able to find that pin with the pin finder. If it is not there and you had to tie in an eye hole, that gets into a whole other ball of wax. But basically what I can tell you guys is, if there was an eye hole there that I could establish that there was a pin there and I had to place a pin there, I could still shoot it in the same method and get a WGS84 cryptocurrency, which is a combination of the picture of the plotted points that correlates to all of the coordinates that I shot. So if I had either this picture and the local coordinate system, or if I had the WGS84 coordinates and the local coordinate system, or if I used the local coordinate system and had the local base coordinate system, any of those. But primarily, I'm going to use the WGS84. And here's why, guys. Because whether there's anything like within 12 inches of this pin, and I can't prove that I'm within a few inches using this crypto method, then you're either not going to be able to find it, or you'll be able to find it in a satisfactory way that will give you close enough dimensions on your drawing for planning and planning and calculating off and doing layout or subdivisions or whatever you're going to be doing. But you won't have to even go back to it, because it's a crypto, and because it's only the point that it's the only point that can be measured with a long lat at that point to the closest degrees, minutes, and seconds. No coordinate in that system is ever going to be no coordinate near that point is ever going to be the same, because basically I could tell you, for example, every pin in all of Alberta, we'll say, are all located at a different WGS 84 coordinate. However, there's been tons of times where there have been pins tied in, or construction sites or whatever, and they have a local coordinate, and it only correlates to the surveyor that's used that data. That doesn't help a lot of people. And so if you just had the list of the 100 shots that you collected over 200 seconds and a picture that correlates to it, and one being the middle and the average, and you took a picture of the plotted points and combine it with all the coordinates, you would have a crypto that would only be able to represent a point that is within your tolerance that you figured out from your average in the position of that pin. So let's just say, worst case scenario, we didn't get our 2 centimeter quality like we did in the middle, but we were 5 centimeters off the pin if we could prove it with some sort of conventional robotic method by coming off the other pins. None of it matters, guys, because the plan and distances on these or the plan distance and angles on these plans never ever match. First of all, what you'll find in the field, because some surveyor could have came along and spun this pin or moved it, or just to get it to fit his survey. There could have been somebody that moved the pin entirely, but um, the important thing is the plan distance and angles are historically there because it was harder to find the pins without any kind of angles, distances, or directions. Angle or directions or angles, because just because of the survey methods and technology available at the time. So if this was 100 meters across the frontage of a property and this pin was here and all four corners of this property were here, 100 meters isn't really how much land you have at the front. It's really the distance you have from your placed pin to your placed pin. And all the surveyor is doing in any situation when he ties those in is just to verifying that the boundaries of your land haven't really changed from planned or distance. But nevertheless, he's going to have to accept where they are at unless one of them is like grossly out in comparison to the other ones, in which case he would not use it for calculations and he would have to go further to find another more accurate pin. Guys, you can see how this can take a long time. And so what I'm going to say is, if you tied in a pin anywhere on your project and your average seems to be out from all your other pins and you're out more than a foot or so, you could drop that pin and just use the other ones and figure out your angles and distances that way. But all I'm saying is, if you tied the pin in with this picture method here and the 100 coordinates that you have tying to it in WGS 84, that information can be given from any base station setup that you have anywhere, and it will give you RTK data. And so all you have to do is take those WGS 84 coordinates, put them on a page opposing this, or have this in the corner, just because they are all scaled and they are based off the coordinates. And if you flash a picture of that, and the red one being the average or the differential color in the middle, whatever you choose, and then you have the 100 points in longitude, latitude, and they correlate, that's crypto, because you can't recreate it. You could only get close to recreating it, but you have to be able to recreate it at any time. And because satellites are so consistent and they track the movement of the wobble in the earth and the direction of the sun, stars, all these things, it's basically going to make your data really tight and recreatable. So if anybody else had to come back just to verify one of your cryptos, they could just take a picture of it, put it into their base station or their receiver, have their base station set up, and then they could hover over that point in the same spot. And then so you never have to bump or move pins again. You just take them for what they are, the governing boundaries, and not worry so much about the plan distance and angles that were derived a long time ago with different instruments. But you could just check that they're within a reasonable amount. I would say if they're more a foot out from plan distance and angle, that point may have been altered or moved, and there's a lot of things that could have come into that. You'll have to figure them out on your own. But all I'm saying is then you might want to drop that point and find another one, but you won't have to tie it in again, because nobody's ever going to find the position any more accurately than you did just by using this simple method that anybody can do. Okay, so I went over how we would make that crypto. Guys, we are into this almost 5 hours, which means I'm probably going to have to break it to upload it. As you can tell, I'm kind of losing my voice, but we've really covered everything that's going to give you an advantage. And as far as this crypto method for tying in pins, guys, that's going to be basically used for long distance measurements, like around sections or areas of land and long right of ways and stuff. But you won't have to retie them in again if you have a crypto for it, because you'll be able to find that when you set up your base station in WGS 84, setting it over any point, and you have a system that correlates to it, you won't even have to set up over where the last base was set up, because whenever you set up your base anywhere, it's going to project the WGS 84 coordinate to that base station within under a centimeter typically, or under 2. And then your quality plus that in in on your shot point and then your average points, you shouldn't be more than like several inches off the point. And this is based on having a 200 shot method at static position. And so whether you take a picture of it or not, or however you prove it, you just want to know that the plan distances and angles are just to find the pins that govern. It's not the boundaries that are designed that govern. So it's all about how the survey laid out those pins and they govern. So if the top of this pin was ripped off and moved 10 meters this way and the bottom was still there, the bottom governs in, like, say, Alberta. And that would be the original pin that you'd have to revert to use, whether the distance and angle was out from the top. And I've seen cases where that's happened. So because we're getting so far in this video, I just want to show where this would be applicable. First of all, anybody that has like land in Alberta, say that it has to cover lots of long distances in order to tie it in. Double tying is not always practical. It costs a lot of people money and the surveyor a lot of gray hair, and the rodman a broken back from having to get out and do the tie-ins for the survey, maybe for the surveyor, maybe, I don't know. But all I know is you could recreate it very easily. And I know based on my experience in GPS, this would be very close without having to double tie. And you could calc off of it because it would be within a reasonable tolerance that if anybody had to go back and find that pin, they could set up their base receiver anywhere and get to it with that crypto that they snap a picture of and enter it in their GPS as a coordinate. So what will that coordinate be if you just want one? Well, it's the average. So it's the red one that's in the middle, and it'll be the last one in your list out of 100, which will be the average point. And you'll have to highlight that in the color that you use for your crypto visual. But these will be just like the written book basically about all those points. And so you won't be able to recreate them perfectly ever, but you will be able to use that average point and get within a frisbee size, small frisbee size distance within that pin, which means you'll be able to find it. And that's all that matters because the pin governs. So anything under a foot when you're doing like big long surveys in the rural county, your plan distances and angles only got to really be within like that tolerance to find it, because it's still going to be the pin that governs, and all you're doing is giving directions and how to get there. So if you do use that method, just make sure if you have right of ways like this crossing your property, you tie in all the pins where they cross, but then you don't tie them in anymore if you don't want to. Anytime you show up to a job where they had this crypto method handed to you in a WGS 84 coordinate, which could be published in the registry if you wanted it to be, you would be able to get those points into your survey, and then all you would have to do is calculate your layout, like subdivision, etc., and then just lay it out and then collect the points in the same method without double tying. This gives you time for like me, where I like to have a couple cigarettes during the day, usually about a pack, and I need little downtimes to have them, and the rest of the time I can be doing something efficiently, and besides driving all across the country to get back to a point that I could already prove if I was just there for 200 seconds. Okay, so now that method will be good in the legal surveying, but guys, we're getting to construction, and it wouldn't be accurate enough for you to set up your concrete and pilings. Well, maybe pilings, maybe location of your job. Yeah, it would be accurate enough. But to get all your network on your site jiving, we're going to use kind of a similar method to our military method. But even though you could tie in your pins in this fashion, the fact is, if this was a smaller lot with pins on all four corners, unlike the largest rural subdivision one, having like say 6 or 7 inch quality between pins isn't going to be accurate enough for you to determine several things. And one of them is you're going to have something called a minimum setback. I'm not going to draw it because I'm obviously failing at drawing right now because I'm not concentrating. So we'll grab a line right here. I'll do it anyways. Let's say this is your housing lot and this is the east side of your property and you have a minimum setback. That means that your eaves or anything that could burn really, like your house or the materials on it. And the reason why they exclude gutters is because they don't really burn very well because they're all made out of like tin, aluminum, or whatever it is. But it's basically, in a lot of cases, it's to keep you away from the boundary, and it has to do with a lot of what it has to do with is fire protection. So you're gonna have your but there are other factors, and you're gonna have to know them for where you live. But let's just say your building was gonna go here, okay, and your eaves are extending out, and everything on that building can't cross the minimum setback. And we'll just say for the sake, it is like 1.5 to 2.5 meters. You're going to want to calculate that. And if you're out 5 or 6 inches, and let's say you're doing industrial commercial, that means you're going to be building maybe 0 property line. So unless you were the guy that surveyed the original survey and happened to lay out the building at the same time, you're never going to be able to recreate this survey 100% accurately without having a discrepancy of how far you're past or over this line. So I'm going to just show you a trick that I could use for setting up machine control if I wanted to go make $200 an hour by running a site with machine control and doing really minimal work, but being as accurate as I can be. So we already decided what our method was there for tying in and making this point crypto. And when we make this crypto, guys, if we're under canopy or whatever, it's going to have a little bit of error. But let's just say we could do it on all our 4 corners, and it would be accurate to 1 or 2 centimeters. Still kinds of leaves us a problem for the stickler surveyors out there who, if they build 0 property line and they don't incorporate that 2 centimeter error, which would be kind of an odd number for all the 4 pins. But let's say your error ended up being 2 centimeters and you were 2 centimeters over the property line with your building. Like, let's just assume it had no eaves and you were in the industrial sector and you're trying to maximize space. Somebody could say you're encroaching, and then that way, whenever the bank ends up owning that building and they get to do an RPR, real property report, or certification in BC as it's known, I'm not sure Saskatchewan did not do legal in Saskatchewan, just exploration. But they're going to say that you're over the minimum setback because they didn't lay it out and they wanted that work or whatever it happens to be. Now, if you do incorporate an error, all you have to do is always add the error to your minimum setback, therefore moving you further away from it. And if it is a small enough error that it doesn't matter, okay, and I'll share a few things with you in this process, but if you add the error to your minimum setback, okay, and then you add the error of anybody's survey that could recreate it. So if they came with a robotic total station, a 2-second gun that can measure the parts per million with a laser, and they shot from here to here, and they incorporated all your evidence, and then they shot the corners of your building, and they could find that 2 centimeters happens to be where your building is on the other side of minimum setback, they can't really do or say anything. But if the bank owns it and it's over, then now they got a problem because somebody says it's encroaching, it may be a fire hazard, and then now they have to modify that structure or the property or the neighbors in some way that would meet the requirements for either fire protection or anything else. So you do not want to ever build over a minimum setback unless you have like written permission, because it won't matter. And the only time I've seen that, guys, is when a hole was dug for a house in the wrong spot and I came and showed up and we decided to move it forward based on the fact there was more room in the front of the lot. And we got permission for it from the local municipality because it wouldn't have hurt anything. And most of the houses on the block were already moved forward anyways because of all the terrain in the back of the house. Now, when that happens, just make sure you have permission and you're aware that there's going to probably be a minimum setback on the front of the lot too. Now, anytime you're doing residential or commercial, most of the time you're never going to have a minimum setback that is 0 on one side and 0 on the other side, meaning you're not going to have a structure that is your max footprint on the property. The only time you'll really do 0 property line, which means you'll bring this building right to the property line, is when it tends to have like almost no overhanging structures or eaves, but in some cases could, and then that just has to be incorporated and move it over a little bit, in my mind, like, because otherwise what is a minimum setback? But anyways, let's say it's 0 property line, you're in industrial, but residential commercial, you're always going to probably have a sideline minimum setback just because it's just different in residential, and then commercial. Commercial in the city would be considered a lot that industrial clients would acquire, and so for commercial as well, I would see a zero minimum setback. My opinion is if you can establish these boundaries with a very low tolerance, and you add the amount of that air to the inside of the minimum setback, then if you build at zero or zero minimum setback or whatever it happens to be, including eaves or whatever, and you build with your property line at zero, but you added the air of survey, then you know that the most you could be out is at zero property line. But because you went a little further, you should be okay. And then another little piece of advice I could give you from knowledge I have is that anybody that comes back and replicates the survey, whether they use GPS or they use the robotic total station, which would be much more accurate, they're going to be able to find out that you are either over or behind that minimum setback. So you're going to want to make sure that when you build this property, you're using a very tight control system that you can prove the raw data with. And so if you are a construction outfit, all you need to do that is save all your raw data in your instruments. And if you get called into a court of law to prove it, you can do that. And I will give you what you need to fight that battle. And really, that is just the raw data. So that could be your WGS 84 coordinates that you have. It could be the local coordinates as they correlate to each pin and your stuff on lot. Now, the problem that you're going to run into when you're setting up machine control is, let's just say, for instance, this is your building and this is how much of the lot it's going to be taking up. And you're doing a commercial apartment building. It's square. There's parking all around. You want to know how to set up so that you could tie into the sidewalks that are going around it, we'll say, and then maybe grass that is the neighbors, and then like a back lane or something like that. I'll show you how to set up the machine control from beginning to end so that you are totally jiving. And what I'm going to do, guys, is this our map is getting a little convoluted. And a lot of the construction stuff I'm going to describe now isn't going to work for our war scenario, because we're not going to be building like concrete foundations with pilings and stuff like that. So it was fun for a while. So I just have to mention a couple things about the cryptocurrency you would need for the hypersonic missiles. And guys, that's just to recognize stuff like stars, the moon, solar angles with the sun. Can't use the crypto on the sun, but you could on the moon, and definitely on the Earth's surface, guys. The Earth's surface is always changing, so it is constant crypto technology. So if you have a hypersonic missile that is installed with a ground sensing technology, and that ground sensing technology is recognizing the lay of the land as a crypto based on it's the most recent activity that's been published on some sort of like public forum, or maybe it's like NORAD that has it. And if it's not jiving, you could just make full safe measures to be able to recognize the moon at any time during its cycle, the sun, and also the Earth's surface, the moon's surface. And then because the moon is always facing towards the Earth in the same pattern, or at least relatively close because of its spin and its travel around the sun, around the Earth, you'd be able to use the change in the surfaces of the moon as an identification marker of whether or not this missile is in the right place or doing the right thing. So the hypersonic missile, in my theory, would just be like, it would if you wanted it to be completely navigational free from GPS, meaning our WGS 84 coordinate system, and you wanted it to be pre-programmed to have fall safe measures in order to not fall into the wrong hands, or have to, or the onboard would have to complete certain crypto functions based on the moon's surface, the stars, and all this, the angle of the sun, and then also the detail of the terrain that it's involved, right? So, for example, if somebody tried to launch a hypersonic missile at like Detroit, right, and by the time the missile was passing over, let's say, the southern United States, if it wasn't getting the right accurate current data from the lay of the land, it would either shut down, fall into the sea, or maybe it would not know where it is at all because you pre-programmed this for your enemy to fly back on them using the stars or whatever. So it's all going to be based on these guys. You can figure out how they correlate. I can't go too much into it because I don't really want my video to be removed, but you'll be able to get the gist of it. And so there is a way in there that you can make them full safe. Guys, a lot of this is going to bring us to a conclusion in our Army scenario, or our pre-World War III scenario. And that conclusion, guys, is no matter what, no matter what war you fight, when, where, in the history or even the prophetic history of the world for some, it is going to have to be a battle that is won by boots on the ground, and they're going to have to be young individuals, and they're going to have to be ready to get dirty and defend themselves, their country, their race, their religion, culture, whatever it happens to be. And so politicized religion and all these things are going to have to be something you take into consideration. But my end game theory is that once you understand all this technology about hypersonic missiles and stuff, you won't see the threat of them much anymore, based on how they're programmed and how you'd be able to mess with this data. So if, for example, you had the moon as one of the crypto recognition devices on these satellites, and let's just say you said, okay, everybody's allowed to have hypersonic intermediate range nuclear weapons, and they have to base them off of moon crypto, solar alignment, stars crypto, meaning all of the very finite azimuths that we can measure and visualize in the stars. However, we can't use crypto in the stars because they're too far away for us to visualize the surface, and let alone the surface of the sun. And any planets that are closely able to inhabit life like the Earth are too far away for us to use the crypto on that as well. And in any likelihood, a hypersonic missile wouldn't be able to read that anyways, but it would be able to read stars, moon, sun, and Earth's surface. And so if you had a full safe measure that anybody that had these missiles was able and legally allowed to send and detonate them on their own land, that would really be the only way that you could program them, because nobody would really do that. And of course, a lot of this is theory extension right now that I'm thinking about, but I have thought a lot of these processes. Anyways, if you could get to the point where, say, if it had to use the moon, for example, for a certain launch, and in a measure to disrupt its ability to detonate or whatever, there was also a hypersonic missile sent to the moon, and it blew up on the surface of the moon that we always see. All of these rockets would then be null and void in their capabilities, because when they launch and then they detect where the moon is and its pattern that it's supposed to be seeing at that time of day and everything, and is drastically different, then you would know the missile would have like a shutdown protocol or something like that, so that anybody that was in possession of them couldn't use them if they wanted to. Because the only other way you'd be able to use it if you wanted to is if you could have it linked to GPS or something, in which case the accuracy wouldn't have to be so bad when in a nuclear explosion to make it destroy everything in its area. But the whole idea is it doesn't have this available. But if you had both available, you could either mess with the sinusoidal data on one or the other and drift it into the sea, or have it go through a protocol where it just disarms and it just ends up being a large paperweight airplane with a rocket on it. So you can figure all that stuff out for yourself. But because I got to keep this to surveying and it's been long and exciting, we're just going to move back over to here to how you would set up your machine control. So I'm going to pause it for a sec, and then I'm just going to draw that up a little better, take down some of the notes, and then this will be the end of the video and the audiobook. Thanks, guys. Okay, guys, there is some notes I'm obviously going to keep up because I showed you the crypto method here that correlates to the WGSA 84 coordinates. We're not going to use the setup our system that way. First of all, what we're going to do is we're going to use our robotic total station with a line of sight We're going to find the longest line on our site. So imagine this site had a radius maybe going around this corner, or maybe an odd angle here. It's just an odd shaped lot. What we'll always do is we're going to look into our survey drawing that we get with it, and we're going to see what the tolerances are for where these pins must be laid out. We know they're never going to match because the surveyors probably spinned or used these pins. So whenever we set up construction control, we never want to use legal evidence for it because it won't be accurate enough for what we want to do. However, it will be accurate enough for our location of buildings and stuff, as long as we incorporate our arrow in the direction, away from the direction of our minimum setback, which should always only be on one or two sides of the building. So, in short, what are we going to do? Well, let's just say there's a coordinate for this corner, this corner, this corner, and this corner. If I set up a robotic total station anywhere on my site, or like close enough to these points that I could get distance from the longest side, or if I set up on this point and distance to the longest side, which would be more accurate enough to begin, which I do recommend. And there's no building here. You got an empty site. You want to set up machine control. You can kind of adapt our military method, which is why I left these two X's here, but we're going to call them piles now, and we're going to move them to a much different location. So we'll just redraw them, and we're going to assume that they're just maybe in the corner here, and then maybe in the corner here, because once our building goes up, we're not going to be able to see through it. So I don't want them across from where anything is going to be built. And also, I'm not going to want them in any pavement, concrete, or anything that's going to have to move anywhere during the duration of the completion of the project. So say this was a large apartment building on a commercial lot, then or a large residential lot, however you zone it, or in your mind, or whatever, or an industrial building on a commercial lot, or a residential building on a residential lot. You're going to pick the longest line, and then you're going to apply the difference of guaranteed, and this is what they say on their survey drawings, and it doesn't say guaranteed, but they are saying the tolerance will be within a certain amount of either centimeters or decimal feet or inches or whatever it happens to be. It might be in neither of those ever, but it will be like usually in centimeters. So in Canada, say in Alberta, so let's just say it's like 2.5 centimeters that they say these pins will all be within congruency of each other. We're gonna have to remember that, but really not for right now, because first we're gonna just set up and see how close they are. Now, guys, when you're setting up anything with total station or robotic, I'll give you a piece of advice that will help speed things up. You will have something that most surveyors want in their survey, and it's called PPM settings, or atmospheric settings. And it's basically going to be three things, guys. And it's going to be the barometric pressure. So we're just going to put pressure, air pressure, whatever you want to call it. But it's measured in, like, we're going to say typically around where I'm at. Let's just say it's like 900. And it's going to be HPA, I guess is how you measure it. I can't remember. But anyways, it's going to be like in the high, where I'm at, the high 800s to low 900s in Alberta. So it's going to be pressure, and then it's going to be temperature. And you're going to have the last one. So pressure, temperature. And there's the last one, guys. I got humidity. So that'll be like the atmospheric humidity and percentages. So those three main things are going to be called like your PPM settings, are really atmospheric settings that give you a PPM differential that you could apply to your survey, and then it gets your information more accurate. But let me tell you something about the history of surveying instruments that I happen to know. Since we've had a theodolite in the 1980s that has a laser and an angle measuring device, which usually has to be like an etched glass or something like that, it is extremely accurate, you guys. So you've been able to go around the block for really the last few decades and tie back into your original setup on any city block that you happen to be in, And I can do it and have done it, like perhaps say like in the Okanagan, where we never put in ppm settings or for our atmospheric settings for surveys, because BC guys just do like to make their legal stuff more efficient, and I like it, and that's why I liked working there in legal. I have not liked Alberta legal as much because of all the double tying, the vast amount of land and all that stuff, but I have enjoyed it for construction and other things. So we are talking just about how to set up machine control so it is accurate, and that so your construction ties into all the things it needs to. And I'm telling you for a fact that if you put in atmospheric conditions like pressure, temperature, and humidity at any time that you're surveying anywhere, you're wasting your time. And let me tell you guys why. The atmospheric settings are only going to be changing your survey in parts per million, and really the distance measuring device, the laser on your instrument that measures to a prism, which is a very finite centered point and comes back to it, is going to measure in like 4 decimal places, which means you're going to have tenths of a mil on it. So to change that parts per million is not going to affect you anyway, because you're never going to have to lay anything out in your life on any construction site at more than 4 tenths, or really more than 3 tenths of a meter, which is a millimeter. And even when you are, it's probably going to be like 3 millimeters by 3 millimeters, and then maybe 2 or 3 millimeters for elevation. So you just think like a little 2 or 3 millimeter end of a pin, like you would put in like a cork board on the wall. It's going to be less than that, and that's going to be for anything steel, like pile capping, that where you have to weld, etc. And in a lot of cases, like say in commercial or whatever, if you do have that pile capping or whatever, it's going to be covered in concrete, or it's going to have a steel structure put on there that has a field fit on the piping that's over usually 100 mil or close to. So they're going to be able to field fit a bit. But with your robotic total station, you'll even be able to help them then, so they can cut and fit on the ground, fly it into actually accurate, a very accurate place based on their isometric drawing, because the rise and run will never be the same as the actual as-built position, just because of all the error that gets incorporated through the survey. So I'll teach you how to minimize that error. But the thing that you first need to know is atmospheric conditions don't really mean anything. But if you did set them drastically different, you could get a different answer, and it would it would be like setting your temperature to like 4,000 degrees, or the max your instrument would let it, and stuff like that. And you're never going to come across that. So my recommendation, guys, and this will work in any situation where you have to recreate these methods or recreate this data. My advice is, what I do is I would keep my pressure, temperature, and humidity, or whatever atmospheric settings I have to put in. I will keep them at a constant year-round setting. And why is that? Well, because weather is easier to measure historically and what actually happened based on how it was measured at the time. So when you put in ppm settings, or atmospheric settings as we're supposed to probably call them, I'm just calling ppm because it's short and that's what they relate to. If you put them in the morning and you're just using a standard little weather measurement device that has these on them, you're basically predicting them for the day, and you're not going to know how to predict them for the day because they're so sporadic and they will change so often just in the time that you're inputting them into your instrument, that you will not to be able to accurately get these. But if you always have your instrument set to the same preset settings, it is easier to go on the weather channel or weather network or on your app on your phone and look for what the pressure, temperature, and humidity were for that day at the time that something happened that is under investigation. Then you can apply those to what your generic settings are, and you would get the difference. In most cases, it would be so small or insignificant that even a police officer recreating an accident scene wouldn't be able to incorporate them, even if he was using like a physics professor to do all of his calculations on an accident scene. And like, I mean, like, you could just imagine that what if the tire prints were just a millimeter one way more, and everything else just transpired the same. Using your physics calculations and stuff, you wouldn't be able to really calculate much of the difference. And So all I'm telling you in short is atmospheric conditions. If you want to stay up to date and you don't want to waste time putting that stuff in the morning because you're only predicting it, use the historical, compare it to what your generic is, and then that's how you could recreate the investigation if you needed to. And so even for you guys that might be RCMP or police and you recreate accident signs and you're like, hey, you know, I'm predicting the weather when I'm putting these in, and I already have an historical evidence of what the weather is. You could use this method, look up the historical method, apply the ppm settings to what your actual measurements in that were, and you could see if it makes a difference. And if it really doesn't, then you know you're wasting your time doing this too, because I've worked for a land surveyor that's been in the field for really more than 30-40 years, and he didn't make me put in ppm settings. And there's a lot of people that aren't even doing hard notes uh, for doing legal in British Columbia, which I love, because you could just save the raw data off your instrument as your backup, and if you go to court, the numbers are the numbers, guys. The notes are never going to take precedence over raw data that's provable scientifically and otherwise couldn't be recreated. So raw data, always save it. Always save your design and layout coordinates, and you should be able to cover your butt. Okay. Because of the errors that we're going to find in the pins on our site, and because I am doing like a 4-corner lot now, I'll just show you a couple things to watch out for. But in order to do that, I just want to draw the pins on the other corners. So I am going to grab my circle here, get the size, whatever it was that I used there. I don't remember. So we're going to just say these pins were all placed by us. So they're circle and there's nothing in them. Or no, sorry, we're going to say that we found them. So that means they're black still, and we're going to fill them in like this. So they're all found pins. We didn't post it. We don't get the luxury of building zero property line without anybody being able to bug us about it. The other thing we can do here is, guys, I'm going to take what we got for line, or no, the right of way we could still say is on there. I know I got to get going here, but this is going to be everything you want for machine control. My favorite subject when it comes to construction, because it is, you guys, and we'll write this here, it is documented that it is 66% faster at building your civil. 66% faster. So all the grading and stuff like that, you could have done 66% faster, which in my mind means your machines are worth 66% more, but you'll be out of there in more time. So if you change your hourly by 66% for the rate for the machine after you upgrade it to dual GNS is what you're going to want for a machine. So basically all that is a fancy way of dual GNS capabilities. I'm going to put GPS because that's all I ever say. I don't care about all the other names. So machine control 66% faster with dual GPS. And guys, most of these can be done with just a few cell phones mounted onto some survey equipment, and as long as you have the schematics for your machine and some tilt centers, and you know where you're mounting your tilt centers, and you have the schematics for for what that machine can do, you could program those two cell phones with some distance and offsets to the machine and those tilt centers to do the same thing as our supercar machine control current GPS setups, which is it was a much smaller market controlled by very big companies that occupy some of it. But you guys, there's a way into it. You can figure it out, and even if you had to acquire this equipment, it would still be worth it for the amount of production that you can get and the amount that you could bill out a tech or the machines for. So just imagine the price of your machine going up 66% per hour, but your labor is going to go down because you're going to need no gradesman for that guy, and then you're going to not need any stakes from the surveyor from him, and then he's never going to be slowed down, so he can pretty much go at maximum capacity. You're going to do a couple surveys to tie him in to, like, say, sidewalks going around or asphalt or anything going in. But other than that, you're just basically going to be using these pins to orientate the building, get it off your minimum setback or right of ways that you can't be on, and then you're going to be able to go. But just to remember, the pins that govern the boundaries of the lot, all that really does is control the fact that there'll be a utility right away somewhere around your property, outside the property lines, but probably between your concrete and your property lines, wherever it is, or asphalt or whatever. And it's just establishing that that belongs to either the city or the municipality. And then it also gives you the amount of land that you were proposed to have. The pins will be a little bit different, as they always are. But for now, we're just going to assume the building is not here, but that's where the footprint of the building is. This right of way is not here. That was from our military scenario, but this minimum setback here is there, guys. And so we're going to just say we're far enough from it and our eaves are coming out. We're not building zero property line, and we're going to have parking all around, and we're allowed to go right up to property line, and it doesn't really matter if we move the building 5 centimeters one way or the other, as long as we're not hitting any of the minimum setbacks or other or we're like a fire hazard to neighbors or anything like that, right? So how I would do this is, if you want to do it really quickly and but you want to be accurate, on the way to your job, you're going to have your file with plans, distance, and angles for all these angles around your job. You're going to need a little information how to calculate those out. So they're going to be either in bearing or they're going to be in like an azimuth is related to true north. And so typically they're all going to correlate to neighboring lots, although I have seen different azimuths and angles on lots that tie to the lot that I'm on. And that's because the person was too lazy to just assume the same angle and then make all their angles the same. So you're going to have to watch out for little things like that. I highly recommend always having a legal survey involved in your process, especially if you're doing machine control. Just don't let him do any of your laying out or setting up and all that, because it's going to take time, and most of the methods he has are going to be outdated when it comes to machine control. But you do want to make a little work for him. So my recommendation is that you have the building certified before you pour the concrete, meaning like it's easier to move forms than it is to move concrete. And if he's bumping you over like mills this way and that way, he doesn't know what he's doing, because you've already incorporated that error in your survey to make sure you're not at minimum setback. Just a piece of information for you. If all these pins do tie into, like, let's just say 3 centimeters of each other for position, based on the angles and plan and the distances, that is pretty good. But you got to remember, you're going to have to add that error to your minimum setback to get where your building has to go. And the reason why you're doing that is because you don't know which way your error is going. There is ways of figuring it out, but this is just the quickest and easy way of doing it, so that you don't end up on the other side of your error, which would be towards the minimum setback. This will take a little time to go through. I am losing my voice, so I am going to take a little break here. But this should wrap us up with everything construction. We've already done a lot of legal. There's a little legal in this, and the seismic stuff's already done. So once you get through this, guys, that is all for my audiobook, and I hope you enjoyed it. Okay, guys, I am back. I grabbed a cup of coffee. Like I said, my voice has been going a bit. We are into this a few hours, and I just want to see how long it is now. We are 5.5 hours for this audiobook, but I haven't read a book in faster than six hours that could teach me everything I need to know about surveying, and I have been requested to give somebody books or a book that they can learn everything they need to know about surveying, and it's not out there, just in case you've known it or you know anything about the subject. So I'm going to try and get back to where we're at. And you guys, that's for anybody that wants to set up machine control. Once you're done the step where you can set up machine control, chances are you're going to have the technology on site, i.e. a robotic total station, to do all of your finite grading, whether you want to set asphalt with a machine that has a 360 degree prism that is on the grader or mass that's spreading your asphalt. And then you're going to pack it. There is a few measurements you're going to want to take into consideration in any step, whether you're grading and then packing and then grading gravel and then packing. as you can kind of figure out just from the description, you're going to have a little bit different of a vertical cross section, meaning like the height or elevation of that top of gravel or asphalt will be a little bit different based on the grade you cut it at, like the calculated digital terrain model, which just means the invisible surface that you're grading to, and then what it's going to be after you pack it. So depending on your soils and materials and where you're at, I've seen sand that you can wet and pack it as much as you want. It's just going to spread because it is too silty and it doesn't meet the proper standards for the 100% compaction that you're going to want on all your compaction stuff when you get the quality control to test it. So my advice is just pick a little area of your site somewhere where you can just lay all 3 or 4 whatever layers of material that you're going to have till the end grade, and then just do a kind of run through in that little area of pack grade, pack gravel, and how much your material is packing to get your 100%. This would be something you have to do to be completely accurate and up to grade. If you want to just little cheat sheet of what you got to do, you might already know in your mind how much your loam or your clay or whatever your subsoil is, the original ground might pack where it has to be moved. So all you're going to do is add that vertical offset to where you're grading. You're doing your first grading at, like, so say with a cat or grader that comes in and you're removing original ground and daylighting around the edges. And now in industrial, it's going to be entirely different. And now, so I've done the earthworks on industrial CPF access road, so central processing facility, and the access road over 6 kilometers. There's going to be a lot of things you got to watch out for in that situation. I could tell you a few of them and the ones you definitely want. And you guys, this goes way back to when we were getting evidence for the seismic and giving it to the legal, and then now the legal is primarily going to use like a section evidence and not the ASCMs, but really the boundaries of your project to determine your coordinate system. So what that means is ASCMs that you originally used in the seismic won't be any good anymore, even though if you do tie into them, you can correlate the data to the section evidence that laid out the lease and boundaries for your site. However, a lot of the time you're not going to have enough of them, and they're not going to be in the positions they need to be in order to not accurately do this, because you could do it accurately with that information, but the problem is it might be in a coordinate system that is involved in something called basically an ellipsoid, or in other cases would be, you could call it a geoid. And basically it means those circles in the WGS 84 that go around the Earth tend to be, well, they are in arc-like circular patterns that are very definite and measurable. Okay, but when you involve elevations, the surface of the earth is basically like the shape of the earth. It's more like kind of egg shaped in a way. And so they're going to be irregular elevations despite the gravitational paths of the earth, like that satellites would go around. So kind of in short, to describe this is, if you're going to do any type of municipal road building or anything like that, you're probably going to want to be in a coordinate system that is like GSD 95, which means that all your elevations are going to be within a certain amount of error from the actual elevation of land where you're at. And so the majority of the time they're going to be in such a close area that you could hold these elevations when you're in your design. But no matter what, the number one rule of thumb that I always use, whatever coordinate system I'm in, I'm always going to take the existing and tie into it. However, when you have maybe flow lines like in the SEGD situation we were talking about earlier, where you're doing the oil sands, those flow lines are all going to be on lease sites. And when it's on a lease site and typically it's been drilled by a rig or something, all you're going to have is the coordinates for that lease site and access road, and however it ties into the main roads like highways and stuff, or the rest of the property, and however it ties to the ASCMs, whether they gave you ties to that or not. Um, so typically it's going to be in a coordinate system that has some sort of ellipsoid model for the surface of the earth. Now, that's not all that important, but what it is important for, guys, is, excuse me, actual ground distance. So if you pulled an actual meter with a tape, and assuming you did all the right chain calculations, like for the temperature and everything, and you got 100 meters across site, and you knew 100 meters was 100 meters no matter what, that's fine in a flat plain environment, kind of like our Call of Duty environment. However, guys, that distance will be shorter than the distance that you measure the same distance with if you use the GPS with any type of an ellipsoid in it. And in some cases, or I guess in a lot of cases or all cases, it could include just a curvature of the longitude and latitudes. But in this case, it's going to involve a different coordinate system that has a geoid. So GPS distance, if you look at our meter and you took this line and you're looking at it from sideways and it was exactly 1 meter long, and then you measured it with the GPS, so say it was not 1 meter long but like a kilometer long, and then you measured it with GPS, and there was a curvature that was going over it, you know already in your mind that line is going to be longer than your actual 1 kilometer line. And why is it like that? Well, basically, guys, because a meter is a meter at sea level for GPS. But as you move up from the Earth's surface, the UTMs or any coordinate system you use is going to have to be projected, and it's going to become longer because it is in a curved line. So you can go through all the theory of that. I've been through it a lot. And basically what it means is when you get the coordinates for your wellheads or well sites, or the wellheads on your sites, they might be in a different coordinate system. And we're just going to say, for argument's sake, it is like one that I've maybe seen in my career a couple times, or not a couple times, a lot of times, but in legal doing oil patch work. And I think it would be, off the top of my head, like NAD 83 or NAD 87 or something like that. Or maybe there's both of them. I can't remember. I think there is. And they're going to have, not only may they be shifted to different areas, like by, say, like several hundred meters, but they might also have a scale factor. And that scale factor means that if you want to get the distance of that long line that is in GPS into a local 1 meter is 1 meter line, so with no scale factor, you're gonna have to apply the scale factor to the GPS distance. Okay, now where this comes in to play is, like, for example, if you had your well sites a long way from your central processing facility, and I have seen this and how it costs millions of dollars, and that's not even talking about the errors in machine control that we're cutting and recutting at wrong elevations, why we were laying out to different coordinates and stuff on a major central processing facility. Guys, this was a site where at peak construction they would have 6,000 more guys on site, and it could have been delayed easily day by day by just 5 to 6 guys surveying and only one guy that was calculating everything. And he was sitting down with the project manager, axing stuff on the site and adding stuff that he and the project manager felt needed or didn't need, and it was really based on the limitations that he could calculate or conceptualize the project. And so ultimately the road that we had, that was the common highway, was about 6 kilometers away from the site. And so whatever we had for coordinates on that road that would have came from legal data and been converted into a coordinate system that needed a scale factor to go to the plant coordinate system. In short, what would happen is over that 6 kilometers, we end up losing like about a meter or so, or a meter or more, or less than a meter, but it was significant enough that the center of our road didn't tie into the center road of the central processing facility by about a meter point two over that 6 kilometers, and it was because the scale factor wasn't applied. Now, I can't totally prove it in that situation because the person that was calculating the roads was doing it wrong. They weren't just holding center line of road and adding different arcs to each different side of the road based on the center of circle or the center of those arcs, which should have been the same, meaning they would have different lengths on each side of the road. They would just, for example, calculate the inside turn angle, copy it, put it on the outside, and then just make the lines longer for that shoulder of the road. But as you can see, that doesn't always work because with an arc distance, the arc on one side of the road is going to be longer than the side you're turning to on the inside of the road. So anytime you're doing piping or anything like that, which is where this really was costing the money, in particular on another project with about the same size and variables, and as well as a SAGD, you would know that piping doesn't tie in very well at 1.5 meters. So if you go over about 1 kilometer from your well site, if they gave you a coordinate system that was in an ellipsoid or geoid and it needs to be converted to a plant coordinate site, if you do not apply a scale factor to the base distance, meaning really that wellhead and whatever you held as your baseline from there to your coordinate system on site, if you don't apply the scale factor, in most cases it's going to be like a 0.99 something. You're basically going to lose a few, maybe a centimeter or more, or under 2 centimeters, or centimeter to 2 centimeters per meter. So if you go 1 kilometer, that will be obviously 1,000 meters. So if you lost 1,000 centimeters, it could be up to, if you went 1,000 meters being 1 kilometer, your scale could, if you're losing like a centimeter, a meter, it would be at like 10 meters, right? But the scale factor is actually smaller than that. It is like a 994, whatever it would be for your geoid system to get to the plant system. You're gonna have to apply it because and this is not a question that you might be able to figure out right away, but you're gonna want to talk to a legal land surveyor for it, hands down, because the seismic guy is gonna know nothing about it and the engineer guy is going to know nothing about it, because the engineer is going to have a shift and rotate model, because in his mind there's only distances and angles, and that's all there is in engineering, because you never need to know scale factors unless you're really involved in road building. And I've seen instances where a guy was doing road building and he did not have a geoid in his model, meaning like a GSD 95 that incorporated elevations. So he ended up building like a few kilometers, maybe 10 kilometers, maybe 2 kilometers. I can't remember how much road, but it was a long amount of road. And by the time he got to the end of it, it was like 70 to 80 centimeters high, which means it was almost a meter. So you can imagine how much more fill and material they had to move to create a road and have that much more or less material. And you could imagine that the design that was used for that building wouldn't really be able to be applicable anymore because of the major differences in the original ground to the design. So to avoid that, always remember, if you're doing like a road building or anything that involves a long distance and there's a curvature in the earth, you're going to want to be in a geoid or ellipsoid model that allows for that curvature in your GPS measuring, because you will know that a typical tie-in for elevation for GPS can be like up or down 3 to 5 centimeters typically, whereas the horizontal quality will be much better, meaning the 2D, so left and right, forward, back. So if you do not apply a scale factor when you are changing something in an ellipsoid to plant data, then you can expect to have your piping anything over a kilometer or so for that kilometer to be out like a half a meter or more, depending on how much of the scale factor is based on your location, what geoid model you're using, and how far your baseline is from the well site to the tie-in point. So just remember three things. Not only do you need the shift and the rotate, but you need the scale factor if you are coming from a legal wellhead on your site that has been separately surveyed in a lease site and has a different coordinate system than your own. Now, if they've already converted it and they are in a local coordinate system on that pad, then you will only need a shift and rotate because it will already have had a scale factor applied. But just in any case that use the location of that wellhead to get to your central processing facility, make sure you apply scale factors so that you could tie in nicely and cleanly. Otherwise, guys, you're going to have hundreds of thousands, if not millions of dollars of steel rework with pipe supports, piping that will not fit. It is a mess, and I've seen it, and it's just not great. So it costs a lot of people money, and it will cost you money on your project if you have flow lines going to a lease site that was laid out and legal with a different coordinate system that it needs a scale factor to get to site. So with that being said, always remember that you're going to need a scale factor, but that is usually in large applications where you're getting data from the legal surveyor, say on a lease site or any other information, and it's in a geoid model so that they could stay as accurate as possible. And then they handed it over to you, but they just forgot to mention you need a scale factor in your application. So all the engineers overlooked it. They drew everything without it. And now all your pads and all your flow lines and where they tie in at the central processing will not tie. Now, depending on which way you make this error, you either will tie in at your flow line where you start construction, assuming you know the locations of the piles and everything are right. And then when you get to your processing facility, you will end up being out. However, if you start at the processing facility and you're tying in good and you hold the same measurements when you get to the pad site, you're going to be out. You may not even know with the piles that you're out yet because mods haven't been set on the pad or whatever. But all you need to know is just remember there is going to be a scale factor if you're coming from a different type of coordinate system, and it is in an ellipsoid coordinate system, and you're going to a meter, like as in no scale factors coordinate system. You're going to need a scale factor in that shift and rotate. I think I've explained that enough, but I just can't get to you enough about how much I've seen this cost contractors millions, tens of millions of dollars by not having their information correlate to what they were building, and they weren't able to find out later. And in the case of a flow line, it may be only a few $100,000 in welding, recuts, material, and all that stuff, but it will be significant enough that it'll get your attention and maybe you will lose your job. So that's all I'm going to say. As for getting back to once you have that coordinate system, we could assume that maybe in our example, which we are going to be doing a commercial lot with a building that you could apply to residential, and this is for machine control. But if this was a central processing facility and say you only had these 4 pins on this big grid and you were going to tie them in, you would do this kind of in a similar way. The only difference is these pins are going to be so far apart that for you to tie them in with a robotic total station, which would be very accurate. However, it would just take too much time in the case that these boundaries are several kilometers long and whatnot. You're going to just go do it with GPS. And then when you do it with GPS, you're usually going to get residuals because these will all be on piles, not pins. They are just the control for the site, like I've seen in my time. So a typical site around Fort McMurray is going to have its own base station or maybe share a base station with another site, but typically it'll be its own dedicated base station. So you will not even need a base station to set up in this situation. You could pretty much just start contracting like I did by renting an RTK receiver that was just high quality. In my case, I used a Leica and a robotic or two-man total station to do all your fine work. So in that situation, these would be piles around the site, and there would be a lot more of them because you'd probably have an irregular shaped site and you want to get all the extremities. My recommendation is when you're localizing, the more of them, the better, because if any of them aren't jiving, you'll be able to drop that in your collection and not use it because you think that it's too far out of tolerance. But in my situation, I went around a large central processing facility. I tied in all the little 3/8 bolts that you will see on the top of these piles. And you'll need to remember that because 3/8 bolt is anything that your instrument is going to screw onto. In that case, I didn't screw anything onto it. I just held it in the middle with a small short rod because they were about chest height. And I tied them in and then matched my residuals to the actual WGS 84 coordinates. And I could see that the residuals were maybe less than a few centimeters, and I'm going kilometers, so that was good for me. So basically, I was able to take this GPS out in the central processing facility here and shoot a point, and then somebody from another company could come and shoot it, and they would be within like 15 millimeters of that point with GPS, which means it was better than it had to be, because in GPS, we're typically looking for 6 to 9 millimeters in each direction, which would give you 12 to about 18 millimeters in accuracy. If you have to foresight anything with those points that is greater than that, for example, pile capping, concrete, anchor bolts, or anything, all you have to do is set up 2 or 3 GPS points that are farther away than the extremity of your building. Okay. And then you're going to be out about a cent or two. So if the building is placed out a cent or two, you probably won't get fired or have to worry about it, because everything that ties into it is going to have a field fit of over 100 mil on piping. And then the pile capping, you can be out as much as like more in several centimeters than that. It's just the pile cap itself that's going to have to be really congruent to the other ones. So in this format, we're just going to say this is the central processing facility or building. We went around, tied all those points. Now we placed 1-2 points right outside the building, and maybe a third one just as a check shot to make sure we're orientated on the right point. And what I mean by that is if you set up on this point or that point, and I will just draw it in real quickly. So this is going to be, So this will be your point. And then this will be your point, and you're going to have one more as a checkpoint. And these points are just maybe going to be nails in the ground or rebar. You're going to want them rigid and not be able to move. And you're not going to want to use survey pins because any surveyor has access to those. So never leave your control based on survey pins. If someone's checking into survey pins because that's their program, you already know they're wrong because they can be moved at any time by anyone. And it does happen. So you're always going to want your control network to be on your site by stuff that is only under your control. So it is, because it is very sensitive. It is very sensitive control, and you're going to need it to prove everything that you have on your site as in terms of your raw data and what you accumulated. In case everything goes wrong, you can cover your butt. So we'll just say we're in the central processing facility. You can ignore this right away. There isn't really a minimum setback. You're way out in the middle, hundreds of meters from any boundary. And so now you need to place the site on design coordinates. And so originally these boundaries all would have had design coordinates, probably derived off the legal, and might have been given to them by a municipality if it was local, like in a city. In this case, we're going to say it's like in the middle of nowhere. It's a gas oil production facility or whatever it may be. And so they just picked 0, for their control wherever that was. And then all these ended up becoming coordinates on that grid. So they'll all have just kind of sporadic numbers based on their northing and easting. So in order to tie into those, and they're really far away, we just shot them the GPS, and then we took our GPS and we dropped 1, 2, 3 more points around the building that we're gonna like hit. Now, if this building was a central processing facility and it was really big, you might have piles like this all through the facility so that you could see in between them. and they would all have to be checked to each other very well, probably with a robotic or manual total station. And in this case, you're not going to really have time to do that because most of the plant's already built and you're just adding on to it. And all you have to do to get your correction is basically shoot some existing. So if I set up one here, I backsite there and I backsite there, let's just say, or sorry, backsite there, and then I do a foresight check to this point over here that I don't really use. It's just a check orientation. I'm going to notice that when I backsite this point from this setup here, what's going to happen is I'm going to probably have an error, and the error is going to be anywhere between in my experience, I've done it and I've had less than 4 millimeters of error because my error was accumulated either in the same or close to the same direction. And that's not uncommon with RTK accuracy. So I was pretty much good to go with it. But let's just say it was maximum error I've seen. And I've seen up to 45, 50 mil with 2 GPS shots that were really good. And the reason why is because the error just sporadically went in opposite directions at a bad angle. So we're not going to really want to use that, but because we know it's going to be longer than our building and the azimuth is going to match our outside site, we know we have a good angle. It's just our distance we have to get down. So if you don't want to have to change those coordinates at all, which I highly recommend, because as soon as you start adding and subtracting dimensions off of northing and eastings, you're doing a lot of things that are wrong and it messes things up. And if anybody ever sees you doing it, it's just not going to be what you do. So the way you're going to do it is we'll just pretend that this building is going to tie into, say, maybe this right away here that's going under it. Now that makes no sense in practical terms, but we're just going to pretend it's a pipe maybe, and it has to come in at this angle onto the building because I don't have to draw something else because I'm already 5 or 6 hours into this. So what you could do is you could set up here, backsite here, and then any drawings or any material that was IFC'd or commissioned, we're just going to say this line was already maybe commissioned and our new building's tying into it. I have done projects that are similar to this, although it didn't look like this. But I wanted to know how far I was out from this existing line and where my building was go. So in order to do that, I already have my coordinate system. All the coordinates on the previous construction I have available to me through some passage of information or other, namely that they're going to tie into a building and that building is going to have dimensions that match to where it's tying into. So if I already have existing, the number one rule of thumb is you always tie to existing, just like a carpenter would build to existing if he was doing renovations or anything like that. So you shoot the existing at its design coordinate, and then you're going to get a residual, and it's probably going to be pretty close to what your GPS error was. And so all you're going to do is add and subtract those dimensions till you get a 0, and then that's your new coordinate for that item. So you haven't changed your control at all or botched with the numbers. You're just going to accept what the backside is, whatever it is when you set up. And in order to make sure your building's in the right location, because you know you're really within like 30 to 40 mils in general, basically because of the air in your backside. But we're just going to say maybe it was really good in some situations and you just went forward with it because it wouldn't have given enough discrepancy to really change anything. Like say if it was less than 5 or 10 mil, chances are concrete can all be located within 10 mil or less. It's the anchor bolts and pile caps that got to be within 3 mils. And so if that whole building is out by like 15 mils, it probably won't matter. But if you have one pile cap that is 15 mils out from the next one, then it will matter because you only want to be able to prove 3 mils or less. So how to do that is you set up, none of this building is built, you tie in the existing, and all you do is add or subtract the deltas on that to get it to 0. And then that is the coordinate for that new point. So how does that work? It just means that any coordinate that you calculate to where that must tie in. So for example, if it was like 6 mils west, but the northing and easting are good, then your point that ties into that building, you're just going to calculate out with 6 mils differential to the west. And then all that means, guys, is when you lay out the coordinate, you're still going to be shooting for your 3x3 on steel and bolts, and then your 10 mils on concrete. and pedestals, grade beams, footings, and pedestals. It just means that when you zero out, you're going to be at the design coordinate that ties in with the existing. So you won't have to do the math in your head. You're just going to give it a new coordinate based on where the existing is, because you have to tie to existing. And if anyone ever argues with you, you just tell them, hey, that's the existing. Do you want to rebuild the existing, or do you want to or build something new to tie into it? And I got news for you guys. Even if you lay out all the pile caps on a site, you have a really tight control network, and they're all congruent within their 3 millimeters horizontally. They're going to be probably 1 to 2 mils. Like the way I do my elevations for pile capping, I have had times where they've been out a lot, but once I refine my method, using a robotic and then checking them with a digital level only, because it too has a crypto form of currency, meaning the barcode, I have a less chance of making a human error. And so the only time I can make that human error is writing down my leveling notes for when I'm checking the robotic data, which is going to be pretty much errorless if you just use a mini prism, like a mini, and it's going to be accurate enough. However, a larger prism that is a 360 is still going to be good to like 2 mils. So it just depends what you want to go with. I would go mini, because anything larger or a conventional miniature prism that is just like faces in one direction is not 360. By the time you swivel and move it a little bit, it's going to have a little bit more error, and you're not going to be able to align pile caps with it. And you don't want to have to use string line, and you don't want to have to draw scribe the center lines of the pile cap, because you're just going to scribe corner to corner, because that's the easiest way to get the center. So after that, you'll be able to shoot the sides of the pile cap for orientation. So that'll all go quick once you get this coordinate system set up. So all that means is whatever your existing happens to be, you shoot it, and then you make your building tie to it by just offsetting all of your locations in the building by that much. So if you were going to start calculating this building from this corner and you had a specific coordinate, you're going to have to adjust it the amount that your existing ties into your building, and then start calculating the whole building out from there, so that you know if you go to 0 on all your points or within tolerance, you're going to be within that tolerance according to the existing. That should be all pretty straightforward and understandable. So we're going to make it work in our situation for machine control. And then so for machine control, we're going to imagine this building is here, and we have parking all around. Our three benchmarks, which are these circles that we put in the industrial application, they're now going to be much closer to these corners of the lots, because it's going to be a smaller site. And now, so we're thinking commercial or even residential. Now in residential, you might not put 2 piles in to keep your control all the time. They'd be kind of in the way. It is not that hard to set up a residential site as easily, and you might not have to use machine control. But if you were doing a subdivision that has a lot of lots in it, and you had to develop it, and you wanted to hand over that data 3D to the municipality so they could hand it over to developers and landowners, you would probably want to know the system and then use it for all of the lots in the area. Now, there's a lot of inefficiencies that I can see in these areas already of development, and that is the ability to develop a lot of land quickly. And quite frankly, they move too much soil in and out in a lot of these cases. And if that's something that you guys have to do, maybe for environmental reasons, or maybe it's for other reasons, I'm not sure, but I see it a lot, and you see it a lot. And a lot of the times when all this underground piping and sewer and or deep underground and sewer and maybe even fire water or whatever happens to be in the neighborhood that they install, is when it gets installed and built, only the 2D information is given to the municipality. So for example, here in Red Deer, when they build a subdivision, when you get to that subdivision, no matter how brand new it is, all of the sidewalks, okay, unless the sidewalks and curbing were done with GNS technology, and that means 2 GNS sensors and a base station, then chances are they're going to be out as much as high and low, sometimes as maybe 20 to 30 centimeters, including manholes, drainage, maybe where utilities are. They could be significantly out. So what you can bet right off the bat is that If you have any land that's been turned over by a municipality and they haven't given it to you in three-dimensional format so that you know where all the inverts of pipe and everything are, you're going to have to play a little guessing on some of it. However, most of it won't matter because on your lot, you're going to find your deep underground utilities or your electrical, plumbing, and sewer and stuff like that. And you're just going to make sure you tie to the existing, and you'll be fine. So for drainage, the only thing that will be important is that you make sure that the drainage in your building slopes to the drainage in the municipality at a reasonable rate that wouldn't make it like flat or have a negative slope so that anything would drain back into the building, making the draining system and the plumbing useless. So in order to do that, most people can figure that out. Excuse me, guys. It is straightforward, but I recommend dialing that in. And so some of this would be involved in that process. Now, the reason why those things will never jive is because the coordinates that have been made up for the building and the lot have been coming from an engineer. Okay, and that engineer may or may have not been able to calculate the dimensions off the sides of lot as accurately as you, because he doesn't know where the actual pins are, which will always be different than the design. And because you're only getting 2D quality, anything that's going up or down, like sidewalks, roads, alleys, maybe municipal reserves that you're tying into, anything is almost always never going to be exactly where it says it is either. But fortunately, in these situations, you're not going to be building blind to a lot of this, because maybe you're doing a large apartment building, and I've done them in a few instances where you already have all the sidewalks, everything there. In a lot of cases, you would, in most cases, really, because the subdivision would have been developed years earlier. So you have all of the infrastructure that the municipality needs before they turn it over to you. However, you're going to have coordinate systems on your building, parking lots, curbing, and everything. And they are going to be design coordinates, and they are not going to jive to the coordinate system that you're going to set up on site. No matter what, it is impossible. And there is maybe a few ways you could do it, but we're just going to do it the way I know how to do it. That's one of the ways. And that is we're going to orientate the site to that information so that when you start building using those coordinates, i.e. the DWG for grading in your machine control or anything, it's going to jive. So you're going to need permission from the engineer for just a few things, which we'll get to in a moment. But first, we're going to set up the control, and I'll show you how we're going to do it. So this is a smaller commercial site. You could do it in residential. It would work in small areas in industrial, as I've already showed you it. But really, we're going to talk about like probably a 50 by 40 meter lot that's used for commercial. Could be bigger, could be smaller. I'm going to say it's probably bigger in most cases. But whatever it is, we're going to do we're going to do 40 by 30 meters. And the reason why is because then we'll know the distance across the middle is 50 meters because we have a 3, 4, 5 triangle. The building's not here. We just have this, this, and this. And they are just 3 piles with a 3/8 bolt in the middle, and then we could screw our GPS base station onto at any time. And we could screw our total station with a robotic feature, meaning it's a robotic total station, to one at any time. And we could swap them if we had to, or if we had to, we could use the third one. However, in commercial or residential, I probably would never put in the third one because I would just check to the section evidence that we already calculated out. And I wouldn't start laying the building out over on the other property next door because I already know where we're working. So, excuse me, I wouldn't really have that problem. Now, to start off, we can't use the crypto method for tying in the pins that we use the WGS84 coordinates because although it'll be accurate enough to find the pins in any situation, it's not going to be accurate enough to set you up closest to the minimum setback as you can be so that you don't go over the line. And you can also achieve all your quality standards in your survey. So how we're going to do that is this. We will set up our instrument over here. And to do that, I'm going to draw a circle around it because I think it would be helpful. Um, we're going to do no fill. So our total station is going to go here to begin with. And there's going to be no building or anything on this property. It's just a bunch of dirt left by the developer. And it's either high or low and all that. And we could figure it out later. Okay, now something you guys should know about UAVs is a UAV can do a topographic survey that the best survey in the world could never do 50 or plus years ago. And up until recently, really, that now my 12-year-old daughter could do with just a quadcopter and a simple cell phone as a base station setup that can communicate to each other. So what that UAV is going to do is basically what our UAV did in our military our military application before we landed. It's going to go and it's going to just fly around the site according to waypoints that you set. So like a start point and an end point, and then like some sort of offset that it will go down and pass. And that's going to give you a topo of all the soil and everything you need or know to bring in and take out if you calculate the vertical offsets of the existing material versus your finished grade. We're not going to do that, guys, and I can prove that step is kind of redundant because you're not going to have to tie in anything in this area to anything in the neighboring lots unless it's at really the property lines or beyond, and it's only ever going to be like concrete sidewalks, which you're not going to adjust or build to, or you're not going to adjust or change. You're just going to build your sod or whatever, your grass or asphalt parking lot that goes right to property line. You're just going to build to that existing like neighbor or whatever. If you happen to be up or down or whatever, that could be fine too if it doesn't, because you're still going to be on your property. But the reason why I'm saying this is because people might use UAVs because they want to save a bucket of soil here and there, and it's not really as cost efficient as you think. And so and none of our elevations will matter on these pins because we're only paying attention to the minimum setbacks. So I think UAV is great for mining and major construction, especially if you're going from that seismic to legal where you need good vertical data on your ground because you're going underground. But you also need that LiDAR and UAV, and typically it would be more like a plane like application LiDAR so that you can cover a lot of ground in less time. But if you wanted to use a smaller UVA on a smaller project, UAV, it would work. The only thing is I can just show you that with what you're going to have to do anyways, it might be a waste of time in your situation. However, there is applications it could help in, like, for example, if it was like environmentally sensitive and you couldn't change the original ground and you had to find out what is original and what's not, and it was really hard to, I don't really know what application you could find that in. Maybe if it was like somebody messing with the property a great deal and you had to figure out how much soil they stole from you or something. Like I said, guys, big phase construction where you have a large area and you need to calculate intermediate and final qualities. I recommend a UAV or something similar. Uh, Again, in mining, like in a Fort McMurray situation, UAV would be the best for volume calculations rather than, excuse me, rather than having a survey go out there and shoot it all and get numbers that are not going to be as accurate as UAV because it's using that laser and tying it to that GPS location in less than 2 centimeters, like we said. And it's just more accurate and it can cover more and do more. The only other way you're going to get to the same accuracy as quick is if you mount your GPS on like a UAV, as in utility vehicle, or a kind of like a ATV or anything that you could drive. I wouldn't recommend snowmobile, although you could do it. It's just the play and the suspension is going to change a little bit for you, your elevations. And usually you're not developing soil or civil when there's that much snow unless you have a thawing process, and it's only going to be around the buildings, etc. So anyways, if you had like say your quad and you could drive around an entire central processing facility site on it, if you just measure the distance between the sensor and the ground um, at the proper point, you'd be able to get elevations and positions on everything just by driving around, have it continuously occupy points. You can see how the UAV would be faster. So you could go with a little quadcopter for that does LiDAR. It is the same technology really that we're using like in our deployment portal where we scan our body for our Army combat uniform, except for it's not using GPS. It's using a robotic origin when you shoot the laser and distance, and then it's gonna make a 3D visual of your body. And if you're like in a kind of like spandex suit, it's gonna be like right to your skin, right? So the laser part's the same. The GPS is a little bit different. Instead, you have a robotic shell around you doing this measurement. In the UAV or whatever, it's just using the GPS and then relaying your projected laser down to the ground, and it's giving you just a shot measurement, like a just anything. Any laser can measure distance very simply, just like a distometer that you would use in real estate to check square footage on a house or wall-to-wall measurements. That stuff is always going to be the same. It just depends what kind of machine you have it and the application. So for this, we have our total station set up in the bottom. So it's going to be the south and the west corner. Okay, so when we set it up, we'll just grab a line here, and it's going to be blue because I just want to keep it like so you know where we came from and where we're going to. And it's going to be our back sight. So we shoot a line from here. Oh, I didn't do this right already. So I'm going to delete that. Sorry, guys. Sorry, I need a line. I'm starting from here. It's going to be blue because I want it. So I got light blue. And it's going to shoot with this laser a distance from this coordinate to this coordinate. Okay, these drawings that you'll get in plan format, they're going to have angle and distance on the line. They are not going to have coordinates on your pins. You're going to have to figure that out for yourself. And the way you figure that out, guys, is easy. We are going to start with the longest line on our site, and then we are going to apply the amount of error that the plan says those pins are allowed to have. So on a typical survey plan that I've seen, we are going to say it's around 2 to 2.5 centimeters that they could be out if they are all on the same lot. And that would have been guaranteed for the layout and design. So say you have a lot of these going around a big irregularly shaped lot, you're going to find that some of them maybe got hit by a bobcat or were adjusted or moved, and you're not going to be able to accept them all anyways. So the only thing you're going to be able to accept is anything that's in that tolerance and reasonably more. And if it is, you're just going to put that error into your minimum setback, so that if the next person comes out and gets different answers than you, and they shoot your building and then they calculate the minimum setback, they're not going to find that you're over the line because you gave yourself a little bit of a buffer. Now this will make it quick and easier, and anybody can set up your control system for machine control. Whether it's the legal surveyor or not, you just have to give them the instructions of how you want it to be laid out. Can you do this or not? It doesn't really matter, guys. It is the legal surveyor's kind of jurisdiction, but the pins you have access to, it is your property. It is not a legal survey. It is a restake. And if you are relating anything to a boundary, I can't say that you're doing a legal survey for sure. And legal surveyors are not the only ones that have the right to make measurements. But this survey is not going to be registered with the surveying authority in the registry, in the land titles office, because you're just placing a building. However, the survey that's going to happen at the end of it, in particularly maybe Alberta or other places in BC, it would be like a certification, and it's going to be happening before you even pour your concrete there. It's going to be a certification that establishes you're not in minimum setback. However, in Alberta, they'll let you pour and build the whole building before they know, and then they'll do a real property report, and then you'll find out whether you're in this minimum setback or not. By then, it's too late. It will change the value of the property because it is encroaching and it either has to be fixed or passed by the city somehow, whether it's the municipality or the province or whatever. And it's just a big headache, guys. So building zero building zero property line is a waste of time because you're going through too much to do it. You just calculate your zero property line, you add the area of your survey to it, so you give yourself a little buffer, and that's really just how I would do it altogether. So in order to get to that step, the first thing we do is we put all these four pins into coordinates, because right now they're in angle and distances, and unless you want to calculate that all out manually when you shoot them, you're not going to be able to. If you want to calculate that all manually when you shoot them, it's going to be hard because your gun's going to deal only really in coordinates primarily. But if you don't want it to, you can do angles and distances only. But you're going to have to make sure you look out for stuff like slope distance versus horizontal distance, because your gun is going to measure the slope distance with the laser, but it'll calculate how far you are horizontally from this. So any elevations we're never going to pay attention to when we deal with legal pins, because the only thing that matters is horizontal quality. So for all our elevations, we can just always put in 0. It doesn't matter. All that we need to know is our 2 base points on these piles are going to need elevations to be able to do all their grading and set the buildings and everything else, etc. But we can assume those at different times and in different ways, and we'll probably do it with our level to make sure it's the most accurate. So right now we're all going to do 0, 0 property line, and this is how we're going to do. Okay, so not 0, 0 property line, sorry, a 0, 0 coordinate for one of our coordinates in the beginning. And so what you'll note right off the bat is if we've already got all our drawings in a coordinate system based on design from our engineer, I don't know, I erased that. That's our shot line anyways. There our laser that's not really blue. But anyways, the thing that you'll note right off the bat is because we're going to assume as one of these pins is 0, 0, 0, and our lot's going to be 40 meters by 30 meters. And because we know that the cross distance in that, and this is a 90-degree angle, of course, and this is a 90-degree angle. Guys, this is a perfect world scenario, and it doesn't exist. All of these angles will probably be different to the minute or second, and then probably parallel each other, depending on the road or the lane in the back or anything they tie into. And then, but we're going to assume it's pretty close to a 40 by 30 lot, and that's going to have a 50 meter across distance from pin to pin. That will not show up on your plan. I rarely see any kind of a distance tie across a lot like that, unless there's a right of way like this one or this black one here coming through there. We're going to assume there's no building or anything there. And so because our minimum setback is on this side, and it's usually going to be on a side and the front, and then on the back, depending on where you're at. The front will just be like a utility right away that everybody has to maintain on their property. We're going to just say that we're going to go on the side that we're closest to, because that's where we're going to add our error, whatever side it shows up on. And we're going to try and make it reasonable enough that the client doesn't mind moving the building this much, but also ensures that they will never be encroaching or endangering the neighbor's property. Which will come in handy at the end of this when you have to do the real property report and you just want to make sure that you're in compliance with everybody. So we're going to call this coordinate down here 0, 0, and it could be whatever point you want. I'm going to say in this scenario, I would calculate it 1, 2, 3, 4, or 1, 2, 3, 4. Okay, so basically no matter what, our third point is going to be this similar or the same, and then our fourth point will be just a check shot. Just to make sure. And so we're going to assume some good things and some bad things. And most of the time we've been doing worst case scenario. So we might do it here too. If I am on here at 0, 0, 0, okay, that means I'm calling it 0 north, 0 east, and 0 elevation. Okay. Anytime I shoot in any other point and then ascribe it a coordinate, is going to use the rod height that I shoot it at, and then it's going to just push it down the rod, whatever I say the rod height is, and that's what the coordinate's going to be. So if you want to hold elevation, make sure you measure the height of your instrument, which is going to be the center of the eyepiece. There should be a dot or some sort of imprint on the side. a lot of instruments now, and if you get one that has just a disto device that measures the laser, you'll line up with the pin on the bottom. uh, that will give you the height of the instrument. So if you want to hold elevation, just remember, because you're making up the first coordinate and elevation, you're going to have to adjust this point and this point at some point to make sure it jives with your drawings. But we're just going to do it in a little bit reverse order. So we'll just make sure everything's true, and then we'll find out what this elevation is actually at, and then we'll recalculate it based on what our control is, and then we'll shift and rotate all the points to based on our control. They already should be pretty close if they were based off the design dimensions of the lot. So in some cases, we'll just investigate that and then see how it goes. However, I can almost guarantee in any situation, they'll be probably a lot different than what we assume, unless we can tell on their drawings what they did assume. But we already know the existing pins are not going to ever be in the position they say they are. And we know that none of the infrastructure in the subdivision is going to be at 3D. So it's going to be either up or down sewers and sidewalks, and everything else we're just going to have to field fit to tie in, like grass, sod, parking. It could be up or down different. I typically would always tie my parking lot in the same level as the neighbor, just because, I don't know, why not? Why did I have to build higher or lower? It's just you can go with a few things in that respect, but the number one thing is to get your project properly insured. You're going to have to make sure that you build everything to the engineer's spec. And that's where you guys, this area is a little fuzzy, because legal surveyors will believe, well, we should be laying out the building, and then the construction designer or the engineer and the CMT or whatever happens to be in your case, they're going to say, well, it's our building, we can decide where to put it, as long as we know we're not in any minimum setback and we're in compliance with everybody. What's the difference if we download our raw data and send it to the judge, or you download your raw data? Is it going to be just your ethics or something like that is superior to ours? So I don't know. There's arguments about this, guys. So I'll just show you what a legal surveyor would expect if you had him lay it out. But just remember, if you did, he was probably going to want to do a lot of different things. It's going to take a lot of time. And you could just train somebody that is a tech, that has learned from me, who is also a tech, and not by a tech in meaning I went to school, because again, I am the Metis Surveyor without papers. But a tech is somebody who's qualified and understands how to operate the equipment to a satisfactory enough standard that he can make his employer money, or he could do the job properly. And so this will not be a legal surveyor registered in land titles, although it may eventually become a legal surveyor as an RPR or a certificate. But if you could do it and somebody comes in and checks it, all you did was just do work more efficiently that you didn't have to get them to do. And we'll just make sure that you know how to satisfy all the requirements of the legal surveyor. So let's say you have a partnership with one already who's going to do your RPR at a good price, because you're going to make all this money on the project. What I would do is, because I've worked for surveyors, is I would just have them look over my work and verify it maybe. And if they were just unwilling to, or they got nitpicky over things that didn't matter, I would already know I wouldn't need them. But if I did want to get rid of liability, then I could actually pass the notes to them and they could process it. And if they were going to use a lot of the information I gave them for the RPR, and that means they would be comfortable with my surveying techniques and the minimal errors and values that I give them. And they could use some of it to do the RPR. And then also, if I leave these two piles in the dirt at the end of construction, they could technically set up on them, shoot to my pins without knowing where, shoot to my pins without having to set up their own legs and setups and everything, and conduct most of the RPR. And they could use foundational measurements that we had on the concrete, and we just measure off the siding and all that kind of stuff. They'd be able to do it very seamlessly with the information we give them and prove that it was all accurate. So this might also expedite your RPR, a real property report, at the end. But we got to do it right so that they do give us that advantage. So I'm going to show you the quickest and easiest way that I've set up surveys in legal surveying. It works. And I've heard of people say it doesn't, and they're wrong because they're old school, and they just can't trust it because maybe they've seen one way it didn't work and it was done wrong. So we're going to assume a lot of the worst case scenario things. We are not going to shoot our pins in GPS, then drop points, and then adjust like we did on the industrial one, because our points are a lot closer together, and then we have the plan, distance, and angles to make our coordinates. So it's going to be different, where in the industrial construction, most likely you would have been given a coordinate for any control you get, and it would already be in a meter equals a meter kind of environment. So you wouldn't have to apply a scale factor or anything like that. The next thing you know is, if you do anything with GPS, make sure you're not working with a scale factor, guys, because if you try and tie into that with your total station, you're going to be out and you're going to be pulling out your hair while you're out. And it's because the distance is not the same length. So whenever you use your GPS in construction period and you are laying out 100-meter building and it has to be exactly 100 meters, do not have a scale factor. Make sure when you see scale factor, it just says 1.0000 forever. And that's the only way you want to use it in construction, because you're going to want to be able to set up and get total station running off of it. But because we want it to be mostly accurate, we're not going to set up our control GPS. We're going to set up with total station, and then we're going to attach a GPS to that control, so that we know that the error is definitely not going to be more than the GPS plus the error in the total station. But if we set up the control with GPS, then that means we are now going to have a greater error, and then we're going to have to add the error of the total station to it. It seems like in both situations you're going to end up with that, but only where you use GPS for layout will you find the combination of the two. But when you have to use the total station or the robotic by itself setup, you're only going to have a total station or a robotic error off the pins and then to your building and points. So you're going to have still an extremely low error. But if you set up the control GPS, you're already out that much more, and you'd have to add it to your minimum setback, and we're not going to do that. So we'll set it up with the robotic total station. So we're going to pretend it's a perfect world, and the surveyor was able to lay this out on a perfect 90-degree angle from north, and this one a perfect 90-degree angle from north, and measure and document that. And then this one would be perfectly 180 south, and this one 180 south. So in order to calculate all these coordinates, it's going to be pretty easy in this situation, because we have 40 meters to the east and 30 meters north, which would make this coordinate 30 comma 40 comma whatever elevation is going to be. So it's going to be 30 north and 40 east. So in this situation, this one up here would be 30 comma or 30 delimited, but really it's northing 30 decimal 000, and then it is east 0. So it's not going anything east. Now this one's going to be 0 north because it's keeping the same north, obviously, and we're going to be 40 east. So we know we got 30 40 here. If we are going a rise and run of 40 by 30 to get to here, I know already with a 3 4 5 triangle, this distance is going to be 50 meters. Okay. So we're going to say that all the planned distances were in angles, they weren't in bearings, and they were all to the second, and they were all on 0, which you will never see. So you will have to probably brush up on your trigonometry skills a little bit, but if you think you can handle it and you know the difference between a bearing and a regular azimuth that you might see on a plan or whatever, and how to convert it, then go for it. But if not, maybe just get your surveyor or somebody to do this, because you don't want to mess up the placement of your building. So this is perfect world scenario, but we'll have to assume some things about it that aren't great. So let's say you have this 0 coordinate and you have this 30 40 coordinate up here. The instrument already knows that if you set up on 0 and you shoot 30 40, it's going to get a 50 meter differential. Now, any shorter of that means that this pin or this pin is either too far in. If it's longer than that, it means this pin or this pin is too far out. And because we have like about a 2.5 centimeter quality, we're going to say that we can be 2.5 lower or 2.5 higher than that, and then we should be fine. So if we see 2.5, so if we see 50.250, or sorry, 0.25, which would be our 25 mil, or less, up or down to about 49, and then or 49 9 whatever 85 it would be, I guess, for 15 mil down, we are going to be kind of okay to go. But if it's in, we're going to just subtract that amount, or sorry, if it's in like shorter, we're just going to add that amount to the minimum setback, okay? Because it's only on this side and it's coming from our 0, 0. So that way we are assuming that it could be pulled in this way. Now, in actuality, when you shoot this, guys, it probably won't be the difference of your error on the survey plan, meaning within that 2.5 centimeters that they claim it is. And it's not necessarily their fault. They may be able to prove that it was put there, but somebody might have moved it, somebody might have hit it, or anything like that. So first of all, we'll try and shoot for that residual here. Now let's just say we got the 50 right on and we're fine. And we're like, oh my God, I could just lay this out at 0 property line plus setback and then eaves or whatever, and I'm going to be golden. Not exactly, guys, because we're going to have to check all the pins on the lot, which is what the surveyor would do. So just to document it, we'll turn to this pin and we'll shoot it in. But let's just say I never got the ability to do that. Maybe the pins were missing. I had to get it reposted, whatever. And we're going to say this is short, and it's short a lot longer by than we thought. And we're going to just say it's about 5 centimeters short, which means that you either have to have at least 5 centimeters in one of these pins or 2.5 in both of them. And it's going to be anywhere between 2.5 and down. Sorry, 2.5 and up, and between that and less for each pin. So you're going to have up to a 5 centimeter error that's either on this pin or this pin, but it could be halved and you don't know which way or whatever. So but you already have the longest line on site. So that is the best orientation. And no matter what that distance is, guys, those pins govern. Because remember I told you earlier that the plan distance and angle that goes around your lot does not govern the size of your lot. It is just a proposed lot, and actually it's going to be the pins that are found at any given time ever that are going to govern that lot. So what we're going to say is, if we shoot any pin that is greater than that distance out of our tolerance, then we're just not going to accept it, and we'll accept the other 3 or 2 or whatever what may be. But we already know this is the longest line on site. So if we shoot this and it's within tolerance, we can assume that this pin and this pin must be within tolerance if they haven't moved, but they may have, so we're going to shoot them anyways. So we'll say we're balls on for this, for this point, and then we're going to check this one. Okay, maybe it's a little bit short or long, but we're not affected by that minimum setback. So we are just going to want to note one thing, and that is the angle that it's on. Is it going towards our building or away? And if it's going towards our building, that means that pin is in, or so excuse me, that means that pin is in and undeniably, because it's at a lower angle than this one. Or sorry, it's at a higher angle, or a higher angle than is designed that we thought it was at. But it's also governing now the new boundary and not the one that's listed on the plan. And that's where the pin is at. So just to be on the safe side, we'll take a shot of it and make sure we know where it is. And then we're going to take a shot of this pin too. This one's on the front with a minimum setback, and that's always going to be usually utility right away. You might be way far away from that. So if this one has a lesser angle than its design, meaning it's further towards the building, and you have a setback on the front, just make sure you incorporate that into your building. You'd be able to figure out straightforward how to do that pretty easily, but basically all you got to do is take the distance that you get on that line, which is going to be, based on your angle and distance that you shoot. But we'll just say this pin is like in this way, and then this pin is in this way, and these ones just happen to be right on, okay? But if this one is actually in or out, you're still going to need to know that. It's just that you're not going to change the angle, because no matter what, that pin governs, and you don't want to change the angle. So in order to get everything jiving, so you do that, let's just say this is short by 5 centimeters. So 5 centimeters would mean that we are at 49.950. Right? Oh, of course I did that. Anyways, I'm just going to erase this because it's in my way. I don't like it. So it's supposed to be a design of 50, and then it's at 49.950. So you're 5 cents short. So in order to get everything on balls the way you'd like it to be, you want this to tie to 0, okay? So in order to do that, you're going to have to take this coordinate and move it in 5 centimeters, okay? And the reason why you're doing that, moving that coordinate in 5 centimeters, is so you can get zeros from property line to property line on the longest measurement on site. And you could verify that your back sight is, you already know at the longest angle, and the pins govern, but you're going to get it to tie to 0. So when you turn to these two other points, you'll be able to get your solution a lot quicker, just because you were at 0 on this point. And the reason why I do that, guys, is because if you have 0 arrow from this point to this point, and you have actual distance from the pins, then the plan distance and angles don't really matter, because a surveyor might bump this pin back out 5 centimeters to leave it. So there is an option there. I guess you could just bump it out to the 50, but we're just going to say, hey, the pin was there and we didn't mess with it and it governs. So we assume the longest line on our site. You said it was within 2.5 centimeters. So it wasn't. It was short by 5 centimeters, and we don't know which side it's on or in which pin. So what we're going to do is shorten our plan distance by 5 centimeters. Now, it might be just easy in your mind to be like, oh, I'll bump this towards this pin in 5 centimeters. But to actually calculate it out, you're going to need your 5th point. And so to do that, all you guys do is take your angle that you shot here, which is the design angle for the longest point. And then you are going to shift it in the direction towards your first point. So point number 5 is going to be staked out to this line, and it's going to be at 5 centimeters from this point. So however you want to figure out doing that, you can do it. There's a few ways you could go from this point at an angle at 49.95, create a new point, and then you're just going to shoot that design point, and you should get your residuals to be 0, 0, and then elevation we're not paying attention to. And now, why do I say, you guys, that we're doing that? Well, because now we've proved from pin to pin that we are exactly 0 residuals on the longest line across from the site, back and forth, okay? And so we just gave them the benefit of the doubt. And because it moved in, remember, that means that either we're in here or in there, and we don't know which way. So we got to add that somehow to our minimum setback. But before we do that, we're going to find out whether it's on our side or just the pins next to us, right? And these could be in any direction because of the nature of the way they get put in. For example, a surveyor might put in a pin and it's not in position, so he gets the rodman to knock it over. Then he as-built it, then it's good. The next surveyor comes out and he's like, oh, this pin is bent, so I'm going to bend it straight. And then now it's out of position. And as you can see, like, it just becomes a ball of wax, right? So, excuse me. To get around that, we now have tying 0, 0 from the longest distance. And now we could publish, if we had to, the actual distance from pin to pin would be this. So that gives us 0, 0. Now, we already know we're 5 centimeters out of tolerance, which means the pins aren't where they were supposed to be. But let's say they were within tolerance. We'd be able to check into these other pins. And if we found they were in tolerance, we'd be able to just add like maybe a few centimeters to our minimum setback, as much as we're willing to take without losing like parking or curbing or anything like that. And we could add it to the minimum setback, and then we could lay out the corners of our building. Okay. Okay, guys, there might be a few things that you think I'm missing, but just to go back, let me reiterate. We're setting up on the side that has the minimum setback, right? So no matter where that pin is, no matter what, we're going to have to add our minimum setback to it and to the one that's correlated to it, or that is on the same line to it, and then create a line that's parallel to these two pins, and then that will be defined as minimum setback. So how do we know that will never change when the next surveyor comes along, bunts some pins around, and it says, "Hey, you guys are over property line because I survey 3 inches different than everybody else," like most surveyors can and will, and up to at a lot of times, based on the condition of the evidence. So I'm going to assume we have 0, 0 here. I'm going to the absolute furthest pin, and then I'm going to say it is 49.950 because I know it is short by 5. It is not the 50 we anticipated. So that means I know I am going this far into the lot or this far into the lot, either 5 centimeters, or I'm splitting the difference somehow. So I'm between 0 and 5 centimeters one way or the other. But what I know about this line is it is based on the actual pins. Is the longest line on the lot, and I am set up at zeros on the minimum setback side. So that means when I add air to that side, I won't have to double it, or I won't have to add it to both sides because I don't know which side it's coming from. So even right now, if I was just to start laying out the building and I believed, listen, this surveyor was out to lunch that laid this, I'm already out 5 centimeters. I'm just going to add 5 centimeters to my minimum setback side on this side. And then just to double check, I'll turn to this. And if it's like a centimeter or two to the right, then I got to add about 7 centimeters on this side. But because I'm getting closer to the building, excuse me, but because I'm getting closer to the building and I've only added 5 on this side, I might need to add less to keep it parallel, but to keep the building off the new property line because I know the pin is moved, then I'm going to need to make sure that I have my minimum setback plus the distance I've missed, which is the 5. So this one would have to be like more like 7 centimeters. This one would have to be parallel, so you probably would want to hold the same angle. So you want to have to make this 7 centimeters. So no matter what, this pin and this pin are going to have the same minimum setback this way, same minimum setback this way, and it's never going to be measured on the other sides. Now, just in case I said something goofy there, we're going to have to go over it real quick. If I find that this pin is this way or this way after I take my backside at zeros with the new position, I already know this pin is going to have to move like about it could be 5 centimeters this way. So if that's the case, then that minimum setback's no longer good. We have to add 5 centimeters to get it to 0. So if I know that's true and I want to keep it parallel to this pin, then I'm going to have to immediately add that distance to this pin or to the minimum setback if I want to keep it parallel. But if this pin happens to be this way or that way, I can either add or subtract to keep it parallel with this pin. You'd be able to figure out as you go, but this pin would be only just to check because we're not going to lay out to minimum setback there. Say you backside of this pin and you get zeros. You're on the minimum setback line. You got the longest line and it is errorless now. So you turn to this one, you find out you're maybe 2 centimeters to the right. So you're going to just say, okay, I'm going to hold that as the new location of the pin. It's obviously different than was stated in the survey plan, but I shoot this one. It's 2.5 centimeters. And it's going out this way, so it doesn't affect me whatsoever, and I'm not gonna have to parallel it or anything. But because everything on my lot's gonna parallel this line because it's the longest azimuth. So that means that no matter what survey ever happens on this lot, whether they do resections or set up and lay out a really tight control network, they're not going to be able to get a more accurate angle than if they go cross to cross. And the only time you can do that is before the building and everything gets built. But we will make this pile and this pile able to see all the pins. This pile will not be here. That was just more for the industrial setting. So I know I got the longest line. So let's just say I'm 2 centimeters this way. I've already adjusted for my 5 centimeters error. I add 2 centimeters. Okay. Or excuse me. I add 2 centimeters just because I know I'm that much further that way, different from the design. So you guys, if I had 7 centimeters approximately, and you're gonna have to figure out in your own mind exactly how you do it. But if you just add your air to this side that you're working from, and you hold this as 0, and then you backside this so it is 0, um, you are not going to shift 5 centimeters towards this point because you're still holding 0 this way. So all you do is add the air to the minimum setback. It's just a simple way of doing it, guys, and it will work. If you need a little bit more of a buffer because you can't prove maybe some angles or whatever, you just talk to whoever owns the land. If they're willing to give up a little bit of property anywhere on their lot just so that they comply, chances are they're not going to hit a minimum setback anywhere else on the lot. If you have like 2 buildings or whatever, then the same principles are going to apply. It's just they're going to just have to be congruent together when you lay them out. Okay, guys, another way you could have done this if you set up here and you had coordinates for all 4 pins is, let's say you set up here and that's supposed to be 0, 0. That's what you would have assumed it as. So you assume it is 0, 0. But then you calculate out this pin, and this pin, and you decide, I don't want to set up on a known point, but I'm going to set up on a known point. I'm just going to give it a new coordinate. What you could do is something called a resection, and you shoot this point, and this point, and it acts exactly the same way your localization does in the GPS, except for it's going to be tighter data because you're using a laser EDM. Like you have you have a fine azimuth measuring device in your machine, and then you have a laser to correspond with it with distance, and is going to be highly accurate. But what you notice it will do is it's going to get these coordinates to as close as they can be, and so you'll have a list of residuals, and it might just say like millimeters by millimeters that you're out. And when you get that, and when you get your result, it's going to punch out a new coordinate for your 0, 0, and it's going to tell you where it actually could be at best fit. That will also give you the residual of how far this pin is out from design. But because it's still design, it's also going to average the position on each of these pins and shift them according to the longest line. Guys, it's going to be pretty cool to go through all that and like test it out and see what you want to do. It would be a check that you could do after if you want to just see the differences between numbers and what and how far you were off. But I'm just telling you, if you go hold your 0, 0 on the minimum setback line and add your error to that line, you're going to be safe. And whatever that error happens to be, I'm always going to add 3 inches or about 90 mils. Approximately 90 mils or whatever it happens to be, 75 mils. I can't remember. 2 inches about 50 mils. So whatever it happens to be, it's going to be around 3 inches, and I will add it because no matter what, guys, if those pins moved or get bumped ever again, and some guy comes by in 40 years when I want to sell my apartment building and he says you're encroaching because he surveyed completely different and those pins have moved, you're going to have all your rad data to support it. So I recommend taking a picture of the pin after and before you shoot it. But anything that would help you in a court of law or anything like that, but it's going to still be best practice than most surveyors would do because they might just set up a GPS, tile these points, say they're reasonable enough, then they're going to go stake out your building. There's times when they would do it over the property line, as I have seen and heard about, and then you're going to have to sue him, and he's not going to have the money to pay for anything to fix, so he's going to obviously get hit on insurance. His premiums are going to stay relatively the same as I've seen in the past, but you're going to get a big check, and it's going to take you a lot of work to get your project back in order, whether it's moving piles or concrete, etc. And guess what, guys? You're probably not going to make the money you wanted to for building the building. Now, it might work out because you're going to get a big insurance payout, but I could tell you by the time you get into piling and plumbing and all the phases of construction you want to be, if you have to turn around, it's going to cost you probably way more than you're going to get insurance for. Although it will be a sizable check and that might be fine, but I don't like doing rework. It's a waste of time. You want to build it right the first time. And so getting the numbers right is the most important thing. Okay, so because that's our longest line on site. And then we know it's the most accurate azimuth because it's our longest dimension. We're using the as-fit pins. We've already seen if our minimum setback goes this way or that way. We just have to make sure this minimum setback parallels these two lines, which means it's going to be the same distance off as this one or this one. Okay, now something that you can know about your setup point from this point to this point is because you zeroed it in and assumed the as-built position of the pin and you zeroed its position. You're going to now see the error of this pin and this pin more clearly, but you're going to also remember that you're out on this side, but you're starting your baseline on minimum setback side, so you should be fine. The other thing you need to know is if I shoot one position from one setup to the other, meaning I'm on one and shooting to the other, if I have like say a bipod setup here, it's very stable, or maybe I'm using a mini prism and it's very low to the ground, so there won't be much angle difference in terms of the position from the prism to the ground. There's going to be a very tight errorless shot. So you might even have legs set up here with a back sight to even keep it tighter, and then you could check these and then check back to it just to close your survey, which I recommend doing. You're going to always want to close your survey in one way or another. So whether you're laying out pile caps, building concrete, if it's high precision, you're going to check your site a little bit more than not, like maybe at breaks and lunchtime or earlier if it's really high precision. But you're going to always want to close your survey because you don't know if somebody's kicked your legs or messed with them. But we're not going to have a lot of those problems during the setup because we're only going to have 2 piles with 2 3/8 bolts that we're going to set all our instrument and gear up on throughout the whole project and be able to accomplish everything we need and not set up legs really ever again. So now that you have this pile and this pile, which is going to be a 4 to 6 inch pile or 3 to 6 inch, it's going to have to be steel, and it's going to have a pile cap welded on the top with a 3/8 bolt. Okay, so that one will be operating a GPS, which is going to control all your machine control on site. The other one's going to be your total station, which you're going to lay out your concrete, bolts, piling, and plumbing and everything sensitive with that. Most of the time, all you're going to need is like a can of spray paint maybe, and because all the earthworks, everything is going to be cut and graded with the machines. They are going to be going with no stakes. All your plumbing and the inside the building initially and piling cap, you're going to have the piles done. You're going to be able to do that all with precision with the machine, and you're going to be able to do all of the plumbing in that either with your RTK. If you want to set it up, it'll still run the machine control without interference. And there'll be some things like the piles themselves you can use RTK to stake them out with if you need to, whether you use paint, nails, or whatever happens to be the food of choice for the piling installer. It doesn't matter. You're going to have enough quality to give him the shots he needs, whether you're just walking in front of him or you're using a big stencil and painting where the pile goes, maybe a little less diameter of the pile so that you know if you see paint, you're out of tolerance. The other thing you can do is pin flags with a nail, but they still have to get that into the middle of the pile, and it's a little hard to do when you're trying to drill it maybe, and it travels on you a bit. So that's why I would go with like a paint and stencil. I haven't used the paint and stencil because if it snows or something, it's gone. So it all depends what time of year it is, where you are in your project. The best thing and the most common thing, guys, is just a small nail if it's gravel. Maybe a little larger if it's clay and you can get it in. But pin flag, and then I would say like a nail, maybe just a paint dot, but a pin flag definitely with the location, the name of the pile that they're giving you, which will be based on your drawings, so that they can correlate it when they go out to the field, whether they need a different size pile. They're going to probably have something called a pile schedule. It's going to have all the pile cap sizes, the pile sizes, and all this information about each station that has a label. So you're going to find out how to number those based on the drawings. And you're going to be able to set it up from one point, and you're only ever going to have to switch these two setups, your GPS and your total station, and you're just going to want to make sure they know what point they're on. So we have the best fit line. We're tying to 0 across of it. We've already incorporated if our minimum setback will move in a little bit. We've made sure it parallels the boundary, and then the building will parallel it. So, okay, so the first thing you can do is now you can turn to your control here and give it a label. And just based on looking at this, guys, I'm going to say here we're going to have a northing of about, if it's 30 deep on the lot, this is going to be somewhere around, let's just say for easy sake, it's going to be about 27, and then it's going to be about 10 or maybe 3 or 4, whatever it is, this minimum setback, but we'll just say like 4 meters to the east. So this would be like about 27 and 4, and then this would be about 27, and then we're gonna add say this is like a say 30 meters in here because we're at 10. So I know this is botchy math, but it's gonna be like at 27, and it's gonna be shorter than 40. So if we're using the same 4 meter thing, it's going to be about 36, so 27 and 36 or whatever. But they're never going to have balls positions like these, just like the drawings won't really. And the balls just means that it's right on the mark, guys. They're going to have just sporadic coordinates that you give them. Okay. So, we have our back site. We're now in our coordinate system. We've assumed 0, 0 is this coordinate. What can we do? Well, we're going to now turn this laser to this point, shoot it. It's going to give us a coordinate, and that coordinate is going to have northing, easting elevation. Because we're going to hold elevation, you guys, this, even though it's 0, 0, 0, you're just going to have an instrument height in here, and this will have a rod height, and it will know the differences in height and how long your rod is. Boom, you get an elevation for that. So if you want to put elevations on everything right away, you can. Just remember, you're going to have to adjust your layout to that elevation. Excuse me. And it is going to be based on data that is a little corrupted because it's based on design data that the engineer got, and it's going to be based off of designed property boundaries and underground that is not going to be handed over into anything but 2D. So anything you have to tie into, like sidewalks, etc., back alleys, asphalt, like I said, about maybe a right of way that goes to your property or a municipal reserve or anything like that, you're going to have to make sure you tie in some of that existing furniture so that when your machine is cutting along the sidewalk, it's not like digging out the sidewalk or like way above the sidewalk. You're going to want its digital terrain model to be just tying into that sidewalk so that if he has to, he can manually just stay off at about a half a foot all the way around. And then where you're going to have asphalt, he's going to be able to manually put dirt, like maybe right up to that, or sorry, maybe manually put dirt right up to where that swale is on the crossings of the sidewalk so that you can access the site until you get asphalt up to that point. Which can happen relatively quickly when you guys are using machine control. This is so powerful. So I'll just show you how I would do my layout. I've already decided the minimum setback and everything is going to be fine. I'll go with it. And you know what? If I get chewed out, I get chewed out, whatever. I've been chewed out before, as the saying goes. So now that I have a coordinate here and here, I'm going to just drop one here as a checkpoint. I want to set up on this point, and then I want to be able to verify the rest of the things I already know. So if I now set up on this point and I just backsighted this one that I set it up control off of, I should have 0 zeros. Okay. If I don't, guys, don't worry about it. It's not going to make a big deal. You're going to just try and find congruency between this one and this one, but you should have zeros here. And the other way you could figure it out, guys, is now that you've had 3 independent points set up and they're all congruent, if you're setting up here and you resection this point and this point, you should get a different coordinate than you got when you laid this one out. And in this situation, I could almost guarantee you with my whole paycheck, whatever it's going to be, whenever it's going to be, whether it's my disability check or a big consulting check, what you're going to notice that this coordinate that you got is not going to be very different from the one you shot it as before you set up on it. And all that is a check to make sure that your system is congruent and your instrument is accurate enough to do this. And so, guys, that brings up one more thing that a legal surveyor is going to do to waste your time, and I could prove it right now. And he's going to traverse these points in. So if you see his instrument where he turns it and shoots back to the same point by plunging the instrument, which means he turns it 180 and then he plunges it 180 so that it goes back 360 to the same point. He's trying to get the air out of his instrument. And we've already discussed that we have a 2-second gun that a sniper could use at cross distances and, you know, get 1,000-yard kill on an animal he's hunting. And that's going to be the same technology in your gun. So if it's 2 seconds, that means it's 2 seconds. It can hold horizontal angles for miles and miles. And it would be really hard to find the air if you weren't doing your setups and stuff properly, or if you were doing your setups and stuff properly. So the PPM atmospheric settings we've already discussed. After years of research and doing it myself, they are not useful, but you can recreate them with historical weather. So keep it generic. The other thing is don't traverse any points. And the reason why is because there's only 2 reasons why you'll traverse them. Remember earlier when I was talking about the history of instruments and all the instruments that I've used, and how that the majority of the time you will be using your eye to operate them. The thing that you have to remember about traversing is because you have a 2-second gun and it's using that electronic EDM, it already has a very tight angle between points. So when you do your layout and piles and everything, you want to do them all from the same setup, and you want to do them from an angle, or you want to be able to at least switch setups and check a few of them to make sure they're still jiving. With a 2-second gun, that means that you're going to only be laying out anything within this parameter to less than 2 seconds, according to the gun, because you're going to be at a distance that's really longer than the building. And it's not entirely longer than it if you incorporate the fact that you got this cross distance in here. But by the time you get outside of that radius, it's going to be able to still be within that 2 to 3 second area. And that's really going to be immeasurable as well, guys. So I'll give you some tips for how you do the high precision stuff. Just make sure you use a small mini prism, because if you use a larger 360, it would be okay and suitable. But if you use a smaller one-way prism, which means it only looks in one direction, and you swivel that, there's going to be some error in there. And I can guarantee you, in setting over 1,000 pile caps in my career, it's going to be measurable. And so you'll have pile caps that will look skewed. You want a mini, small 360-degree prism like that Leica makes. You could use it with almost any total station. All the constants will be in all of these total stations, and if they're not, you could program them in or enter them in. And just remember, they will be different for different machines, and you're gonna have to know what they are, because it is the distance from that your laser will have to compute to add or subtract from its measurement in order to get the accurate position. So in order to bypass that, we're just gonna go with the small mini prism. And when we have the small mini prism, it's going to give us the most accurate measurements, because we're going to imagine this building here was a big pile cap and we shot the middle of it. Well, first we're going to etch a line across it with a straight edge this way and that way, which means it's going to find the true center and the load point. And then when we take a center punch and snap the center of that pile cap, we will locate it to within 3 millimeters. Then you'll be able to go out to the outside of the pile cap without changing or doing any measurements, and all you're going to do is measure whatever half the distance of that pile cap is towards the center on this side and this side. So say it says 200 on this side and it says 201 on this side. Well, then you know you're turned clockwise 1 mil. You're pretty much fine. But if you have something on this side that it says like 197, and on here it says like you're 203 east, well, then you can already see you're 3 mils this way and 3 mils that way. You got to turn the cap. So you will turn it, like rotate it clockwise or counterclockwise, whichever way you have to go, and then just shoot back to the center as a check. And then the welder can tack it and you're on your way. And then at that point, I would just maybe check the side again. But you could as built it. It could be put into a cloud right away. And then it could punch out the paperwork for quality control, who's sitting at his desk doing nothing, talking to safety. Or maybe they're out bird dogging you. And then you got to send him to go get his paperwork to quality control this because it's ready to be welded or it's ready to have structure put on it. Everything you're going to want to do is going to be put into a cloud, guys, because when you are cutting this dirt with a machine, the machine will act as the survey instrument and it will as built that as it's going over it. I would recommend maybe not as builting it until you do it manually after it's been compacted to make sure that you are within tolerance. So that is why you're going to have a technician on site all the time. And that's how he's going to make some money. He's going to make you some money. Everybody's going to go home happy. So back to this layout and the precision stuff. If I set up on this point now and I resection between this point and this point, I should also be able to resection between this point and this point, which are my longest distances. And because I had a zero tolerance between them, or close to, because I adjusted the distance on this point by moving it in at this angle, because I know I was short on my lot. Once I resection that point and that point, that 2-point resection should have residuals less than 2x1 mils. And if they are getting much higher, guys, you might have set up wrong or done something wrong. I don't know. But if I set it up, I know I'd be getting 2x1 mils because this is an errorless distance. I shot it straight across and I assumed the angle. And the angle was the design angle. So I took the maximum design angle I could get, and then I put it on the maximum side of the lot so that my everything is to the max or to the closest angle I can orientate it to. However, to get the minimum offsets and setbacks, I would have to adjust these boundaries. Now, all that means is I'll be orientated if I use my error and add it to the survey on the minimum setback side. And seeing how I'm holding this side is 0, it'll accumulate on the other side and not on this side. So I just have to add it and then make sure I'm good. You guys can figure all that out. But the thing that you have to remember about resections is it's going to draw a line between this point and that point, and then it'll draw a line here. Okay, but using that computed distance based on the distances I actually shot to it, it'll triangulate my position. And don't give me the circle of death. You can set up on the circle of death and shoot one point and another point, and you might think you're over on this side because trust me, you have a better chance of getting struck by lightning 4 times in the afternoon while you're doing this than that having that happen, because it will always take the closest measurement and apply it to the distance to the point that you assign to it, and then the instrument knows what side it is on. And the reason why it does is because you're not doing the math by hand, and if you put it into AutoCAD and you do a simple distance line calculation in the same matter, it will know what side you're on based on the distance from this point and this point. And you're going to compare that coordinate to the one that you got when you set up. And you'll find that it is within mils. So you could keep the original coordinate because it was from the best possible setup that you had. And then you're going to be able to check any of the other pins and everything you want to do. And you want to get ready to set out this building. So now we'll just say, hey, we're here. We got no fill. Or we got our total station set up over here now. Okay, you got our total station set up over here now. We got our control network, which means these 3 points here all have control on them. It's based on our longest line. We've included our minimum setback. We're not on 0 property line. Our eaves or whatever are included. We're not a fire hazard. We're ready to lay out the building. Okay, now here's where it's going to get a little tricky. And there's 2 ways you could have done this, and I would have personally done it on the way to the job, maybe getting the building to jive with my design control or whatever. But because the design control is out, we can do it now. And it's going to just take maybe a little effort. We may have to, in this situation, just send the information back to the engineer, and then he could re-ascribe coordinates for all this. But you're not going to really have to, because we're going to just adjust it the way we did it in the industrial point. And then we could just adjust the numbers of our control. So how would that work? Well, it's going to take a little thinking in that, and we're going to have to get through it together. But now we're set up on this point. We've done a resection to that point and this point, and then we could even backsite to this, or sorry, foresight to this, or this, or this, and check it. Now, this is the only time we're ever going to use the pins, guys. For the rest of the survey, all we're going to use is going to be this pile, and this pile. And either we're going to have a total station set up on it or a GPS, which is the 2 pile method, which will be most common that I would use if I was going to do it. But it is good to have a 3rd pile as a check instead of checking to a pin and you don't know the position. But in any case, when you're set up on this position and you backsite and you get your first result, then you calculate it over, shorten the distance. You're going to want to shoot that pile and store it as a point in this pile and that pile. And we are not going to be doing traversing because, again, the instruments of the old school guys could not measure seconds and minutes as accurately as the modern instrument could. So that is why you had to plunge it so that you could get 2 readings on your, basically what I would call your dial or your azimuth plate or whatever you want to call it, whatever read your angles. And when you got those 2 readings, when you shot the same point twice by flipping the scope or plunging it, as we call it, and doing a traverse, you would find that those minutes and seconds, or seconds in some cases, or both, or whatever it happened to be on the instrument, would have a little bit of a difference because of the error of the instrument and your ability to read it with your eye. So what you would do is half the distance of that angle. So by calculating it and subtracting it and then having it, adding it to the lower number, whatever which way you do it, you just average the distance or the angle that is between those 2 angles. And that is how you get the error of your survey done. So for example, if you have a builder's level and you're laying out a hockey rink in your backyard and all you need is an angle that is close enough to eyesight, you could do the 90s and cross angles if you calculate them with just a simple builder's level, maybe even a digital one that has a plate on the bottom with degrees, and then you got good eyesight. It was going to be close enough for what you need to do. And chances are, if you use that same method to lay out piles and a lot of things, if you had an accurate chain and a good chainman and you knew your stuff, you'd be able to lay out fairly accurate. And that's why a lot of old survey data is so accurate, is because they use that method. However, if you are still traversing pins in your career, you do not know what you're doing anymore. And I would go to the field with you any day and take your check and prove it to you. And it is just a waste of time. It is like the double tying that we got rid of, and it is not needed, guys. The instruments are so accurate that you could really just put a ruler on top of any pen, shoot it reflectorless one time with like a 0.2 second reading, quick and dirty, and it would be good enough. If you happen to hit a guy wire or something like that, you're going to have to figure that out on your own, because that's just a matter of being a smart surveyor. But if you see big residuals in your numbers and you can't account for it, that means something has moved drastically or you shot it wrong. So before you go blaming other surveyors or the design or whatever, just make sure you had your setups good and tight and not standing over a long period of time to get this control in, because the more time passes, the more air you're going to have, especially if like the ground is melting and you're going to need snow over the legs or anything. I always personally don't like to set up on the pins. I would like to set up on concrete somewhere on a nail that maybe I drilled in. And then I just start right off the bat with resectioning this point and this point, because I already know setting up on it and then backsighting it, I'm going to get the exact same distance and error. The only difference is it's going to be harder to shift this point if I don't do it that way. And then it's harder to hold 0 on this point if I do a resection, because it's going to average the distance. It's going to average the position of these 2 points in a resection, so that you know basically 2.5 centimeters will only be your error on this side, but you don't know if it's more or less and on this side or that side. So that's why I start with the back sight first, because if you resection, and again, resection is the fancy way of localizing that we did with the GPS, but all it does is use the angle side angle method or side angle side method or whatever information you have to compute the best possible answer. So by doing this, we've already found out that setting up on here and resectioning the two original points that were errorless, our coordinate is virtually the same. So we're going to go with that. We're going to incorporate our addition to the minimum setback. And then we're going to only use 1, 2, 3 pieces of control ever for the whole duration of the project and ignore the pins completely and entirely. Although we will have shot them in, not traversing, but just to document them so that if anybody sets up on this again and wants to find them, they can get within a reasonable amount of distance between them and use a magnetic locator and find them. Okay, so we're set up here. And then we set up our GPS here, and we just have to make sure our GPS knows it's on that point. And that means it has to have all its digital terrain models and everything in the coordinate system jiving, meaning the drawings and design jiving to the machines that are going to be laying out. And there's 2 areas it's going to be doing that in. First of all, it's going to be doing in grading. So grading will be your subgrade, then your gravel or pit run or whatever you have on the bottom, and then your fine grade gravel or maybe just continuous gravel, whatever you decide to go with. And then on top of that, you're going to have asphalt at some time, and it's going to have to tie into critical points. And in the meantime, when you don't have asphalt, you're going to still have to be able to access the site and get around. You don't want stakes everywhere, because I've seen it, guys, and it's a mess, and it slows things down. It's going to cost you money, and you're going to have mistakes. And it's just so much better to stick this 66% faster with dual GPS. Okay, so first of all, right off the bat, once we set this GPS up, let's say we get a design trench, and it's going to be for the guy that's going to dig the, we're going to say the deep underground's all done, so our utilities are up close enough that we can get electrical, plumbing, and sewer, or anything else we need. But we're going to need some shallow underground, and that means we're going to need plumbing through this house. We might need an elevator shaft in the middle if it's an apartment. If it's a big commercial building, it might not have elevators or a shaft, but it might have the underground plumbing still. So anyways, that stuff will all be designed with inverts of pipe, etc., by the engineer. He may not design the trench. However, the trench itself, we are going to want to be designed. So the way we do that, if the trench is not designed, but we have the inverts of pipe or bottom of pipe or whatever it may be, we calculated out using the drawings, slopes, and bottom of pipe. So we can still dig to that, and we're going to be very close. If we have to add, like, say, 4 inches of sand under the pipe, so we're not digging right to grade, we're going to dig below, and then we're going to put a sand bed in. Maybe we're just going to put sand just under the pipe, use a fillcrete. Maybe there's going to be cathodic protection that has to go in the fillcrete on something that's maybe a steel pipe, or maybe the pilings get cathodic protection because they don't want them to rust out over years. That's basically what we'll do. But you'll notice that the trench itself won't be designed. So you're going to need an operator if the trench isn't designed and he wants to dig with a 3D system. We're going to put the piping in there. He's going to be able to see it on the screen and everything. Preferably, we'd put the trench, but he's just going to have to be able to dig the trench to safety code, whatever your HSC says for sloping, entry, and exit requirements. Who can be in it, who can't be. So a lot of this stuff, guys, your permitting and all that kind of stuff can be decided early on and through the process, because you're already getting into construction the day one when you set this up. And if you have the drawings and the files, all you're going to have to do is make them jive. So in order to do that, you're going to probably have an AutoCAD-like program. In our case, we might have like Micro Survey. And so what we're going to do is we're going to put all our DWG information into that drawing program. Unfortunately, I don't think it will come up on MS Paint, but if it does, it is a similar program. It would work, but we need 3-dimensional, and this isn't 3-dimensional, and we need it to be in a form that these machines can run off of, which has got to be the DWG or any type of DXF or whatever file it's running that just happens to be like a 3-dimensional calculated drawing that has smart lines, or what we would call smart lines for guys that do drawing in CAD. Maybe it has points at the beginning and ends, and the focal points, like for piling, top of caps or top of like slab if it's tying into concrete. And then for piping, all the relevant information, and it's all going to have to overlay each other in that program file. And it's going to have to be where it's going to have to make sure that the tie-in points for plumbing or whatever you have to tie that go into or through that concrete or under it, we're going to try and make sure we're not having to drill holes or too many holes or whatever the design requires through that grade beam, because it's going to compromise structure. And I've seen people have to do it after the fact, and it's not a great thing to have to fess up to because your drawings were that bad. So the one thing we're going to look for in our drawings that it will not mess up our project if we get it right. And we are going to check if the dimensions in our drawings match the DWG drawings. So we only want one set of data from the engineer, and that's going to be all the DWG where he is actually put in his manual or any of his fall safe kind of checks into making sure the DWG dimensions are exactly to design. And that means he used the design of the law and all that kind of stuff to come up with it. And so if that's a case, and we know that the any IFC drawings that are for visual pleasure that go to the client, they're going to have to match the dimensions on them generally will match design, but the actual scale of them will not, because they are often drawn for, like I said, the pleasure of the client's eye, because they want them to look good. So in that case, they're going to be using a drawing program, which in this case could be the same as the CAD program, but it's not going to have the same actual scalable measurements, even though they might be labeled differently. So number one thing, never use a scale off a drawing to determine a measurement that you're going to lay out with one of these pieces of equipment, because it will, in a lot of cases, differ from the actual calculated distance, which will be labeled, but the actual distance when you scale it will not be the same as that. So you're going to think, oh, I have all these problems right away. But what you don't know is the engineer knows it. He doesn't care because it's just a drawing that he could fit the dimensions in properly to, so it looked like a good product for his client. But you're not going to care about that because you want to know where it actually is and what it's saying. So you could use the numbers, but we're not going to recreate the entire thing. So we're going to just go to the engineer and say we need the DWG for center pile cap. So we need all those centers. Then we're going to need all the bottom of piping and underground that we need to excavate for and, tie in. And then you're going to need permission for a few other things, which I'll get to. But mainly we're going to get all the building and everything in it jiving together. The last thing in that secondary would be the curbing and parking lot. You're gonna have to meet certain requirements for that. So you're gonna do just a double check after you get the building and all the plumbing and electrical and all that kind of stuff jiving. You're gonna also be able to get this small machine with dual GNS tracking after he's been able to dig the piping for plumbing. He'll also be able to head over for electricians and dig anywhere across the parking lot that seems reasonable, I guess, or on back of parking to install your plugs and outlets for plug-in parking. So once that's all done, guys, those two phases, which could be done in the first several days, as in the underground for the building and maybe even piling, but they won't be too much in the way for the parking lot and whatnot, because you're going to grade that all separately and then get the asphalt going. Because my goal, guys, people, is to have this done in half the time you normally do. And when I say done in half the time I normally do, I mean all the civil and all the slab in an early works contract turned over, so you can get payment as a contract earlier on without having to wait for the completion of the project. Meaning you can certify all your early works and sign off on it with any level of quality control to the point where you can receive payment. Because even if they built a house on it out of spaghetti, or an apartment out of spaghetti, and it failed every code that there was, you could still establish the work you did in early works was done properly and good, and you can go from there. So now that you got some of your underground done with that one small backhoe that's able to do that, he's going to put some sand under it, maybe use the Philcrete, whatever. You get it done in a few days. And now you got people waiting around to maybe tie rebar to put in your piles because you're doing concrete piles. So you're throwing rebar in there. Maybe you're doing drill in piles, which are kind of the way I would go for a lot of things. Excuse me. However, in bigger applications, that's when you need them. In smaller applications, you can go concrete with rebar. It depends. I've seen both. I would always recommend a helical pile. Why? Because it gets installed to a torque, and that is not just a load value. So it is definitely harder in my mind to move than just concrete you poured into a dirt hole. However, in a lot of cases, that still would suffice with the reinforced concrete. So it all depends what your engineer goes with. I don't really particularly care. It's his own but if it doesn't work, I have to just make sure the dimensions and locations are proper and documentable so that I cover my butt. Because all the engineering is going to be based on loads and loads, tensions, whatever it is you have to deal with in making a structure, and they're going to be based on distances applied to a specific material. And if your distances are wrong or narrow or short in any way, that means it's going to be it'll be overloaded, or it'll be under capable of handling the load, or however you want to word it. And in most cases, things are over engineered, so you would be fine. But you can't play that game, and you got to be able to stick to spec, guys. And spec for concrete is going to be, even in industrial, we're talking 10 millimeters, your corners in any direction, on the inside or outside at the most. Anchor bolts and pile caps, we're talking 3 millimeters in any direction at the most, and they're going to have to be congruent to each other. So you could tape check them if you want. That will be helpful, just in case something happened with your instrument or whatever. But because we're at these solid locations that no one ever installs on a commercial project, we know we're going to be fine, and you're not going to have to set up legs day after day. You're not going to have to wait for survey. You're not going to have to do any of that. It's already day 1 or 2, and we're already cutting, and we're already getting ready to finish our subgrade within days and bring in gravel. So some of the tips and tricks I can show you for wanting to do this best is, once you set up here or here, and you need to get the coordinate system for all your information jiving to basically your 0 point or whatever coordinate system you're on, you're going to be able to do that after you get it all into your drawing program, and you make sure it's all overlaying each other and you have no conflicts. So that's a simple plan check. It's not going to be, it might be based on drawing dimensions, but it won't be based on scale drawings, and it's going to have to come from the DWG. You guys, if you get a DWG drawing that is based on the visual presentation of the drawings, and it has different measurements than they actually are, and you use that for your layout and setup, or whatever, I can tell you're going to have major discrepancies, and you're probably going to get fired, and no one's ever going to want to use you again. And I've seen it happen in situations where it cost oil field clients in the oil sands tens of millions of dollars, if not more, because one guy couldn't do his job and check the plans properly. So even like a site like that I know of still to this day, anytime that firewater could freeze, it's going to be a safety hazard for someone because somebody didn't have the proper elevations above it or the proper protection for frost. And definitely when you're hauling very heavy mods across narrow gravel, frost-bitten roads, that frost is going to push down. And so for safety's sake, I'd love to mention it, but I can't do it here in any case. But what I can tell you guys is it will be a bad taste in everybody's mouth if your drawings, are the glorified drawing of your calculations. Number one thing you got to remember about AutoCAD, it is a calculation program. So you are applying loads, tensions, whatever your engineering data is to a distance, and you are ascribing a material that has to be able to be capable of holding that load or tension or whatever it is at those distances. And if your distances are wrong, then all your calculations are wrong. There's nothing to lay out. You're going to right off the bat sue the engineer because he does not have any of his shit in place and you're ready to build and he's not. It's one thing that the fact that he's already going to have a coordinate system that is not going to jive with yours, but you can deal with that because you're the surveyor and you're the tech and you're going to make it jive. You've already got your error in the minimum setback, everything. You're ready to go. So let's just say, for instance, this corner of the building right here is where the engineer started drawing his whole project. So that means he looked at the minimum design and everything and he said, yeah, well, we're going to have to be off minimum setback this way, but I'm calling my drawing 0, 0 here. So everything he's drawn is all at 0, 0, 0, 0. So you already know in your mind that if he took that 0, 0, okay, which your coordinate system is operating on, and it started laying out any earthworks or anything like that, that means it would put the corner to the building where your 0, 0 is because you've already ascribed 0, 0 as that coordinate. And that's not going to work for anything you're going to do. And the reason why is obvious, because you're going to be over the minimum setback. All of your grading is going to happen in the street and you're going to have dirt all over the place. None of the back of your lot's going to get produced. And everything is going to be out the distance of whatever 0, 0 is from here to here in a shift and rotate. Okay. So that one's pretty straightforward. So you see how we're going to now have to label all the coordinates in this drawing to match ours. But because you're in AutoCAD, which is a calculation program, and all you have in here is 2D and 3D information so far, and you want to be able to match it all up, you're going to have to find a few things. And first, you're going to need permission for them because it's going to change the drawings a little bit, but it won't be very much structurally. And if you are a land surveyor and an engineer in geomatics, you typically have the ability to change swells on sloping and grading and things like that will be involved in your drainage plan, even though you might not be designing or altering structure. And so that's what we're going to do. So for the first part, we already know we're going to have to tie into the sidewalk going all around, maybe the first few sides of our lot. So we go around, and our property lines here, there might be a sidewalk out here that'll typically be outside the pins as it was developed. And we're just going to tie in that sidewalk every 5 to 10 meters using our total station. And what that means, guys, is we're going to have a really accurate picture of where it is, so that when we start projecting that data to our machines, which cuts at a lower, I was going to say currency, but I know it's a lower spec, meaning like lower quality, it's going to still have a very finite position on where it's tying into. So you'd almost not be able to see it. And all you got to do is just stay like your foot or so off the concrete or whatever. And you could tie it in with a rake later, but it'll be so easy because you got close to it because you tied it in and put it into the design for all your end of swells for the grading on the lot. Now, I've seen a surveyor show up to his site and maybe he goes and shoots in all the sidewalk and everything, and he finds out that it's all out compared to design, and he'll just send his engineer, leave it on his lap, and you're waiting days, and he's like, what the fuck? I don't know what I need, what I don't. And guys, the surveyor will just cost you a lot of money. So you want to go in this process that I use, because I like to be an independent survey guy, do as much as I can for other people and as much as I can of my own job, and not let other people do it for me. Because if it messes up, then I'm not going to have a lot of excuses and I'm going to be embarrassed. So I have to make this 0, 0 on this building. Okay. It's going to have to end up, being a coordinate, and we already know what that coordinate's going to be if I just turn this grid on. Okay, so I'll go view grid lines. Okay, that'll help a little bit, but I'm not going to be able to calculate it by scaling or anything like that. So what I can do is find out where that corner is either physically going to go, and then from my setup I can shoot it. All right, and then I could find the distance and angle from my 0, 0, and then I can just shift everything, okay, so that instead of being over here, I'm going to move it over here. So you already know in your mind that's going to be at umpteen of an angle at so far of a distance, and that'll serve as a good check if you get it right. That way might not work as good, but it's going to be a little bit better than shooting the pins, which were in design position, which he may have calced off. But we're going to say he didn't do that at all. But say you do have the design from the lot lines and that in your drawings and stuff, which you should. You would be able to also align your pins based on coordinates that you give them in your system to the ones in design, okay? And we already know, because we know all the pins aren't going to be that way, that that's not going to work. So we already checked our minimum setback. We know we're able to go. What we can do, guys, is, and one way we could do it in the CAD program is just simply shift and rotate all the data according to our coordinate system the way we want, based on a residual we get from an actual corner we shoot, like the location, and some sort of design data or whatever it may be. So I'm going to have to walk you through this process. I have been talking a while. I am supposed to finish this book this morning, and I promise I will. We are into the 7 or 8 hours. It's the shortest book I've ever read. It's been fun. It's good. We're almost done doing machine control, which means I've already walked you through all my tricks that I've got. There is a few maybe you haven't got, but that's okay. I do got to keep some of my cards as close to my chest. But in essence, if you have this total station set up, okay, you have your coordinate system already all the same, or sorry, already congruent on site. It is jiving. So if you set up on any of these 3 piles, in backside or foresight, any of them, you're going to be within 3 mils or less. And that's kind of my guarantee if you use the system the way I told you to employ it. Now that you're set up here, you just got to take your 0, 0, because your building is over here and you got to get it to where you want to be. So how do you do that? Well, just leave it at 0, 0. You can match it 0, 0. Maybe it's way out. It doesn't matter. What you're going to do is go with your manager, property manager, whoever he is. What you can do is maybe put some lath along this minimum setback to where you know it is. And then just pick the physical point of one corner of the building and just put a nail in there that everybody agrees on is going to be the corner, and it's going to be orientated to the design lot that you already have. So in that case, you might put in 2 corners. How do you do that? It's going to be a little bit harder, but look, you just put 1 corner in, you have the distance over to here, and you need it to correlate. So just shoot it and then get that coordinate, whatever it is, because whatever the distance is from your 0, 0 or wherever your drawing is sitting, it's going to have to move that distance to there at that angle from its design that it has in space. And it's going to sit there and it's going to be at that orientation. And the orientation is going to be basically the same as whatever's on the design, because it'll probably be designed in orientation to the lot at the very least. And if it's not, there's ways you could check that by just measuring some of the dimensions around the building off the lot line, and just make sure that you take a couple minutes in placing your building, guys, because you only get to place it once, because you're going to have cribbers and everybody working on it for days. And if you have to rework all that stuff, then a whole bunch of French guys are going to have your head and they are going to cut it off. And it's because they're going to be doing all kinds of rework and you wouldn't believe it. And they're going to sue you and you're not going to make it. So I could just tell you, if you want to be able to do this survey and not have anybody pee on your shoes, so to speak, you're going to want to make sure you pick these corners of the building right. Now, you don't have to pick 4 corners and then average it and then shift and rotate, because you want one clear, concise shift and rotate. You already know that you have no scale factors in your GPS or in your total station setup. So all you got to do is be able to pick one corner, and you already know it's going to be orientated to the job. And if it's not, well, that's just a matter of rotating it at an angle that you might pick with the second point that is also off of a minimum setback or whatever that you can physically measure with the instrument, because you have all the pins tied in. But in most cases, in all scenarios, guys, where the building is designed to go does have a little bit of float space. And what's going to determine that is how close your parking is to the property lines and any curbing, okay? If you just have lawn around the entire thing and all you have to do is tie in grass to grass, you can move your building a little bit as long as you don't move it too far from proper drainage, and it doesn't have to be redesigned or if that too much. The main thing you want to get is sloping in your draining that's going to go into the sewer, and that you would be able to get fairly easy with just a few calculations. I'll let you figure all that out because this is going pretty long, but all you got to do is be able to pick one or two corners of your building, and as long as you have the right distance on them, you could basically shift and rotate all the points in your AutoCAD program according to that shift and rotate. And how you do that, guys, is a pretty easy step, but I'm gonna say that you were smart enough to hire a drafter that was trained in doing this, and he's gonna know all these steps and understand them, especially if he's in surveying, and he's gonna be able to tell you gotta select all the points, okay? And you probably want to copy them so that you don't lose their congruency, because it is basically all the dimensions that you got from the engineer that you know are right, not fantasy ones, not ones that look good on a drawing or you can scale. They got to be digital, and they got to be able to go through your base station. They have to be able to work with your base station and your machines to make sure everything is cut proper. So you've already tied in the elements that you have to tie into. So you already know that that is where your sidewalk really is. So if you looked at, for example, the sidewalk on your drawing, you wouldn't really want to shift and rotate all your drawing to the sidewalk because you don't know what the dimensions will be from that sidewalk to the building, because you don't know what the pins actually are, which are what govern the property line. So because we've already figured all that information out, we've made sure we're on the minimum setback. All we got to do to all of our information is shift and rotate it to wherever it sits in space to where we want it to be in real time and at that angle. And we're just going to shoot those two nails, whatever they are, the farthest corner in the building and the farthest corner of the building, which you could very well do. And I would be fine with that. That's probably actually how I would do it. It just, all that matters is that once you do shift and rotate, you obviously mark out the other corners and the offsets that they require or want or anything, but you'll all be able to do that anytime, anywhere with either two of these machines, never setting up legs. Again, if it isn't straightforward to you enough, I'll explain it a little more. But you shift and rotate all the points in your drawing according to the horizontal location you want them in. Now there's going to be one more shift you do, and it's going to be a vertical shift, and you could do it in the first step. If you already knew your vertical shift, you're going to have to find out, guys, where the top of that building comes in, and where it comes in is going to be wherever your top of concrete is, minus to where you fill topsoil and grass, and then all the other cross sections below it. But we'll start with like the grass, where it ties in, and then where that grass ties into the sidewalk, and then everything else is be subtracted down from there. So whether you got to take in earthwork or move it up, it has to tie into the existing construction, and it's going to have to tie into your building. So at that point, if you know already, okay, maybe you did use a UAV to calculate all the dirt and whatnot, chances are you're not going to want to bring dirt in. Most cases, you're going to want to like skim the original ground if it has lots of grass and foliage, a growth on it, grass, etc. You're probably going to be stripping it, maybe storing it and bringing it back. Who knows? In an industrial section, it's in an industrial sector, you would do that. You would strip and bring back in the topsoil, especially if it was very fertile soil, like up in like a muskeg region or something like that. You would have to do reclamation. So it's going to be stored, bringing it back. It might be the same for other types of soils, and that typically it's just the original ground. But once you get down to clay, guys, or whatever it is, you're going to have to decide with whoever's there where that elevation goes and to which sidewalk or to which parking that fits best. So say your sidewalks are all high, but the swales and the tie into the road is actually really close to design. I would probably stick with that, seeing as how walking on a sidewalk a little bit higher or lower is not going to make a difference. But you're going to need to watch that you have a good drainage plan from the building to the sidewalk. And by that meaning your as-built points that you've already shot in your new coordinate system. So there is a way to just take all the information in your instrument in your AutoCAD program, shift it and rotate it to the sidewalk, etc. But I would always use a physical point and angle on the building because that's the most important thing to place. The other thing you want to know about parking, if you move your building too far and it starts cutting off maybe a lane of parking, that might not be too bad if, say, your parking's going in a certain direction and you only lose part or one parking stall. You might get approved for that from the engineer right away, and he'll say, go with it. However, if you have parking going down an entire line and your building moves into it and you have no way to get to that parking, or it's too short for the average vehicle, you're going to have a very big fucking problem and you're not going to like it. And I'm sorry for swearing, but this is 8 hours and I am ready to get done because I was up late yesterday and I've been up late all night getting this done today. And I've described it in as thorough and with as primitive drawings that I can, most and all of my secrets. And guys, all you need to know about this, shifting this control into your control system, is get the elevation so you're sloping down to sewer and to and your swales are sloping to whatever manholes you have installed. So that'll involve like just a measurement from top of asphalt down. Usually at a minimum, you're going to have one on 3 to 5 inches of asphalt, typically like a 4-inch lift. Then your gravel under that's going to be about 6 inches or more of gravel, maybe 6 to 8. And then your subgrade itself will be like the stripped original ground. So if you have to bring in soil to get your subgrade up, then you might not have picked the best place for your building, or you had no choice based on the existing infrastructure you had to tie into. So in that case, it'll involve our first back charge, which will be to the developer of the person that built the subdivision or developed it. And you may or may not have to do this, but depending if his soil is very low and limited compared to the volume that you have to fill underneath either your buildings or parking or anything like that, and is drastically different from design quantities, you could have a reason to maybe back charge the original developer in engineering, and the fact that it was maybe harder to get to utilities or drainage without having to redesign your building too much or bring in or remove soil. So those two factors and redesign shouldn't be a big deal, because the only thing they're going to redesign in the apartment is either they shorten or lengthen the downspout that is on your drainage, and that will basically make it tie into the manholes and road. In most cases, these slopes are going to be a lot lower. Just pay attention to drainage, because you're not going to have pressurized sewer. I can guarantee you that. If you get the sewer right, and then you get permission to change the angle of swale from the building to the existing, but hold the design elevation as best fit, that's the only thing you're really gonna have to change. As far as the layout of parking lots, location of curbs, location of building, all that, none of that will change. It's just a little bit of a vertical offset on the tie points, basically on the concrete and on the way you do the driveway, etc. Okay, now guys, if this was me and I was able to shift and rotate all my data because I picked a real life point, and then I shifted and rotated all my data to that coordinate, I can now give all of my grading data with the new swales design to the machine control day 1, day 2, whatever it is I'm on, and he can start grading and cutting and compacting. And what that means, guys, is he can grade and can compact an area that I want to have asphalt on it. And for me, guys, that is going to be the whole parking lot. I don't want to see anybody staging material on my project until it is on asphalt. And the reason why is because then I got to move it again, and then I got to do the asphalt and the gravel and the grading under it. And it's going to be muddy, and I don't want mud everywhere, because when everybody's walking in the mud, it's going to slow them down. And so unless you want rig mats everywhere, which I would recommend at some point in the project if you are staying on mud, because everybody's going to be slopping and complaining, and you don't want that. And maybe the rig mats are free the time of year you use them, as I've seen in some places, but you're going to have to remove them. You're going to have to haul them, and it's not going to be fun. So the other thing, once everything is jiving, now you got like maybe one cat doing all the grading for your whole commercial site within a day or two or whatever it takes, because it's all going to be automated. All the digging can be done for whatever's needed for electrical outlets and plumbing in and out of the building. Piling, you could decide what order you're doing in it depending on whether you use piling, what types of piling you're using, whether you do the footing and grade beam first. Well, obviously you're going to want to do the piles before that, but just the way you do the footing, maybe you have a crossing point or you leave out a section that's at the end of the building so that you can access it because you want to get the grade beam going. All of this you guys can decide, but I would just to give you a quick trick for how I would do the pad and all the grading. I would make sure that I could get all the asphalt and all the grading done in the season that I'm working in. Why? Because once it starts to become frosty and wintering, it is harder to do those things, and you already have everything you need on site to do it. So this GPS is going to be able to do everything up or down within a few centimeters, and that's going to give you grade, and then that you will be able to check with a rover that works off the same GPS by walking around. That's this thing, maybe without the bipod, and you're just going to check quantities or quality of how close you are and as built. So even though his machine will as built in real time, once it's compacted, it's going to be a little bit different. So you're going to want a technician just to go and check and paint those areas. But you're not going to have a technician with the power of a conventional surveyor you might have on that's going to say, hey, I want you to cut out compacted gravel that's 2 centimeters high when it's within your tolerances. Because I have seen it done, and it costs a lot of money, and it has really, really affected clients. So what you're going to want to do is just have that guy. He is quality control for the surveyor. He's the survey technician. He's running the GPS. He can also as built with his total station if he wants tighter numbers, but the GPS will be accurate enough to what is being cut with. If you find that you stuck with design and you did not adjust your vertical offsets to account for compaction, that's still okay. All that means is you just might have to compact twice. So you just push more material over it like you normally would, compact it again, and you're going to be close to that vertical offset. So, but let's just say you did the grading on the subgrade and it was a little low, but then you added in and you didn't worry about it because you're bringing a shit ton of gravel and it doesn't matter to you if it's a bucket more or not. And so you just left the subgrading a little low. You went with a little more gravel. And then the gravel was a little bit low too, right? Now, in any situation, if somebody drills a core hole and drills through your asphalt and your gravel and your subgrade to find out where all your clay and topsoil or whatever it is that you had under there and find out where it is, they're going to be able to see that your cross section still meets the minimum engineering depth of the gravel and the asphalt. Subgrade doesn't have to have a minimum depth. It just has to meet compaction or close to spec, just because of the nature of the fact that it's already there, and you just want to keep it where you can get like a compaction or a properly graded level. The most important thing is you get the compaction and you get the cross section on your gravel, and then your asphalt and or pit run gravel, whatever else you might be using in any of those sequences. With that being said, you're going to be able to also, once you get to the top of gravel, say you cut it a little bit low again after, or you say you cut it to the vertical cross section or the elevation you want it at with sloping and everything, but then you come along and compact it and you notice again it is a little bit lower. So then at the gravel point, that's when I would add in a little bit more material, cut it to the same elevation, and then just pack it maybe one more time. You should be very close to where you need to be. If not, the guy with the rover going around is going to tell you, hey, if everything looks low, we got to add something to everything. If everything's a little bit high, a little bit low in some places, or very close to, then you're probably right on where you need to be, and nobody's going to be the wiser. And you know in your mind, ethically, you'll have met the engineer's requirements and provability. So a little trick there that I would use is I would definitely cut the subgrade to whatever its design element is, and that's going to be based off of points that you calculate down from this furniture you got to tie into, and then where the building and stuff has to tie into, including because of the plumbing and all that. And once you get that to jive, you can start cutting the subgrade and even pushing up that soil under the building where it has to be, and then cutting just a basic subgrade that you would know where it has to be for that. In simple terms, I've already described how you just have to have the drainage plan working in all cases. And most of the time, the stuff you tie into neighboring properties is going to be either a curb, grass, or just something simple like a fence. So just make sure that you remember the building can move a little bit in all situations. You're going to make sure it's beyond minimum setback, and you're going to calculate that out using the longest line, holding 0 to the closest side, and then you're gonna foresight all your piles. Then you're gonna set up on one. You're gonna check that longest line, check your coordinate. You're gonna make sure everything's jiving. If you've never done this before, or even I haven't, and I've done these types of things, but this is the system that I would use that would work the best if I had to get into this industry again today. And I probably won't be again because of my handicap, guys. So I'm just starting off with my first audiobook, and it's to spill all my secrets about surveying. So the last and definitely not least is the RPR that we had to order. So I don't really care what you do for it. You can just call the surveyor and say, hey, come do an RPR. And it might take him 9 hours to find all the evidence that you found in a matter of minutes, because he might be down the block tying in a pin to a GPS that's set up somewhere totally different. So to help them out, I would give them the location of these piles because they're not going to move. If you want, once you are done the concrete, shoot the corners of concrete, give him the location of foundation. All he has to do is come with a tape, measure out each corner just to find out what the actual dimensions of the building is. Add anything he needs to do that is concrete or stuff, or otherwise. This is where British Columbia is a lot better. All they care about is the area of the foundation pre-pour, and then you get a certificate to pour. And when you do pour, you may be called back for an as-built, but in most cases, it's just the pre-pour that matters the most, and that certifies your processes off the minimum setback. In Alberta, you need a lot more furniture and things to put on an RPR, so it takes longer. The surveyor tends to make less money. So if you do help him out in this way, it could help him find all the pins and get his best fit. And then also, if you explain the process of how you added your air into the minimum setback, even if he sets on these pins in any fashion and discovers they're in any turmoil, one, you could determine by setting up on your control that, hey, that pin is moved from the original position. Here's a picture of it. And then you have it in your AutoCAD kind of attached to your pin coordinate, which you're never really going to use or tie into because we've already got our control jiving for minimum setback. I know there's kind of one thing I'm kind of forgetting in here, but yeah, basically the RPR is going to be the last thing, and you can hand them some information. I already went over everything tying into or shifting everything to your physical coordinate of your longest length of building. So you would only just have to calculate that out, guys, and then pick one corner and then just ascribe another corner to it. You would be able to figure out how to do it just by looking at list drawing alone. You would already know that the azimuth would have to be greater than this one. There's all kinds of ways you could check it. All I can say is you won't need much more than grade 8 math. In my case, I didn't in a lot of cases. And when I've used more than that, it was just to calculate tricky things that I had to know, like bearings, etc. If you guys get going in that fashion and you get everybody cutting the subgrade and they're moving along, you have the underground done. What I would do for the asphalting is also use the straight mast prism or whatever type of reflective device they would have for your asphalt grading. And I would also do that manually too, even though a 4-inch to 6-inch lift or whatever it happens to be for asphalt it tends to be pretty easy to put in, especially if you have manholes that already are down 4 inches at gravel. Everybody knows you're just going to fill to the manhole, so there's no point in using the machine control. So in a lot of times, up to the gravel is good enough for machine control. But if you want to go the next step and use your robotic total station to do the asphalt or the majority of it, you would be able to use the total station. The GPS I wouldn't recommend in that situation, but it could maybe work. I don't know. I haven't tried it in applications that I've seen. You typically have the asphalt being done by machine control because it has to be more accurate. All the other subgrades though could be done with the GPS cutting. I feel like there's one thing. Oh, yeah, I was going to teach you how to tie in your access points. So your access point is going to be filled with gravel, typically to get you in and on site, or our subsoil, which will change rapidly with water or weather. Okay, guys, so the access points. Sorry, I just had to take a little break there. The access points, the way I would do them is you already know that you're going to have gravel coming up off the subgrade. So even if you fill up gravel at your access points right away so they don't turn into slop or sludge, because typically they're going to be a little bit lower than your sidewalk, just in nature by the way the lot was developed and the sidewalks were on top of it, whether they strung line or used a GPS machine to even do your sidewalks and curbing. Usually it's going to be like a string line that they're going to follow, and it's going to be up on the top of your original grade or whatever grade they had. So you'll find that a lot of time you're going to have pooling of water and stuff on your site to begin with that you're going to want to get rid of right away. So at the access points and for whatever road you're going to use for bringing in material in and out, you could have gravel pretty much on the subgrade right away as soon as you cut just a path that you knew was at subgrade in your parking lot area and around manholes and stuff. So the reason why I say that is because you're as soon as you're ready to do asphalt, obviously all you're going to do is edge out the gravel at your access points so that it is low enough to catch your asphalt. So an important thing that to remember is usually that when there's some sort of swale or lower type concrete base at the access points on the site, you remember that if you just cut it out, say 4 inches, because that's your asphalt lift below your sidewalks all around, you're going to be out because if your swales are lower than that, which they will be because they're access and entry and access points, then you're going to want to shoot those into as tie-in points for your asphalt and curbing specifically, so that when you cut them out by machine, whether you're sloping back or wherever you have to go with it to get it to design, because you're not going to change the majority of your design data, only just certain swales that tie into the perimeter. And if it happens to be all of it, then it does, but you're going to still try and stay as close to that design so you manage the engineer's parking lot and everything to the point that it could operate and drain water and all that in the same fashion, obviously, that he's designed it in. As a surveyor technician, anytime you get through any steps with the engineer's information and it is not jiving or making sense, that is going to be on him. So you're going to need to make an RFI or just do a request for information or just talk to some supervisor, depending on what facet of construction you're in. For industrial construction, it would typically be a RFI, which is request for information, and then you're going to wait for a response. So I would want to have an engineer that you could get on the phone anytime and ask him some of the questions you're going to need to know. But just remember to get the coordinate system jiving. Pick a physical place for the outside of foundation, and you should be fine if you just shift and rotate. All of the data you will lay out to your coordinate system. Do not shift your coordinates and the data. Keep those separately. Don't ever shift or rotate them. There are surveyors out there that will shift and rotate them all the time for best fit and whatnot, but then they are completely useless when you show up the next day, because every survey is really kind of a crypto in the sense that you cannot replicate it exactly at any given day. And so that's why we incorporated that extra 3 inches in my minimum setback, because guys, I like to go with that, because in case you have some bad surveyor come along, and a lot of them really can be good, but just say you have somebody that measures off a pin that's out and they decide to proportion your lot differently. at least I've never really seen it happen more than that 3 inches, like just error between somebody else's survey and my own or somebody else's. And in most cases it would be less, so you're going to be fine if you add that error of your lot coming in to your side that is on the minimum setback, and then just kind of roll with it in that way. The other thing you're going to want to remember is water control right off the bat. You're going to start trenching on day one. So if it is downpouring or whatever, you know how it's going to be a sloppy mess. It's going to be hard to pack sand if you want to pack sand. But either way, whatever your piping is, you just have to calculate your bottom of ditch using the slopes and inverts of pipe that the plumber will use to get it done, even if you don't design the ditch. But basic rule of thumb is if the piping is like narrower than the bucket, you only really need to go bucket wide, whatever it is. So just call the design in the DXF or the DWG, whatever you're using that's running in the machine that has 3D cutting control. Just make sure it's like bucket width, and then it has at least like a 1-to-1 slope on it, depending on the depth. If it's like real deep underground, you're going to probably need a little bit of a sidewall, and then at least 1-to-1 going to the top. You're going to need different access and regress in that. So hopefully you can stay out of that as much as you can. You always want to have safety on site, and a lot of times we know this doesn't happen. You're going to want to have somebody in quality control, because if you guys can roll through these processes in all the first 2 days, you'll have seen what I've never seen, even working locally in my own town of Red Deer, and that is being able to get the civil on the go and the underground rolling and to completion within several days to several weeks for the asphalt, and have a slab ready to put something on it. And this will change the face of construction if you use these methods. And how do I know? Because I've already sat down and calculated how much money you rich people that have the money to employ this can make, and you guys that don't have money, I already have made or could make quite a bit of money just doing it myself. But I just think that the industry is so far behind. It was time for me to just give all the secrets I could out. Obviously, all these methods would be different in each situation, but the most important thing is if you put your error in the minimum setback sides of your lot and make sure it is parallel to your boundary lines, wherever the existing pins are, your building will have to go in a new position, and it most likely will be a little bit skewed from design because your actual pins are going to be a little bit different. So what that means is you might have to add a little bit more on each side depending on where your pins are angled to. I did try and cover that the best I could, but I am just repeating a lot at this point, and that's because maybe you don't want to have to go and find it, because I didn't label maybe my current subject as good as I said I was going to do at like the beginning of this video. That is okay, guys. Water control on your site, like I said, if you're going to be doing some trenching and that, you are going to want a few laborers. And to everybody that tries to use this system with a contractor or an employer, I'm going to tell you everything you want to know right away. If you are working for an employer and they want to invest in this equipment, all they're going to need is the total station or robotic, and you're going to want it to be robotic because we are done using our eye to measure. This thing has a tracking light on it that will find your prism with automatic tracking to the mill. It will be better than your eye can do it because it is using the pathway of light to the prism and then relating it to its own EDM information. And guys, it is as good as you can see or better. So you're going to want robotic. Then you can work doing your layout and that with just one man, and then he can switch back and forth from GPS. If you need a guy on GPS just as-builting stuff, maybe you could teach him how to hold a rod straight up, and then he can just as-built and grade and do quality control that way while you do layout on the building. The only other thing you're going to need besides your robotic total station if you're a contractor is the base and the receiver, which I've already told you guys you could do with 2 really high quality cell phones. You're probably going to want a spare 2 in case one's broken. I don't know how you're going to power it, and maybe you're going to just have continuous power source to it from from a vehicle or something, or maybe like a large deep cycle battery. Do not use the small batteries for your base setup. Use a large deep cycle one, because then it'll last years and years. Small lawnmower and other batteries that are like it, they might be convenient for size guys, but they're not made to be broken down and charged again frequently. As you can see if you've been through a lot of them and you do the same thing. Okay, so I'm gonna wrap this video up in the next couple minutes. The audiobook is done. I hope you guys enjoyed it. I went through all kinds of fantasy situations that I would be able to use any of this in. You would also be able to use this process in our warlike scenario. The only thing is guys, a lot of the stuff that we'd be using for buildings in our warlike scenario, the chances are the Amazonians in the jungle just wouldn't give a shit if we were 2 centimeters off a zero setback line, because they got better things to worry about, like where they're going to find their food. So most of these could be just done with a 3, 4, 5 triangle. You're going to set up a tent or whatever kind of structure. If you find limestone and you make them concrete in a bigger, because you have bigger facilities, great. I just did what I would do for bare bones and technology if I was going to do it myself. So in this, so for this last situation, this is to adhere to really strict legal practices and construction practices, and it would work. The other thing that you're gonna need to note. Oh, and that note is going to be that, yeah, in the Amazon forest, you would be able to lay out a building with a tape and your watch pointing at the sun and finding true north or south based on half the distance between your hour hand and your 12 o'clock hand. So with that and a chain and some string line, most of the buildings you'd want to be able to build could be done with that, and really could be done in our country too, with just like measuring off from the pins that are closest to our minimum setback and just adding a distance. And really it would work, guys. But you know, we just don't like doing efficient things anymore, especially when people get nitpicky. In my experience as a legal surveyor in the Okanagan area and then in around Alberta, the people that tend to make the biggest deal over property disputes are those people that have money and they don't have the time to just get along with their neighbors. So if you really want to be a surveyor, I recommend maybe being a technician in the machine control field, because you're going to get better money. You're going to help your clients make a lot more money. I recommend, if you have a client that is doing this and selling and renting out your supercar technology and how to run it, and they have went and paid the supercar prices for this machinery, you're going to want to let them bill you out for probably $180 to $200. And I'm talking Canadian, but it could be American too, in a similar environment, maybe a little less or more, depending on the price of a legal surveyor. But the price of a legal surveyor in central Alberta, where I live, is anywhere from like 120 to 180 an hour. And it usually is around the 160 an hour. And that's what it takes for them to make money at surveying, because of the incumbent processes they have, and do it without having to pay too much labor. But they do own a lot of equipment that is expensive, and they deserve to make some money. And remember, they have been paying for supercar prices, but it's not my fault if they can't fall under an engineer, give the client what he needs, and not continually give him reasons for why they haven't done what they needed to do, which can happen a lot, and it's costing you money. So if you work for a contractor that's willing to invest in the robotic tow station and an RTK based setup, either with cell phones that are high quality, that can be mounted to some sort of cradle or GPS system that fits to a 3/8 bolt, fits on a rod, whether it's male or female, however you buy and set up your deal, you would be able to probably bill yourself out for about $180 to $200, or maybe $220 even Canadian an hour. Now in the Fort McMurray region and up, for a technician, that's going to be quite a bit more, and I would expect you to take it, because you're going to be a lot further away from home, and you're going to have a whole other set of challenges that are going to maybe pertain a lot to more of our war scenario. And that's going to be probably the drug testing and I can tell you from experience, guys, The drug testing in Alberta and in anywhere in North America or the world has completely ruined the industry that you're in. And here's why. If you smoke marijuana 2 weeks ago on your vacation and you come back and you're the better, more qualified worker, and somebody was just on a crack bender for days and they happen to clean up a few days before their drug test, they will get the job and you will get sent home. And therefore, you can look yourself in the mirror, all you health and safety people, and you can just hold yourself responsible for the crack and cocaine and amphetamine culture that's been created in Fort McMurray or any remote place that they do like the fracking and oil field stuff. And it's because you abuse and don't care about your workers, and that's fine, but it doesn't work for me. So I'm not in the field anymore. As I said, I'm retired and I could give a shit less. But for all of my boys that are out there working hard and doing it, and they kind of get themselves up against a wall, I'll give you a little tip of advice. You can get a medical marijuana card, and if any employer or client does not want to accept that card, I will be the first person to go to court with you, and I will help you arbitrate anything you have to do to get that card recognized. And in most cases they already do, and you won't need me. But the other part of that is true, and I can't do anything, like I said, in our wartime scenario to legitimize you using any type of cocaine or crack, other than the fact that you want to clean up quicker for a piss test. So there is a little bit of a design flaw in that. However, I can't get around that part. But as for the amphetamines, if you are getting into surveying and you find that you're becoming tired and lethargic in your thinking and it is hard to stay awake and you have lots of problems with that, then I would recommend an amphetamine that your doctor could give you, which would be like a dextroamphetamine or Adderall or something similar that works for you. And the reason why is because, guys, at the peaks of these projects, you're going to be working 12 to 14-hour days. And then when all of a sudden they don't need you anymore and you're sitting around, you're going to have to find a way to look busy. So I recommend jumping on a crew with anybody. And if they're willing to pay your rate still because of how good you've done, then that's great. I've had it work for me where I've got a journeyman rate for another trade, which might have been less than my contract survey rate, but they kept me on until the surveying was available again. You could work deals out like that. I recommend that if you have a contractor that gets this equipment, you don't pay him any less than $45 an hour. And here's why. Because if you're the person doing it and you've done the system, I'm telling you, you deserve at least $45 an hour for someone that's going to bill you out for $180 to $220 an hour. And not only that, if you can do it well, they're obviously going to keep you around and maybe get you under some sort of contract. And that's going to be good for long term. If you can afford the equipment and do it yourself, however, you are going to make even more than the 200 or whatever an hour, because you're now working at 66% efficiency, better than your previous results on average, and that is documented. Maybe not on average, the average might be lower, but because that is really high, I'm going to say, guys, you can get it done in half the time at probably half the existing price. No matter where you are in your project, all you got to do is install 2 or 3 piles and you could get going. They just have to be intervisible and be able to be seen throughout the project. So keep them in a good line of sight. Maybe put some stakes and lath around them with a lot of flagging and call them the fired zone. If you're in there, you're fired, because nobody's willing to vouch for you for the reason why you're behind that lath and flagging. And if you are, you could be tampering with either the equipment or the piling. The piling probably won't move unless you like bump it with machinery. But if that happens, guys, and you do bump machinery or equipment at any time, let anybody know that they can approach you and let you know about bumping your legs if you had them set up or anything like that. And the reason why is because it only takes a few seconds to check a back sight. And whenever you do layout, make sure you always turn to where you back sighted to start it and close. Now, if you only have 2 piles, that means you're going to have a back sight that you set up on one, and then you have your instrument on the other. So you're going to have to back sight, use that back sight. And by use it, I mean you're going to have to take it down, but your instrument will remember where it was. And you could do your layout and that all you want. And then if the machines have coffee, you can just pull it off and close your back sight and check it, and then just start up the base again by just putting it back on. Just make sure machines aren't cutting it while you either have it off and running or you just have it shut down and then booted up again. If you're using like a hemisphere product that has a base station, it only takes from shut off to being in phase fix solution like 38 seconds, I believe, from startup to stop, or from startup to phase fix solution. That's probably the best in the industry, and they are made locally. You can buy them in Calgary. Or at least I think they're made locally. I don't know if it's local anymore or was, but they sell them locally in Calgary. You could contact me about that information if you were interested in helping me, if you were interested in getting a surveyor and you want me to train them. So all I'm saying though is, if you use this as a backsite, you could leave it set up and maybe use this third point as your base station. All I got to say, guys, is wherever you use your base station, make sure it knows the point it's on. I recommend writing on one of these piles the temporary benchmark that it is. So you can put TBM and then 1, 2, or 3. And then you always know when you're setting up on that point, that's what you're at, and you're either backsiting the one or the other. The other thing is, if you guys maybe have a contractor that gets all this equipment and they want to change their bidding system so that they know that they can make a lot of money even though they're becoming more efficient, and they don't want to be starting to get outbid by competition. The good news is already so many people are not using this technology that you could get so much further ahead with bidding. Why? Because let's say you get a project done in half the time you normally did. One, your client is going to be to first market, meaning like he's going to be able to rent out or sell units first before any of his competition, because he was able to get it done faster. So you might want to consider talking with a builder that's going to say, hey, we've already done prefab construction, and that no matter how fast we throw up walls and everything, it's a civil that always takes our money out of the project because it's not done. It's always over budget and it's in the wrong order. So even if we went module and had it up in 13 to 26 days or whatever it takes to land an apartment with a few cranes or one crane, it won't matter because it takes so long on the civil. Now they can say, hey guys, let's go module. We could have our projects done, whether it's in a difficult environment like Alberta or like it, in a matter of weeks to a few months at the most, using modular and this civil and slab layout method. Now, if they're doing that, guys, you might want to actually get an even better raise, because they're going to be able to charge what their competition charges. And if they just say we're going to come in at 90 cents on the dollar, they'll probably get the bid. If the client comes in and sees you're using machine control and you need to be like, hey, we're moving faster and that's the way it's going to be, and he says, look, you guys charge me too much because you're going way faster, so you're going to be out of here. All you got to do, if you want to not cover it up, but make it look a little more legit, first of all, they can't charge you for being better than your competition. You're allowed to charge them for being better than your competition. So if anything, I would go for a premium, but then you might not get the bid. But because you know you're going to go faster, I'd come in at 99.5 on the dollar. And here's why. Because you're going to be done so much faster, you're going to be able to pocket a lot of that profit. And it is going to be in your early works contract, your civil and slab development. So that way you can get paid out before the contract is complete if everything's to spec and is up to date. If they go modular and put modular on this, then that means you're going to be even getting paid quicker if they decide to wait till project end. So that is going to be even better for you still. But here is the real big kicker, guys, for you guys that want to invest in supercar technology for your machines, and I mean supercar price like technology, and you got the money to spend for your machines, and you can handle this loadout for your projects. And that is you're going to make so much more money per machine. So even if you applied the rate to be generous of just 60% efficiency to your current unit rate on that machine, that would be fair to say is acceptable for your client. And the reason why is because you've paid supercar prices for getting the instrumentation that goes on those machines. And so you're going to have to charge pretty much a third or more. In this case, basically 2/3 more of what your normal value for that machine is. So if you have a large dozer that is now cutting machine control, and you know you could get it to grade faster because you've handled all the digital terrain model issues, layout, boundaries, etc., you're going to be able to get in there, hammer that job off, and get out. And what that means is now your typical machine is going to be worth in profit, really, if that same dozer was, say, $100 to $150 an hour, and now it's worth in the area of 200 or more. They would be able to compare that to their competitors' prices, and then you would be able to say, yeah, but does yours do this? I have a supercar on it. So that is a way you could look at it. And if you do it that way, I could tell you by programming extensive amounts of estimating software for machine control and the labor involved, in most cases, you would be able to man up your site so you had more labor than you typically could, so that you could manage even more controls and get done faster by just having the things that you don't need a person to do anymore, like staking, grading, and all that kind of stuff. Just be dedicated to a laborious work, like whether it's putting sand under piping, paying attention to safety details, cleaning up the site, making it look good. In this case, guys, you really won't need to put up temporary fencing around your project, because you're going to have a civil and slab literally within the first month of breaking ground, even in Alberta, in a typical commercial or industrial environment around this size, or the size that I would typically see like in the city, and it would be even less in residential. Make sure before you put in your piles that they are in a zone that won't be affected by either utility right-of-ways or any encroachment onto neighboring property. And they're pretty much the extremity of your buildings wherever you put them, and they're visible up until the slab construction before and after. You could use these to also set the modulars, but all you're really going to be doing is checking maybe for a slight position error, because they will be based on all your measurements for the slab. So if there's an error up there, it was yours down there, and it's still yours. So those are some things to think about. But if you could do civil and slab very quick at this much more efficiency, I could tell you the ratios for manpower to automated machinery are very, very large when it comes to your profit. So, for example, if you're working maybe in the Fort McMurray region, and a typical bill out for an average tradesman in past years, and may not be the same today, it might have changed to get volume, and a lot of places have knocked numbers down, but let's just say it was $80 to $90, and you had to pay that journeyman or apprentice, whoever he was, in the neighborhood of $40 to $50. You're only really taking a $30 to $40 profit, and you got to carry WCB on that person. You got to carry all kinds of other things that person might be interested in, right? If you let somebody else just handle the labor, and then you subcontract all of it, and then but you allow them to hire as much labor as you want at a generous rate, like a generous wage, you'll realize that he's not really making a lot of money on the labor by the time he manages and babysits and goes through all the headaches of managing it. So your machines, however, are going to be making 3, 4 to 5 times more amount of profit as one person would be, but they also would be incredibly more efficient than the competition. So you could not only outbid the competition, but you could almost match the price. So you're getting the same money that would take them double to get. And they will not be able to compete with you until they can do this same system, or at least something similar to it with machine control. So they either be out of business, not getting contracts, or they'll just keep putting in bids that'll make you a lot more money. Eventually, when the competition ceases to exist and everybody's on the same page in years to follow, you would be having much more similar bidding, whether that's high or low. I don't know. It's really going to, at that point, it's really going to all come back to engineering, guys. And that's going to be how well you are able to design your house with what kind of materials, or your apartment or commercial space, and how long you're going to make it last. And you're not going to be able to free up the money to do that for your project or your engineer unless you can get your shit done quicker in the manner you said you probably could when you started your project, and you still haven't. And that's why I'm here, or you're here listening to me. So this is the end of the audiobook. I think I've shared as much as I can. I got chicken scratch up here that I could barely read anymore, but I understand how to set up machine control for any of the projects I need to. If you have any questions or you need consulting, you can always get a hold of me. And the way you'll get a hold of me, guys, is I don't know. I just want to see how you do. But I work for Pinpoint Survey Solutions. I'm at 44 Kensington Road, Red Deer, Alberta, in Kensington Close in Red Deer, Alberta. And that is where me and my brother operate Pinpoint Survey Solutions Ltd. We're consulting based only. If you need field work or training, we can do that. We do got a pretty nice diesel pickup truck. It's all right. We got a shop to work out. We do have a Bobcat and a dump truck typically available in the central region. Our father contracts. However, my brother does work full time pretty much in Fort McMurray and shift work, so it would have to be the right deal to get him on. But I could pretty much train anyone as I'm retired because of my illness. So I will not do a lot of field work. It won't be much longer than a few days, and you will pay a pretty dollar for it. So make sure you're ready and willing. But it's not going to be like $50,000 for 3 days, but it will literally be several $1,000s in that time. And I promise you'll have a surveyor that would be able to do all this and more for you if you haven't already learned to do it yourself watching this video. So again, guys, I'm going to check the time to see the total time of my audiobook, and we are just shy of 9 hours, which is good because I've read a lot of books, or a few of them, and usually they do take in the neighborhood of that time. And when you're talking about a subject that spans across all industries, it is definitely hard to cover everything. So without further ado, I am going to let you guys go. If there's anything I haven't covered or you need to ask me of, you would be able to get a hold of me on my LinkedIn. It is Jeffrey Burton. I am on LinkedIn. If you need to see a picture of me, it'll be the same one that is on my email, which is jeffrey.burton.101@gmail.com. And is a picture of me surveying on a large industrial site in northern Alberta. I'm just standing behind some legs, and it almost looks like I'm ready to draw guns, and I'm looking behind an instrument. Anyways, that way you know that it's me. I have that on several different pages, including my Facebook, and you're welcome to be my friend at any time, especially if you just want to ask me questions about surveying. I'd be happy to answer them of no charge. If you loved this presentation and audiobook and you want to make a donation, I will refer you to my code for PayPal one more time. It is at the beginning of this video. You could easily fast forward to the beginning and check it out. And the reason why that's a better idea is because if I open other files to get it out, then you'll see more personal information, which I've tried to limit in this video. Excuse me. So it is only a $10 donation to PayPal. If you have to pay for a lot of diapers and wipes to an out-of-province baby mama and she has a little newborn, this comes in handy, in which case I do. Shout out to my daughters, Melody and Kaylee. If you get a chance to check this out, no, I haven't seen you for a while, so at least you know what your dad's been up to. I will be seeing you soon. As for the little one, I will also be seeing you too, but I got to send you diapers and wipes. So I'm going to need those $10 donations. Am I going to make it without it, guys? Yeah, obviously I am. I will be fine. But given all the information I give you and what you could do with it to make a lot of money, hopefully you just contribute to the cause and go from there. With that being said, guys, this is the end of the video. I am now going to stop because I am tired of talking about surveying, and I don't really want to talk about it for the rest of my life because I've done too much of it and I am just really done with it. So I'm going to stop recording. I'm going to publish this. If you check it out or you don't, that's up to you. But please get a hold of me if you really are serious and you could stick to your commitments when it comes to getting your projects done and getting the survey right. Until the next time, if there is a next time, which I hope there won't be, may you have a really good time on your project. Take it easy. Goodbye.